Hello everyone. In this video session, I am going to explain part 171 of Java for tester series, that is method overriding. What is method overriding? So method overriding is nothing but, just understand this guys, when a method in the child class has the same name as the method in its parent class. So in child class there is a method guys, and in parent class also there is another method. So both this method in the child class has the same name as a method in the parent class. That means this both two methods are like duplicate methods, you can say, right? There are parent and child classes. The situation is something like this guys. Okay, there are two classes. Okay, there are two classes. Let's name this class as class A. Okay, and this class as class B. Now I want to make this class A as a parent of this class B. That means class B is going to become the child class of class A. How to do? We have to say extends, then say class A. Okay. So here now class A is nothing but the parent class, right? After extending the class B with the class A becomes the parent class of the class B, and class B will become the child class of the class A. In this kind of situation where parent and child classes are there, okay, let's say there is a method in parent class. Let's call this method as some x. Okay, that's some method known as method x in the parent class. And the same method, if you have, okay, with the same name, if you have some method in the child class also, okay, in such kind of cases guys, okay, in such kind of cases, the method in the child class, okay, this method in the child class, which is a duplicate method of the method in the parent class, is said to override the method in the parent class. Okay, just understand this concept guys. When a method in the child class has the same name as a method in the parent class, like this, okay, in such kind of cases, the method in the child class is said to override the method in the parent class. This method is said to override the method in the parent class. Okay, and so this concept is known as method overloading guys. So now let's get back to the what exactly is method overriding. So what is method overriding guys? When a method in the child class is same as the method in the parent class, in such kind of situations, the method in the child class is said to override the method in the parent class. Okay, this concept is known as method overriding. Okay, this concept is known as method overriding guys. Okay, method overriding. Fine. So why this method is overriding this method? How this method is overriding this method? How the method in the child class is said to override this method in the parent class? Let me explain. Okay, let me explain the concept for that. What happens when a method in the child class overrides the method in the parent class? Okay, when a method in the child class is overriding the method in the parent class. So how exactly it's overriding? So what exactly is meant by overriding? Okay, let me explain. That is nothing but when you create an object for the child class. Let's say you are creating some object for the child class guys, that is class B, some B object, okay, is equal to new class B. Here guys, you have created an object for the child class, and using this object reference of this child class, okay, here class B is a child class of class A, right? I'm just creating an object for the child class, and using the object reference of this child class, if I call this method x, okay, if I call this method x, I'm just calling the method x using the object reference of the child class. Which method will be called? Okay, here class B is extending class A. That means this method x is also part of class B, right? Inheritance guys. Class B is inheriting the method's properties of the class A. Class B is inheriting the properties of the class A. That is, variables and methods of the class A will be inherited into class B. But here the situation is different guys. Okay, even though class B is inheriting the properties of the class A, there is one method known as method x, which is already there in class B. So what will Java will consider when you create an object for this child class and try to access this try to access this method X? Will the method overload with will the inherited method will be called from parent class, or will the child class method will be called? Which method will be called? You are getting my point, right? This class B is inheriting class A. That means this class B is the child class of class A. That means all the properties of the class A belongs to class B. They will be inherited into the class B, guys. So this method X of class A will be inherited into class B. In such kind of situation, guys, there are going to be two methods. Duplicate methods will be there, right? Method X from the parent class will be there in the class B, and also method X of the child class will also be there. So there are two possibilities. Will Java, when you create an object for the child class in such kind of situations, and using that object reference of the child class, if you try to access the method X, whether inherited method X will be called or whether the method X of the child class will be called, which one will be chosen, guys? Here, guys, the answer is the child class method will be child class method, okay, will be accessed. This method X will invoke, this method X will invoke this one, okay, that is child class method will be considered. Okay, it will this inherited method which is having the same name will not be considered. Okay, this inherited method will not be considered. Only even though they have the same name, the method which is inside the class child class will be considered, guys. That's why we say that the method in the child class is overriding the method in the parent class. Okay, when you create an object for the child class and try to access this method X which is there in both class that is parent class and child class, okay, as child class method is overriding the method in the same method in the parent class. That's why as it is overriding, when you call using this object reference of the child class, which method will be called? Child class method will be called, and this concept is known as method overriding. Okay, here child class method is overriding the method in the parent class, and this concept is known as method overriding. Fine. So let me practically demonstrate this, guys. Okay, let me practically demonstrate how this is happening and all. Okay, so I'm going to demonstrate the method overriding concept now. Okay, so this is the Java project, guys. Under the Java project, I'm creating a new class. Let's name this class as class A. Okay, I'm just naming this class as class A and click on finish. Inside the class A, I'll create a method, guys. Okay, inside the class A that I just now created, I will create a method that is public void. I'm naming the method as method X. Okay, some method X. That's fine. So system.out.println inside the method X of class A. Okay, I'm just writing something like this. Now I'll create another class that is let's say class B and finish. Just drag it to the side so that you can see both the classes, class A and class B at the same time inside Eclipse ID. Now inside this, I will say public void method. Here also same method, guys, method X. Okay, here also method X. System.out.println inside the method X of class B. Okay, here inside method X of class A. Okay, here inside method X of class B. And I'm going to make this class B as a child class of this class A. That is, class A is going to become the parent of class B. How to do that? Class B extends class A. So in such kind of situations, guys, the properties of the parent class will be inherited by the class B. So this method X will come here. Okay, inside the class B it will come. Method X will be inherited here. And at same time, child class also has the same method. Here method X is there, here also method X. So one is inherited method from the parent class, another one is its own child class method. In such kind of situations, guys, the method which is there, okay, having the same name as the method in the parent class is said to override. Okay, this method is going to override the inherited method from the parent class. Okay, so why we are saying that this particular method is overriding this method? Because when you create an object for the child class, okay, let me show you. When I create some demo class and I'll add some main method so that I can execute the code. Okay, let's drag it to some side, this side, guys. So let's say, okay, and here if I write some code like this, okay, I'm just writing some code that I'm creating an object for the child class. So objects should be created inside the methods only, guys. Okay, so I'm just creating inside the main method, I'm creating an object for the child class, that is class B. Class B, okay, B object is equal to, okay, new class B. I'm just creating an object for the child class, that is class B. Now using this object reference, B object, I am trying to call this method X. So here, when I try to call using the object reference of the child class, if I try to call the method X, which method will be called? Inside class B, there are two possibilities of this method X, right? One is inherited method from the parent class. Since class B is the child class of the class A, method X will be inherited into the class B. Okay, method X is also part of class B. So will that inherited method will be considered when you say B object dot method X, or will the method of the child class itself will be considered? So the answer is, since this method in the child class, which is a duplicate method of the method in the parent class, is said to override. Okay, this child class method is said to override the method in the parent class. So when you say B object dot method X is overridden, okay, this overridden method, okay, method will be called. Okay, instead of the inherited method, instead of this inherited method from the parent class into the class B, the overridden method, which is overriding this current method, will be called. Okay. So let's see that whether that is really happening. Okay. When I run this demo.java, if it prints, if in the output we get the result as inside the method X of class B, that means whatever I said is true. The overridden method will be considered. And this concept is known as method overriding. Okay, let's run this. Rightly run as Java application. Observe that, observe guys, the result is inside the method X of class B. Okay, inside the method X of class B will be printed. Okay, so this proves that, okay, that overridden method will be called when you create an object for the child class and access the same method, which is duplicate method of the parent class. Then which method is considered? Child class method will be considered because it is a overridden method of the parent class. This concept is known as method overriding, guys. So what if I have the duplicate methods? Okay, public void method X, public void method X. Okay, we have duplicate method in the child class. That's fine. What if I simply add some parameter here? Okay, what will happen this time? Which result you will get? Okay, this is no more an overridden method, guys. Okay, once I change some parameter, okay, here there is no parameter, here is one parameter. That means these two methods are not duplicate methods now. Okay, the method in child class is not a duplicate of the method in the parent class, because the method in the parent class has no parameters, whereas the method in the child class has some parameters. That means the method in the child class is different from the method in the parent class now. So in such kind of situations, if I create an object for the child class and using the child class object reference, if I try to access this method X, which method will be called? This method or this method? Inherited method from the parent class or the specific method to the class B? So what will happen in such kind of situation is, this method, which is not having any parameters, will be inherited into the class B, right? Will be inherited by the class B from the parent class. And now along with that, we also have some method X, which is having some parameter. Now class B is having two methods, guys. Method X without any parameter, which is got inherited from the parent class. Other one is having one parameter, which is part of the child class. In such kind of situations, if you call this method X, which doesn't have any parameters, which method will be called? Here, guys, this will call the inherited. Okay, method, because inherited method is matching. This specific method of the class B is not matching, right? It has parameter. I am calling without parameter, right? So without parameter means which method will be called? The method of the parent class will be called. So let's see whether that is happening. Okay, the inherited method from the parent class should be called. So right click run as Java application. You see inside the method of class A, that is inherited method. Okay, inside the method of class A, that is inherited method got called using the object reference of the child class. Okay. So something like this, guys. Okay, something like this. So and this method is known as, is this method still overriding the method in the parent class? No, guys, because this is not the duplicate method of the parent class. So what can we call this kind of thing? Now, guys, this method is said to overload. Okay, it's not overriding, guys. It's overloading. Okay, overloading method, you can say method overload. This concept is known as method overloading. Okay. At the parent and child level, this concept is known as method overloading, because this is a duplicate method for sure. But okay, these two methods have the same name, but they are not duplicate. They are not duplicate because this has zero parameters. This has single parameter. That means this method is overloading this method. It's not overriding, guys. It's overloading now. Okay. You can have multiple methods having the same name across parent and child classes until and unless you have different parameters. And such kind of concept is known as method overloading, guys. If both have the same name and same kind of parameters, in such kind of cases, this child class is said to override. But if they are different, then this child method having the same name as the parent class is said to overload. Okay. When they are differentiated using the parameter types and all, okay, this method is said to overload. Otherwise, if both are same, having zero parameters, such kind of situation with the same name, then overriding, otherwise overloading. Okay. So, so I explained you what will happen when the method in the child class is overriding the method in the parent class, and also at the same time I explained you what will happen when I have the method which is overloading the method in the parent class. Okay. In such kind of cases, which method will be called? This method. Otherwise, this method. Okay. So guys, this is how the things work in Java case. Okay. This concept is known as overriding. Okay. When the child class method, which is having the same name and is a duplicate method of the parent class, in such kind of situations, if you create an object for the child class and try to access that method, which method will be called? Overridden method will be called from the child class. Okay. Instead of inherited method from the parent class. That concept is known as method overriding. Okay. So this is all about the method overriding, guys. In the next video session, I'll explain using this keyword with methods. Okay. How to use this keyword with methods, I'll explain as part of the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 172 of Java for Tester series. That is using this keyword for differentiating the instance variables of a class from local variables of methods. Okay. In this video session, I am going to explain one of the advantage of using this keyword in Java, where what does this keyword will do? It will differentiate the instance variables of a class from the local variables of the methods when both of them have the same name. Okay, same names. So when the instance variables of the class and local variables of the methods have the same name, in that kind of situation, Java will not be able to understand what is an instance, which one is an instance variable and which one is a local variable, right? For example, inside a class, let's say assume that this is a class, guys. Okay, let's say this is a class. Okay, what are instance variables? 1 minute. Let's assume that this is a class. The variables which are directly created under the class are instance variables, right? Let's say there are some instance variables like string, car, model. Okay, there is an instance variable known as a string, car, model. And similarly, there is a method. Okay, let's say there is a method inside this class like this, and there's another method, another variable with the car model, same car model. Okay, same string, same car model like this. So here, what is an instance variable? A variable which is directly created under the class is nothing but an instance. This is an instance variable, guys. Okay, this is an instance variable. So what is the local variable? This is the local variable which is inside the method. This is a method, right? So this inner box is a method, let's say, and inside the method there is a variable having the same name as the variable that is directly created under the class. Okay, this is an instance variable, whereas this is a local variable. Okay, this one is instance variable which is directly under the class, and this is a local variable which is inside the method. Okay, now guys, if you are trying to, if you have same, okay, if you have same instance variable in as local variable inside the method, okay, how to differentiate them? They both have the same name. Instance variable here has the same name, and local variable inside the method also has the same name. In such kind of cases, how to tell Java that this is an instance variable and this is a local variable? For that, we have to use something known as this keyword. Okay, the purpose of this keyword is to differentiate the instance variables of the class having the same name with the local variables of the methods having the same name. Okay, Let me practically show you guys how you can use this keyword for differentiating such kind of things. Okay. So let's create in this Java project. Let's create a new class. I'm naming this class as car class. Click on finish. Inside this car class, I'll create the instance variables. Okay. I'm directly creating the variables inside the class. Okay. So I'm just creating some instance variable. Only one variable I will create for now. That is string. Let's say car model. Okay. So now I'll create a method, guys. Okay. In this car class, inside this car class, I'm creating a method public void set details, some set details. I'm just creating some sample method set details. You can give any name, guys. Okay, to this method. You can give any name to this method. That's fine, up to you. Okay, I'm just giving set details. Now here, I'm creating a local variable inside this method, guys. That is as parameter, I'm creating string car model. So here, this local variable of this method, okay, this local variable of this method set details. The name of this local variable is car model, which is of type string. And here instance variable is there. Okay, the name is also same. That is the local variable name and instance variable name, both are car model, which are same, guys, and they're of same string type, right? This is local variable. So in such kind of situations, okay, in such kind of situations, if I assign, okay, if I want to assign this local variable to this instance variable, okay, I want to assign the value stored in this local variable to the instance variable. So what I have to do, guys? So I will copy this car model. Okay, I'm just treating that this is an instance variable and copying this is equal to, I will say, this car model. Okay, this local variable I'm copying and pasting here. Copy and pasting here and put a semicolon. So I'm just believing that I'm assigning the local variable, this local variable to this instance variable. But that is not happening really. Okay, Java is treating both these things as a local variable only. Okay, the left side is also a local variable and right side is also a local variable. Java is not able to differentiate what is a instance variable and what is a local variable, because this instance variable and this local variable both have the same name. So Java is kind of literally confused. So when you double click on this instance variable here, car model, do you see anything is getting highlighted here? Any of this left side and right side variable is highlighting here in this operation? No, right? But when I double click on this local variable car model, you see both are there. Both of this left side and right side are getting highlighted. That means both of these are local variables only. Here in this statement, what I am doing is I am assigning the local variable to a local variable. I just thought like I am assigning the local variable to the instance variable, but this is not happening, guys. When I double click here, you see both of them are the local variables. Am I assigning the same local variable to the same local variable? Here, when I double click on instance, you see nothing is getting highlighted. So how to tell Java that this is an instance variable, not a local variable, and this is a local variable? How to tell Java that this is an instance variable? How to differentiate the instance variable from the local variable? In such kind of situations, guys, you have to use this dot. Okay, if you say this dot car model, okay, you are specifically telling Java that this is a instance variable. Okay, you see when you double click here, this car model is getting highlighted. Okay, or double click here, this instance variable is getting highlighted. Now you are able to tell Java that this is not a local variable, this is an instance variable. Now double click on this, only one is getting highlighted. Okay, local variable only left side, right side one is getting highlighted. If you double click on this instance variable, you see the variable which is having this keyword is getting highlighted. That means using this keyword, I am able to differentiate the instance variable from the local variable. So this is the purpose, guys. Okay. So using this keyword, we can differentiate the instance variables of a class from the local variables of the methods. Okay. The variable having the same names as the local variable names. When you add this keyword to that, that will become the instance variable name. Okay. Instance variable. Fine, guys. This is how we have to use this keyword for differentiating the instance variable names having the same name as the local variable names of methods. Okay, so that's it, guys. In the next video session, I'll explain another use of this keyword in Java. Okay, that is using this keyword for invoking the current class methods. Okay, we can also use this keyword. This keyword is not only used for differentiating the instance variables of a class from the local variables of the methods, but also this keyword can be used for invoking the current class methods. Okay, I'll show you how to practically use this keyword for invoking the current class methods in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 173 of Java for tester series, that is using this keyword for invoking current class methods. So this keyword in Java can be used for different things. Okay. So in this video session, I am going to explain how to use this keyword for invoking the current class methods. Let's say there is a class. Okay. Let's say there is a class. Inside this class, there are different methods like this. Let's say there are like few methods, 1 or 2 or 3 methods. Okay. Inside this class, there may be some different methods like this one. Okay, let's take this one, method 2, method 3, like that. Okay, there are different methods. So I can call or invoke the current class methods. For example, if your control is there in the method 1, okay, if your control is, let's say this is method X, okay, this is method Y, and let's say this is method Z. Like that, there are 3 methods, let's say. Okay, and when your control comes to this method, and when you are inside this method, what I will do is I will use this keyword, this dot, I can call method Y. Okay, like this. I can use this keyword for invoking the current class methods. Okay, so even method Y is also in the same class, so I can use this dot method Y to call this method Y, which is there in the same class as the method X. Okay, so this keyword can be used for invoking the current class methods. So let me practically demonstrate this, guys, so that it will be more clear for you. So let's create a new class. Right click, new class. I will name the class as some class A. Finish. I'll create few methods as I mentioned. Public void the method X. Public void method X. System.out.println. I'll print when this method is invoked. I'll print this one. Okay, inside method X. Then I'll create few more methods, guys. That is, I'll copy paste. Instead of creating again, I'll simply copy paste. Here, this is method Y, and let's say this is method Z. Inside method Y, if this method is invoked, it will print method Y. If this method is invoked, it will print method Z. So when this method X is called from outside, okay, this statement will be printed. Then what I want to do is I want to say this dot. I want to invoke the current class methods. Other than method X, what are the current class methods? Method Y and method Z. I want to invoke any of this method X or method Y or method Z from this method X. So for that, I can use this keyword, this dot. If I say method Y, okay, so the current class method will be invoked. Okay, when this method X is getting executed, this will be printed. Then the other method, that is method Y, will be called from the method X. Okay, this keyword here is used for invoking the current class methods because all these methods are inside the same class. Okay, now after going to method Y, I want to give this dot method Z. I want to invoke method Z like this. Okay, I can use this keyword in Java for invoking the current class methods. Even method Z is also part of the same class, so I can use it. Now, how to see whether this thing is working or not? Let me show you. Save it. Let's create a new class. I'll call this class as demo class and select this main method. So inside this main method, I will create an object for this class A, guys. I will create an object for the class A and try to invoke this method X. Okay, class A object is equal to new class A like this. Okay, then I will say A object dot method X. Okay, I'm just calling this method X. So when I run this demo.java, what will happen, guys? So the control will go to the main method and the execution will start from the main method. So the first statement, that is object, will be created for this class A, and using that object reference, we are calling this method X. So method X will be called. When the method X is called, the statement inside method X will be printed in the output, then followed by this dot method Y. So this will call this keyword will call the current class method, that is method Y will be called. Method Y will be called. Okay. So when method Y is called using this keyword, okay, so inside method Y will be printed. Then again you are using this keyword for calling the current class method, that is method Z. Okay, method Z. So inside method Z will be finally printed. Let's run this. Right click, run as Java application, and observe that same thing will happen. First method X got called with this object reference. Then using this dot method y, the method y got invoked using this keyword, and then this dot method z. So method z in the current class will be invoked. That is inside method z will be printed. Like this, guys. These three statements got printed. So this is how, guys, we can use this keyword for invoking the current class methods. Okay. If you want to invoke the current class methods, we can use this keyword for invoking the current class methods. So that's it, guys. In the next video session, I'll explain another advantage or another use of this keyword for returning the, we can use this keyword for returning the current class instance. Okay. We can also use this keyword for returning the current class instance, which I am going to explain as part of the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 174 of Java for tester series. That is using this keyword for returning the current class instance. So this keyword in Java can be used for different things. Okay. For different purposes, we can use this keyword. And in this current video session, I'm going to explain how to use this keyword for returning the instance. Okay. Instance means object. Okay. Object of the current class. You can also, using this keyword, you can also return the instance or object of the current class. So let me practically show you guys how you can use this keyword for returning the instance that is object of the current class. So let's switch to the practical mode where I'll create a class, right click new class. I'll name this class as class A. You can name it anything, guys. Click on finish. Inside this class, let's create some instance variables. Say int A, comma, int A, and then int B. Okay, just declare two instance variables here. Now, in order to initialize this two instance variables, I'm going to create a constructor. So the name of the constructor should be named as the class name. So public class name, and it looks like the method. So public class name. This is a constructor, guys. Okay. So in this constructor, I will initialize these values. Okay. I'll initialize the instance variables like this. 3, 6. When an object is created for this class, automatically this constructor will be called and this instance variables will be initialized. Okay, that's how I have written this code. Now I'll write some method where public void display details. Okay, display details. So when this method is called, I want the values of the instance variables A and B to be printed. So I'll write the code like this. Inside this display details, you can give any name for this method, guys. I just gave detail display details. Okay, you can give any name for this method. System.out.println, the value of A is plus A. Then system.out.println, the value of B is plus B. Okay, like this. The value of A is plus A, the value of B is plus B. Fine. So when this method is called, the instance variables, whatever the value stored into that instance variables will be printed. Fine. Now I'm going to create another method using which I am going to use this keyword for returning the instance or object of the current class. Okay. This method that I am going to create will return. So for now, I will not return anything. Initially, I will not return anything, guys. So the return type I mentioned as void here. Now I'll give something like give some valid name like return current class object. Okay, I'm just giving some name here, guys, for the method. You can give any name, guys. Okay, that's okay. Now from this method, I want to return using this keyword. Okay, I simply will return this. When you return this, guys, when you return this, that means using this keyword, you are returning the instance or object of the current class. Okay, return this means instance or object of the current class will be returned. So if I have to return the object of the current class, this object should be declared with what type? The class, same class type. So class A. The return type should be class A, guys. Public class A, return current class object. Now, when you say return this keyword will return the object or instance of this current class. Okay, that is class A. That's why the return type should be the class name, class A. Okay, fine. Now I have written this method and I have shown you how to use this keyword for returning the current class instance or object. Now let's create another class. Right click new demo. Public static void main. So let me drag it to the right side so that you can see both the classes together. Here we have class A and here we have demo class. From the main method of the demo class, I will create an object for this class A, guys. Okay. First, I will create an object for the class A. Class A object is equal to new class A. Class A object is equal to new class A. So here, when I create an object for this class A constructor will be automatically called, right? From the object creation statement, this constructor is getting called, class A constructor is called. Okay, when the class A constructor is called, the instance variable A will be initialized with 3 and instance variable B will be initialized with 6. Okay, this initialization has been now happened. Now using this A object, I will say A object dot this method I will call. Okay, the method which will return the current class instance or object will be I want to call. Using this object reference of class A, I would like to call the method return current class object. So A object dot return. So what will happen, guys? Okay, if I put a semicolon here, what will happen? If you hover the mouse on this return current class object, it is returning the object of the class A. Okay, you see, as using this keyword, we are returning the instance or object of the current class. When you call this method, this method will receive the object of class A, right? When you hover the mouse, you can see that the object of the class A is being returned. So what I will do is I will simply say dot. Okay, whatever the object I got, the object is nothing but the object which is initialized with these variables to 3 and 6. That is the object, right? These instance variables in that particular object that is being written are initialized with 3 and 6. So that object will be returned. So when I say the returned object dot display details, okay, what will happen, guys? So whatever the object that is written, it has this instance variables. A particular object has instance variables, and those instance variables are initialized with 3 and 6. So when you say display details, so this method will be called, and based on the current instance that is returned, that is whatever the object having this A and B as 3 and 6, okay, those values will be there in that object. When you say the value of A is A, okay, that means 3 will be printed. The value of A is 3 will be printed. The value of B is 6 will be printed. So like this, guys, using this keyword, we can return the instance or object of the current class, okay, and on the top, using that object as a reference, returned object as a reference, you can say object dot display details. So the instance variables of that particular things will be printed. This will confirm that whether this keyword is returning the instance or object of the current class or not. Okay, so let's run this code and see whether we are getting these values as printed. If we are getting the values properly, okay, then that means that this method has successfully written the object of the current class A. Okay, let's run this and see whether we are getting the result. You see, the value of A is 3, the value of B is 6. Whatever the object got written in that object, this instance variables A and B got initialized with 3 and 6. So when I called using that whatever the returned object, using that returned object, when I called this display details, the value of the A got printed as 3 and the value of B got printed as 6 as stored in the object. Okay, as stored in the returned object. Fine. So this is how, guys, we have to use this keyword in Java for returning the current class instance or object. Okay, so that's it, guys. In the next video session, I'll explain how to use this keyword, for passing the current class instance as method argument. Okay, we are going to use this keyword for a different purpose, that is for passing the current class instance. Okay, here we are only returning the current class instance or object. Now we are going to use this keyword for passing the instance or object of the current class as method argument. Okay, we are going to use this keyword for passing the current class object as a method argument. Okay, so anyhow, I'm going to explain about this thing in the next video session. So that's it, guys. Thank you. See you in the next video session. Bye. Hello everyone. In this video session, I'm going to explain part 175 of Java for Tester series. That is using this keyword for returning the current class instance as a method argument. In Java, we have this keyword is. This keyword in Java can be used for different purposes. And in this video session, I'm going to use this keyword for returning the instance, okay, or object of the current class as a method argument. Generally, if you call a method, it will be like this, right? Method name you'll simply call this method like this. Or if this method calling statement has, if that particular method that you are calling has some parameters, then you will pass some parameters also, right? Like this. Here I'm passing the value 9. But in case of this, if I want to pass some object, we can also pass objects using the methods. Okay. So there may be some methods, guys, which have the parameter as the object. Some class object, it will be there. Okay. For such kind of methods, if you have to call such kind of methods, we have to use the method calling statements like this, method name, and you have to pass the object. Now, in this video, I'm going to explain how to use, okay, how to use this keyword for passing the instance or object of the current class. Okay. For example, there is a class, you want to pass the object of the current class. Okay. So how to pass? We have to say something like this, method name this. This will return or pass. Okay. This means instance or object of the current class case. Okay. Here this keyword means in this method calling statement, if you simply pass this as an argument, okay, in the method calling statement, if you pass this as an argument, then it will pass the instance, that is object of the current class will be passed. Okay. The object of the current class will be passed when you simply pass this as an argument of a method. Okay. In the method calling statement, if you provide this as a argument, this will become object of the current class. Okay. Object of the current class will be passed as an argument. So let me practically demonstrate, guys, how to use this keyword for passing the object of the current class as argument using this keyword. Okay. So let me switch to practical mode. This is Java project, guys. Let's create a new class A. Let's name anything, guys. You can give name as anything, guys. Class A. Let's click on finish. Class got created. Public class name got created. Inside this class, I'll create two methods, guys. Okay. Public. First method I will create is public void. This method. Okay. This method will accept some method y, I will say. Okay. This method will accept the object of the class A. Like this. Okay. This is class A, guys. This method will accept the object of the class A. System.out.println. I'll simply say inside the method y. Okay. Inside the method y. And I'll create on the top of this method, okay, which is receiving the, okay, on the top of this method, which has a parameter as an object, okay, class A object, parameter as a class A object, I'm creating another method, public void method y, method x, okay, method x, okay. So in this method, I will be calling, from this method x, I will be calling method y, guys, okay. So I will simply say method y, and here I want to, okay, I cannot call something like this. I need to pass the object of this class A. So in order to pass the object of the current class, okay, current class is class A. In order to pass the object of the current class, simply I can say this, guys, method y of this. Here this is an argument of this method y, right? I'm passing this as an argument of the method y. So this is nothing but the object of the current class, that is class A. Object of the current class A will be passed to this method y. Okay. So this method y calling statement will pass this as an argument, which is nothing but object of the current class. So object of the current class will be transferred here. Okay. Object of the current class will be there here, and this statement inside the method y will be printed. So when I create another method, that another class, that is a demo class with main method, inside this main method, I'll create an object for the class A. Okay, I'll create an object for the class A. Class A object is equal to new class A, like this. And using this object reference of the class A, I will call method x, guys. Okay, method x I will call. What will happen, guys? Just tell me what will happen. So here, when you create an object for the class A, okay, this A object has become the object reference. When you say A object dot method x, this method x of class A will be called, right? This method x of class A will be called. When this method x of class A is called and executed, inside this method x we have method y. Okay, method y calling statement. This method y will call this method, and this is an argument of this method y, which is nothing but object of the current class. This keyword here stands for object of the current class, that is class A, will be passed to this object. Okay, object of the current class A will be passed to this object of this parameter. This is a parameter, guys. Okay, object of the current class A will be passed to this particular parameter, and this method will be executed as inside the method y will be printed in the output. Okay, fine. So here guys, we have used this as an argument of the method calling statement, right? Which actually stands for object of the current class. This stands for object of the current class. So right click run as Java application. You see inside method y. So everything has went well as I explained. So this is how guys we have to use this keyword for returning the current class object as a method argument. Here I have written the current class object as a method argument. As a method argument, I have used current class object, right? By using this keyword. By using this keyword, I have written the object of the current class. That is class A. Object of the current class is written using this keyword here. And by writing this as a method argument for this method y. Okay. So this is how we have to use guys. So that's it. In the next video session, I'm going to explain about super keyword. Okay, how to use super keyword in Java. I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 176 of Java for tester series. That is super keyword. So what is super keyword? So if you have variables and methods in the child class which are same as the variables and methods in the parent class. Okay, just understand this situation, guys. Let's say there are parent and child classes. Okay, and both this parent and child classes have same variables and methods. In such kind of situation, in order to access the parent class variables and methods, we have to use super keyword. Okay, you got my point? So this is the situation, guys. Let's say there are two classes. Okay, one is a parent class, one is a child class. In the parent class, we have some variable. Here also we have, let's say there are two classes. I said, right, that this, let's say this is the parent class. Let me write down parent class. Okay, and this is a child class. Let's assume this is a child class. Now, in the parent class, let's say there is a variable a. Here in the child class also the same variable a is there. Okay, in the parent class there is a method, say method x. Okay, here in child class also the same method, that is method x is there. This is the situation, guys. Okay, this is the situation I am talking about. If you have variables and methods in the child class which are same as the variables and methods in the parent class. Okay, in this parent and child class we have the same variables and methods. Here int a is there, here int a is there, here method x is there, here method x is there. In such kind of cases, okay, what will happen, guys? There will be an ambiguity, right? Child class also has the same variable and parent class also have the same variable. Now from the child class, if you have to access the parent class variables and methods, okay, if I try to print system.out. Okay, print ln. Okay, if I try to print the variable a, what will be printed, guys? If I try to print the variable a from this child class, what will be printed? This a will, child class a will be printed, right? But if I want to refer to this parent class, okay, then I have to add, instead of printing a here, I have to say super.a. Okay, I have to use super keyword before this a to refer to this parent class variable. The same way, if I have to, okay, the same way, if I have to call this method x, okay, if I have to call this method x, simply I will be calling method x, right? From the child class, if I say method x, from another method, if I say method x, this method x will be called. The method x of the child class will be called. What if I say super.method x? If I, from the child class, if I say super.method x, then the parent class method x will be called. Okay. So this is how, guys, we have to use super keyword. Let me practically demonstrate. Okay. So before demonstrating, let's go through these two statements again so that you will get more clarity. We have the variables and methods in the child class, variables and methods int a and method x. Here int a and method x in the child class, which are same as the variables and methods in the parent class. Okay. they are same. In this diagram, they are same, right? The variables in the child class and the variable in the parent class, the method in the child class, the method in the parent class are same. In such kind of situation, in order to access the parent class variables and methods from the child class, we have to use super keyword. Okay. In order to access the variables and methods of the parent class from the child class, we have to use super keyword. Okay. Before the variable and before the method, we have to add super, so that the variable and method of the parent class, which are same as the child class, will be invoked or called. Okay. So let me practically demonstrate this so that you can understand it more. Right click new. Let's say I will create a parent class known as class A. Okay. And finish. Inside this parent class, I will create a variable int A. I'll give some value also. So let's say 5. And here I will create a method public void method X. Okay. So system.out.println inside method X of parent class. Okay. Class A, I'm going to make class A as a parent class. Okay. So I'm just printing inside method X of parent class. Now I'll create another class. Right click new class. This is class B. I'll drag it this side so that you can see both classes at the same time. In this class also we have the same variable A, and I'm giving the value as 9. Okay, here the parent class class A is equal to 5. Here in the child class B, A is equal to 9. How to make this child class of the parent class class A? Simply I have to say extends class A. Okay, now class B is really a child class of parent class class A. Okay, but here in this both classes, in this parent class, in this child class, we have both. We have variable, same variable. Here also a variable is there, here also a variable is there. But here the value assigned to the variable A is 5. Here the value assigned to the variable A is 9. Okay. Now here I'll create one method which is same as the method in the parent class. That is public void method X. Like this. Okay. In this also I'll print something system.out.println inside method X of child class. Okay. Fine. Now I'll create another method public void method Y. I'll tell you what is the reason. Fine. So I will not write anything here for now. Okay, this is one of the method Y is one of the method. Okay, I'll use it for some purpose. Okay, let it be like that. Now right click new, another class I'll create. I'll call it as demo class, and I will select this main method. So I'll pull it here. Now inside this main method, I'll create an object for the class B. Okay, child class. I'm going to create an object for the child class. Class B object is equal to new class B, like this. Okay, class B object is equal to new class B. So now if I say B object dot, okay, dot method Y. So what will happen, guys, when I say B object dot method Y? Nothing will happen, because this method Y in the class B will be executed, but there is no code. So what if I say system dot out dot println? I will print A. Okay. So what is this? This is normal A, guys. Okay, this is normal A. System dot out dot println A. That means the variable A of the child class, that is class B, which is assigned with the value 9, will be. So here when you try to print the value 9, and when I call B object dot method Y, this method will be executed, and this print statement will be executed, and this child class has the variable A, which is assigned with 9. So 9 will be printed in the output. Right click run as Java application. You see 9 will be printed in the output. What if I want to print the variable A of the parent class instead of the variable A, instead of the value stored in the variable A of the child class, I want to print the value that is stored into the variable A of the parent class. Okay, what kind of difference I have to make? Okay, here I am directly saying A, but if I say super.A, if I say super.A, this means, okay, there are two A's, right? One is in child class, one is in parent class. If you explicitly say super.A, this will refer the variable in the parent class. Okay, so here what should be printed, guys? When you say B object dot method Y, this method will be executed. Which A will be printed? This A or this A? The value stored in the child class A or parent class A? Since I said super.A, value stored in the parent class variable A will be printed. That is 5 should be printed now. Let's run this. Right click, run as Java application. You see 5 got printed. So like this, super keyword can be used with the variables, that too to access the parent class variables. Okay. Now what if I say method X? normal method x. Okay, if I give method x here and I'm calling bObject.method y, if I run this demo.java, this method y will be called. So method y of the child class will be called. So inside this method y, the calling statement method x is there. But here there are two method x. One method x belong to child class, one method x belong to the parent class. Which method will be called when I say method x? The child class method x will be called. So if it is really called, it will print inside method x of child class will be printed in the output guys. Let's run this and see whether that is happening. Right click run as Java application. You see inside method x of child class got called. What if I want to call the method x of the parent class instead? Okay, instead of calling using this calling statement, instead of calling the method x of the child class, if I want to call the same method x, okay, the similar or same name method x which is there in the parent class. Okay, so in such kind of case situation, I have to use super dot method. Okay, method x. Adding the super keyword before this method x will invoke the method x of the parent class. Okay, instead of this will not call this method x of the child class guys. When I add super dot method x, the super keyword will call this method x from the parent class. Okay, super means parent, refer to the method x of the parent class like that. Okay, so it should print inside method x of parent class now. Okay, instead of child class, it should print inside method x of parent class. Okay, bObject.method I will invoke this one, and this will call super dot method x, that is method x which is there in the parent class A. Okay, so inside this method x we have inside method x of parent class that will be printed. Right click run as Java application. You see inside method x of parent class like this guys. Super keyword, okay, can be used to access the variables and methods of the parent class from the child class. Okay, when there is an ambiguity of having the same variables and methods in both parent and child classes, we can use super keyword inside the child class to access the variables and methods which are similar to the variables and methods of the child class. Okay, fine. So this is how guys we have to use super keyword in Java. So that's it. The next video session, I'll start explaining about modifiers. Okay, there are different modifiers in Java. I'm going to explain that in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 177 of Java for Tester series, that is modifiers. So what are modifiers? Modifiers in Java are few predefined keywords. Okay, modifiers in Java are few predefined keywords which can be used with variables. These modifiers can be used with variables, methods, constructors, and classes. Okay, these modifiers are few predefined keywords which can be used with variables, methods, constructors, and classes. So what will happen when I use these predefined keywords with these variables, methods, constructors, and classes in Java? They will modify the behavior or change the nature, change the working nature. So now understand guys what exactly are the modifiers. Okay, these three statements will give an idea of what exactly the modifiers are. First of all, modifiers are few predefined keywords which can be used with variables, methods, constructors, and classes. On using these modifiers with variables, methods, constructors, and classes, the original working of these variables, methods, constructors, and classes is going to get modified. The behavior of this variables, methods, constructors, and class is going to get modified, and also the working nature of these variables, methods, constructors, and classes is going to change. So those are nothing but modifiers, guys. So there are different modifiers in Java. Java, there are different modifiers, guys. What are the different modifiers in Java? Modifiers in Java can be categorized into two types. Okay, modifiers in Java at a high level. Okay, I am just writing modifiers here. Modifiers in Java at a high level can be categorized into two types. One is access modifiers. Other one is non-access modifiers. So what are access modifiers and what are non-access modifiers? Okay, I'll explain that. And coming to access modifiers, we have four access modifiers, guys. Under access modifiers, we have four modifiers. They are, one is public, then we have private, then protected, and then default. Okay, these are the 4 modifiers which are under the access modifiers category of this modifiers. Okay, and these are all the keywords, guys. Okay, I told you, right? Modifiers are nothing but few predefined keywords. Here, public is a predefined keyword, private is a predefined keyword, protected is a predefined keyword. But coming to the default, guys, okay, if you don't provide any keyword, okay, if you don't provide any keyword, then it is default, guys. There is no keyword, like there is no predefined keyword with the name default, guys. Okay, here public is a name, one predefined named keyword is public. Private also has a name, protected is also a name. But coming to default, okay, here there is no name. Okay, no name for this keyword. If you don't provide any public, private, protected, it will become default. I'll explain you how to use this default thing in the upcoming videos anyhow. For now, understand that under access modifiers we have 4 types, that is public, private, protected, and default. Coming to public, private, protected, these are the 3 keywords, guys. Okay, if you don't provide any of these 3 keywords, by default it will become default. Okay, by default the modifier will be default, guys. If you don't provide these modifiers, then it is considered internally by Java as a default modifier. Okay, default access modifier. Fine. So you don't have to provide this text default, guys. It doesn't exist. Okay, if you don't provide this keywords, then it will become default internally. Internally, Java will treat that as default modifier. Okay, if you don't provide any text. Now coming to the non-access modifiers, we have different non-access modifiers. Let's say there are 6. Okay, 3, 4, 5, and 6. 6 non-access modifiers are there. So coming to the first one, that is static. Then we have final, static, then final. Then we have something known as abstract. Then we have, what is that? Synchronized. Okay, transient, volatile. Like this, there are 6 non-access modifiers. Okay, these are all the keywords, guys. These are predefined. These are few predefined keywords of Java. Okay, which fall under the non-access modifier category of modifiers. So these are the different modifiers we have in Java, guys. Modifiers in Java can be categorized into 2 types, that is access modifiers and non-access modifiers. Okay, access modifiers can be further categorized into different keywords known as public, private, protected. Okay, if you don't provide this keyword, it will become default. Okay, then coming to the non-access modifiers, we have different predefined keywords like static, final, abstract, synchronize, transient, and volatile. Okay, this synchronized, transient, and volatile. So these are the 6 non-access modifiers, and these are the 4 access modifiers. So what is known as access modifiers and what is known as non-access modifiers? Coming to access modifiers are nothing but they modify or control the access. Okay, they modify the, using this access modifiers, guys, we can modify the, this access modifiers modify the access levels or controls of the variables, methods, constructors, and classes. Okay, when you use access modifiers with variables, methods, and constructors and classes, they modify their access levels or controls. Okay, so public has some access level, private has some access level, protected when used has some access level. Okay, so these variables, methods, and constructors and classes, okay, the access levels of this, access levels or controls of these variables, methods, and constructors and classes can be modified. Okay, the original variables, methods, constructors, classes will have their own access levels or controls, right? Using these access modifiers, we can modify those access levels or controls or permission levels. Okay, anyhow, I'll explain how to use these access modifiers in the upcoming videos. For now, understand that what are access modifiers. Using access modifiers, we can modify or change the access levels or controls of these variables, methods, constructors, and classes. Coming to the non-access modifiers, as the name suggests, they are non-access modifiers. Okay, they are not related to access levels, not related to access levels or controls. They don't change any access levels or controls, guys, because these are non-access modifiers. Coming to access modifiers, they modify the access levels or controls of the variables, methods, constructors, and classes. But coming to the non-access modifiers, they are not related to access levels or controls. They will not do anything about this access, okay? But they modify this non-access modifiers, or modify the behavior or change the working nature by providing special qualities, okay? Special properties, you can say. To what, guys? Okay, when you use non-access modifiers, they modify the behavior or change the working nature by providing special properties to variables, methods, constructors, and classes. Okay, so when you apply the non-access, when you apply the access modifiers, they deal with the access levels or permissions or controls of the variables, methods, constructors, and classes. But coming to the non-access, they are not related to the access levels or control, guys. Okay, they will not do anything about access levels or controls of the variables, methods, constructors, and classes. But non-access modifiers will change the behavior, okay, of these variables, methods, constructors, and classes. They will modify the behavior or change the working nature of these variables, methods, constructors, and classes by providing some special properties to this variables, methods, constructors, and classes. Okay, so both are different, guys. Modifiers are categorized to access modifiers and non-access modifiers. Access modifiers are related to the access permissions and levels or controls. They modify those things, whereas commit non-access modifiers, they modify the behavior or working nature of this variables, methods, constructors, and classes. Okay, so guys, this is all about the modifiers, guys. Okay, this is all about the modifiers. We are going to continue a lot of videos on this modifiers topic, because there are different there are different modifiers like access modifiers and non-access modifiers. In the coming videos, I'll explain each and every access modifier and each and every non-access modifier. Okay, I'll explain each and every access modifier and each and every non-access modifiers in detail in the upcoming videos, guys. So let's continue the modifiers topics in the upcoming videos, guys. So in the next video session, I'm going to explain public access modifier. Okay, how to use the first access modifier, that is this public access modifier. I'm going to explain as part of the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 178 of Java for Tester series, that is public access modifier. Public access modifier can be used with different things in Java. Okay, what are the different things that you can use this public access modifier with? That is classes, variables, methods, constructors. Okay, all these things you can use this public access modifier with. Fine. So in this video session, I'm going to practically demonstrate using this public access modifier with classes, variables, methods, and constructors to show you what will happen when I specify all these things with public access modifier. Okay. So before I practically show you, let me explain at a high level what will happen when you apply this public to all these different things in Java. So guys, if you apply this public access modifier to these different things in Java, we will be able to access all the above things from outside the class. Okay, all the above things outside the class and outside the package also. Okay, outside the package also. So if you use this or specify this classes, variables, methods, and constructors with public access modifier, we will be able to access all these things from outside the class. Okay, outside the class, inside the class, outside the package, like that. Okay, in order to access all these things, in order not to bound all these things inside the class itself, if you apply this public, you can access from everywhere, guys. Okay, in the same Java project, you can access all these things from everywhere in the Java project. Okay, let me practically show you guys how you can apply this public and how you can access all these things. Okay, fine. Let's create a new pack. Okay, let's say this is Java project, and right click on this SRC and create a package. That is, let's say I'm creating a package named pack1. Another package also I'm creating, pack2. So inside pack 1, I'm going to create two classes, guys, class A and class B, which will be inside the same package. Okay, class A and class B is going to be there inside the same package. When I create class A, guys, by default, when I created this class A, by default, okay, by default, this class A got inside Eclipse ID. When I created this class A, by default, this public access modifier is added, okay, to our code. So for now, the class A is specified with which access modifier? Public access modifier. That means we can access this class within the package, outside the package, like that. Everywhere you can access this class, guys. Okay, let me show you how you can access this class. How to access the classes, guys. So in order to check whether we are able to access the class or not, okay, what we have to do? We have to create an object for this class. Okay, create an object. If you are able to create an object and if you are not getting any compiler error, that means this class is accessible. So to do that, what I will do is I will inside this class B that I just now created. Okay, I'll just drag it so that you can see both classes. I'll create some method here, like say public void some method B, and inside this method, I'll try to create an object for this class A. Okay, I'll try to create an object for this class. If I am able to create the object for the class, that means this particular class is accessible even outside the class also. Okay, this class is accessed outside from the different class also. Okay, this class A and class B are from the same package, guys. If I am able to create an object for this class A without any compiler error in this class, another class called class B, that means this class A is accessible in class B also. Okay, let's find it out. Class A object is equal to new class A. So this is the object creation statement, guys. Are you getting any compiler errors, guys? No. That means we are able to access this class A from a different class known as class B, and this class B is inside the same package. Now I want to check whether I can access this class A outside the package or not. Okay. So for that I will create another class. Okay, class C. This class is being created under another package. Okay, class A is under package 1, but class C is under package 2. Okay, class A belongs to one package and class C belongs to another package known as pack 2. Okay, inside this class, in order to create an object, I have to create some method, guys. I will create some sample method like method C. Okay, now in this method, I can create an object for this class A. I'll try to create an object for the class A to check whether, okay, from outside the package, will I be able to access this class which is specified with which access modifier? Public access modifier. So let's find out. Class A object is equal to new class A. So you will get some compiler error because this class A belongs to package 1, but class C belongs to package 2. In order to use a class which is outside the package, we have to import the package, right? We have to import this class from this package. Then only we can access. That's the basic rule of packages in Java. So over the mode and say import class A from package 1. Okay. Once you import this class from the package, then you are able to access this. Okay. That means the class which is specified with public access modifier can be accessed within the package and even outside the package also. Okay, public means can be accessed from anywhere in the project. Okay, if you specify a class as public access modifier with public access modifier, then you can access that class by creating an object. Okay, from anywhere in the project, from anywhere. Okay, no matter where you are, either you are in the same package or you are outside the package or whatever it is, you will be still be able to access this class which is specified with public access modifier. Okay, within the project you can access. Fine. That means public will make this class accessible everywhere in the project. Now that's about the class, guys. Okay, that's about using this public access modifier with the class. What if I apply this or use this public access modifier with variables? Okay, let's create a variable, guys. Let's say I'm creating a variable known as A, and I will specify public access modifier for this variable. In that cases, can I access this? Can I access this variable everywhere? That is everywhere in the project? The answer is yes, guys. Okay, so answer is yes. When you specify the variable with public access modifier, you can access such kind of variable, okay, from everywhere in the project. That is inside the package or outside the package, you can access. So how to access this variable, guys? Using the object reference of this class, that is class A, we already created, right? Class A object is unique. Using this object reference, I can access this variable. So a object dot a is equal to some 5. Okay. Similarly, this class C is outside the package of class A. So from here also can I access this variable which is specified with public access modifier? Yes, guys. From here also you can do a object dot a is equal to some 9. I can do like this. Okay, I can access. So what about methods, guys? Okay, what about methods? We are done with classes. We are done with classes and variables. Okay, I explained how what will happen when you specify these classes or variables with public access modifier. Right? You are able to access these classes and variables within the package and outside the package. That means everywhere you inside the project you can access these classes and variables because they are specified with public access modifier. Same thing applies to the methods also, guys. You will get the same result. So let's create a method. I'm providing public case, okay, for the method. Public void the method A. Okay. I created a method, guys, and I specified this method with public access modifier. So can I access this method from everywhere in the project? Let's find it out. First, let's try to access within the package. A object dot method A. You see, I'm able to access, guys. A object dot method A, I'm able to access. From outside the package, let's try A object dot method A. Still, I'm able to access. Okay. Since this method is specified with this public access modifier, I'm able to access this method from everywhere in the project. From everywhere in the project, you can access. Okay. The access restrictions are not there on this variables, methods, and classes. Okay. You can access from everywhere because they are specified with public access modifier. Now, let's create a constructor, guys. Okay. Let's apply this public access modifier with constructors. First, let's create a constructor, guys. The name of the constructor should match with the name of the class. So I'll give the same class name, that is class A, and create a constructor like this. Okay, this is a constructor, guys. I am specifying this constructor with public access modifier. Okay, so in such kind of cases, guys, I will be able to access this constructor. I should be in a position of accessing this constructor from everywhere in the project. That is, you see, this is a constructor calling statement. When you create an object for the class A, automatically the constructor will be called, right? This is a constructor calling statement inside the object creation statement, right? So in class B, I'm able to access. I'm not getting any compiler error here. Okay, that means this class A is accessing this, is able to access this class A constructor, which is specified with public access modifier. That is within the package, guys. What about outside the package? Now outside the package also we have this class A constructor being called here, right? During the object creation statement, we are calling this constructor. So here also we didn't get any compiler error. That means since this constructor is specified with public access modifier, it will be able to access, we will be able to access it from everywhere inside the project. Okay, inside the project, within the package or outside the package, we can access this constructor. So guys, at a high level, it may be class, it may be a variable, it may be a method, or it may be a constructor. Okay, if you specify any of these things with the public access modifier, that means all these things can be accessed from anywhere in the project, that is within the package or outside the package, doesn't matter. So from everywhere in the project, you can access these classes, variables, and methods and constructors which are specified with public access modifier. So this is how, guys, public access modifier works in Java. Okay, it will make your classes, variables, methods, and constructors, okay, accessible throughout the project. So that's it, guys. In the next video session, I'll explain the next access modifier, that is private access modifier. Okay, the second access modifier I'm going to explain, guys, in the next video session, that is private access modifier. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 179 of Java for Tester series, that is private access modifier. So private access modifier. In Java, this private access modifier can be used with three things. That is variables, methods, and constructors. Okay, you can use this private access modifier with these variables, methods, and constructors. And if you try to use this private access modifier with classes, okay, in Java, if you try to use this private access modifier with classes, you will get compiler error. So you cannot use this private access modifier with classes, guys. Okay, private access modifier can be only used with variables, methods, and constructors in Java. So fine, if you use this private access modifier with variables, methods, and constructors, what will happen? Once you specify these variables, methods, and constructors with this private access modifier, they cannot be accessed outside the classes. Okay, outside the class in which they are created. The variables, methods, and constructors created in a class, okay, they can be only accessed within the class. But if you try to access them outside the class, you cannot access. Okay, they can only be accessed in the class where they got created. Okay, where they got created. The class in which they got created, in that class itself, they can be accessed. Once you mention these variables, methods, and constructor as private, they cannot be accessed outside the class. They can be only accessed inside the class in which they are created, guys. Let me practically demonstrate the same, guys. Okay. So for that, I will create some class, guys. Say class A, and click on finish. Okay. And inside this class, I will create some variables, methods, and constructors. For now, I'll simply use public, guys. So later, I will change it to private. Okay. Let's start with public. Public int A, then public void the method A. I'm just creating variables, methods, and a constructor also. Okay, public class A. For now, the access modifier that is specified before this class or variable or method or constructor is public. Everywhere it is public, guys. Okay, I'm going to change this public to private and show you what will happen. Okay, now let's create a new another class, guys. Let's name this class as class B. Click on finish. Inside this class, we'll create a method, sample method like public void method B. Fine. So let's keep these things ready. We got these things ready now. So what I'm going to do is I would like to make this class as private. As explained, private access modifier cannot be used with classes. If you try to use this private access modifier with classes, you are going to get compiler error. Let's see whether that is happening or not. Okay. Here you can see, guys, there is a class. Here there is a class here, class A. And if I make this public to private here, okay, instead of public, if I'm giving the private access modifier, immediately I'm getting a compiler error, guys. Illegal modifier, it's saying. Okay, illegal modifier, you can only use public or other permitted things. Okay, public or other permitted things can be used here. So here you cannot use private, it is saying. Indirectly, it's saying it's an illegal modifier and you cannot use other than public and all. Okay. So you cannot use private here. So again, I'm making it public case. Okay, that's just for demonstration. If you use public, then only it will work. If you use private here, then you are getting a compiler error saying that illegal modifier, right? Okay. So private cannot be used with classes. Okay, we cannot specify the private access modifier with classes. We try, so we are getting some compiler error, right? Now let's try to use this private with variables. As you can see here, there is a variable A which is specified with public access modifier. I'll change this public to private here. Okay, I'll change this public to private. Now, since this class is public, okay, this class cannot be private. It is kind of public here. I'll try to create an object for this class, guys. Okay, first let me create an object for the class. Class A object is equal to new class A. What will happen, guys? So it will not give any error because this class A is specified with public only. Okay, as we cannot specify the private access modifier with classes. Okay, I just kept it as public because I'm directly getting the error. So I cannot keep private here. So that was not possible. So I made it public. So since this class is specified with public access modifier, okay, I'm just creating an object for this class which is having specified with public access modifier. Okay, up to here is fine. Now I made this variable A to be specified with private access modifier. In this kind of situation, if I try to access this variable A, can I access, guys? Okay, from outside the class. This class B is a separate outside the class of class A, right? Outside the class A, if I try to access this variable A, which is specified with private access modifier, will that be possible or not? Let me try, guys. A object dot. Am I getting A? No. There's no possibility of accessing A, guys, because it's specified as private type. Okay, this variable A is of private. So you will not be able to access outside the class. You cannot access this private specified variable. Okay, they cannot be accessed outside the class. They can only be accessed inside the class stage. So let's try see whether we can access this variable inside the class. If I say system.out.println, okay, if I try to print the value of A, the value of A is okay plus A, like this. Okay, I'm trying to access this variable inside the same class in which it got created because it's of private type. You see, I'm able to access it, guys. I'm not getting any compiler error. error. But if I try to access this, okay, like this, the value of a is plus a object. Using the object reference, we have to access, guys, because this is a separate class. So object a object dot a. I have to access like this. You see, I'm getting error saying that is not visible. Okay, it's not visible because this is mentioned as private. If I make it public, I can access, guys. You see, the error will be resolved when I save it. You see, error got resolved. The compiler error has been gone. Now I am able to access the variable a, which belongs to the class A because it's public. The moment I make it private, I'll get the compiler error, guys. Okay, you see, I'm getting the compiler error saying that it's not visible. So if the variable which is specified with private access modifier cannot be accessed outside the class, this proves that. Similarly, this method A, okay. So currently this method is specified as public. So if I try to access using this object reference a object dot method A, I'm able to access, right? I'm able to access this method A because it's specified with public access modifier. Public means you can access from everywhere. Inside the project, you can access from everywhere. But once the moment when I make this public to private access modifier here, okay, and save it, you see I'm getting a compiler error saying that is not visible. Okay, I'm not able to access, guys. I'm not able to access this method because it's private now. Okay, so such kind of private methods can only be accessed inside the class itself. Okay, inside the class, inside the constructor. I'm just calling this method, guys. Okay, I'm simply calling this method. You see, I'll be able to access it inside the class. I am able to access. Okay, I'm able to call this method A from the inside the class. But when I try to access it outside the class, this method A, which is specified with private access modifier from outside the class, I'm getting a compiler error. Similar thing is there with the constructor also. This is a constructor, guys, which is having the same name as the class name, right? If I make this public to private, immediately when I save it, I can get a compiler error here. Okay, while creating the object, you see this constructor need to be called, right? But since this constructor is of what you call private type, I'm not able to. I'm getting some compiler error here. Okay, since this constructor is private type, okay, I cannot call this from the object creation statement. It's not possible now. Okay, so we have to remove this part, guys. Okay, up to this is only possible. When I try to call constructor from the object creation statement, I'm getting a compiler error. What was the compiler error? The constructor is not visible. The same error, guys. Okay, the same compiler error because this constructor is now private. Can I access this constructor from within the class? Yes, I can do that, guys. Okay, what I will do simply is I'll create an object for class A. Inside the same class itself, I'm creating the object in one of the methods. New class A. Now a object dot, I can access anything, guys. Okay, I can access a object dot a. Okay, system dot out dot println a object dot a. Then I can call this constructor also. Okay, this constructor is already called. When you create an object here, you see the constructor is automatically called here, and I'm not getting an error because this is private. You can only access the private specified variables, methods, and constructors within the class. But when you try to access them from outside the class, you will get compiler errors. Okay? So it is not possible. So the private access modifier specified variables, methods, and constructors cannot be accessed outside the class. They are restricted to the class in which they got created. So this is how, guys, we have to use private access modifier in Java. In the next video session, I'll explain how to use the next access modifier, that is protected access modifier in Java. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 180 of Java for Tester series, that is default access modifier. Default access modifier in Java can be used with different things like variables, methods, constructors, and classes. Okay, default access modifier in Java can be used with different things in Java like variables, methods, constructors, and classes. Fine. So, is there any keyword in Java with the name default, guys? No. Then why I'm writing default here? Let me explain everything in detail. Okay. So in Java, we have different access modifiers like public, private, protected, and default, right? So these are the 4 different access modifiers in Java. These 3 are the keywords, guys. Okay, this public, private, and protected are keywords. But coming to default, it's not a keyword. Okay, default is not a keyword. Then what exactly the default means? If you don't specify anything out of this public, private, protected, it will become default. Okay, if you don't specify this access modifiers like public, private, and protected with this variables, methods, constructors, and classes, okay, by default they have this default access modifier. Okay, inbuilt. Java will take care of that, this particular thing, inbuilt, guys. Okay, it's an inbuilt feature in Java. If you don't provide any access modifiers like public, private, protected before these variables, methods, constructors, and classes, Java will internally treat that as default access modifier. Let me give a simple example, guys. Let's say there is a variable, guys. Okay, int a. Let's say you are saying int a. Okay, and before this you just added or specified this public access modifier. Okay, just before declaring this variable, just mention the access modifier like public. Fine. Then you have to specify, guys. If you want to make this variable a as public, you have to mention this public access modifier. Or if you want to make this private, then you have to use private access modifier. What if you want to make it protected? You have to add the protected access modifier before this variable, right? Now, what about default? For default, you don't have to provide anything, guys. If you simply say int a, that means by default, there's a default access modifier before this variable. Okay, this variable has default access modifier specified inbuilt by Java, guys. Okay, so for all the other keywords, public, private, protected should be explicitly provided. But for default access modifier, if you don't provide any access modifier, it becomes default access modifier. Okay, fine. Now we know how to specify some variables, methods, constructors, and classes as default access modifiers. That is, without providing anything, that they become default access modifiers specified variables, methods, constructors, and classes. Right? Now, what is the purpose? Okay, what is the purpose? The purpose is, or how this default access modifier will work with variables, method, constructors, and classes. So when you don't specify any access modifier, okay, these variables, methods, and constructors and classes can be accessed within the package. Okay, from all the classes within the package, they can be accessed. That means it's public. Okay, this default access modifier will act as public for all the things which are inside the package. Okay, if they are in the same package, it's access public, guys. If you want to access it outside the package, you cannot access, guys, because it is private. Okay, it will act as private if you are trying to access these variables, methods, and constructors and classes outside the package when not specified with any access modifier or default access modifier. Okay, so within the package, the default access modifier will act as public. Okay, outside the package, this default access modifier will act as private. That means you cannot access, right? Private means you cannot access. Outside the class, you cannot access. Okay, within the package, it will be public, but that means it can be accessed. Within the package completely you can access, but outside the package you cannot access these variables, methods, constructors, and classes. Okay, let me practically demonstrate, guys. Let's create a new package. Let me name this as pack1. Under this, let me create 2 classes. Class A, finish. Okay, in this I will say public int a. For now, let me specify with public, guys. Later I will change everything. Okay, then I will say public void the method a. Then I'll create a constructor. Okay, this is a variable, instance variable. This is a method, and now I'm creating a constructor. So public class A. The name of the constructor should match with the name of the constructor. Okay, class. Name of the constructor should match with the name of the class, like this. Fine. Now let's create another class, and I will call this class as class B. Finish. Take it here to the right side. So now I will remove all this public. Wherever the public is there, I will remove, guys. Okay. Here, this class, this variable, this method, and this constructor all are specified with which access modifier? Public access modifier, right? In this class. So I'll remove the public from here. I'll remove the public from here. I'll remove the public from this here, and I will remove the public from the constructor also. So I have removed the public from class, variable, method, and constructor. So what is a modifier now? If I remove the public, what is the modifier, guys? If you don't specify any access modifier here before the class, variable, method, and constructor, they will become default access modifier. Okay. Here inbuilt Java has specified default access modifier. Okay. If you don't specify any access modifier, it's like default specified access modifier. Okay. For all the four things, we have the default access modifier specified now. In such kind of cases, okay, this class B also belongs to the same package. Class A and class B are from the same package. Package one, package one, right? In such kind of cases, guys, this default access modifier will act as public. Okay, this default access modifier will act as public access modifier for all the things which are inside the same package. Okay, since class B is also in the same package, this default access modifier will act as public. Guys, public means you can access, right? So let's create a method here to see whether we are able to access some classes, variables, methods, and constructors from this class. Okay. So let me create some method, public void method B. Like this, I'll create. And inside this method, I'll try to create an object for this class to see whether I'm able to access or, okay, something like this. Class A object is equal to new class A. Let me create an object like this. When I create an object, if I'm able to create, guys, that means I'm able to access this class A from class B, right? This class is provided with the default access modifier here. Okay, so I'm able to access the class here from a different class. I'm able to access this class. That means this default access modifier is acting as a public to the classes which are in the same package. And also, I'm able to call the constructor here. Class A is a constructor. During the object creation statement, this constructor is being called. This is also specified with default access modifier. So it's acting as a public for all the classes which are inside the same package. Okay, fine. Now I will check whether I can access this variable and method also. Okay, if this variable and method also are also specified with which access modifier? Default. If you don't provide anything, that means default access modifier. Using the object reference of this class, okay, A object. If I say dot, okay, something like that, system.out.println, you can write the print statement. The value of A is plus A, like this. Okay, not A, plus A object. Using this object reference, I have to access. Okay, dot A I have to say. Okay, and also I'll try to access this method. Okay, which is also specified with default access modifier, which act as a public to the all the classes which are inside the same package. So here I will say A object dot method A. You see, I'm able to access this. Right? So I'm able to access the class. I'm able to access the constructor. I'm able to access the variables, and I'm able to access the methods. Okay. So that means default access modifier is acting as public access modifier in case the other class is inside the same package. What if I create another package, guys? Pack2. Okay. Let me create another package known as pack2, and inside that I'll create a class, another class. Say class C. Click on finish. Scroll it down somewhere so that you can see all the classes together. Fine. Now, guys, what I'm going to do is inside this also I'll create some method so that I can create some objects and all. Okay. Public void some method C. Inside this method, I'll try to create an object for this class A. Okay. Let's see what will happen. Class A object is equal to new class A. When I do so, I'm getting some compiler error saying that class A cannot be resolved to a type. Why, guys? Why class A is not resolved to a type? Here, for this class, we have the default access modifier, right? That means default access modifier will act as public for all the classes which are inside the same package. That means for class B, this class A will be public. But for class C, which is inside another package, So outside the package, if you are trying to access, guys, in that case, this default access modifier will act as a private for all the classes outside the package. Will act as private, guys. Private cannot be accessed outside the class, right? So here, guys, that's the reason I'm not able to create an object. I'm not able to access the class also, right? So what if I make it public here? What if I make this public? Okay. If I explicitly provide public here, now you see it is asking me to import the class A from package one. After that, you see class A is getting access. Okay, I'm able to access the class A. Now constructor is not being accessed. It says constructor A is not visible because this constructor is having the default access modifier. Default will act as private for all the classes which are outside the package. Class A and class A are in different packages. So this default access modifier of class A will act as a private for the class C. So in that case, constructor is not possible. So if I add public here, you see, I will be able to access. If I say public here, you see, the compiler error got resolved. I'm able to access now. Now what I will do now is, I'll try to access this variables and methods. Okay, this variable and method are also default type, default access modified specified variable and default access modified specified method. Okay, so if I say a object system.out.println, the value of a is plus a object dot a. Okay, I'll get compiler error, guys. You see, this one is also default access modifier, which is nothing but private for all the classes which are outside the package. Since this class C from which we are trying to access this variable is outside the package, so it will act as private. So once I make this public here, I will be able to access, guys. Okay, you see, outside the package, if I have to access, it should be public. If I remove this, it will become default. Default is private for all the classes which are outside the package. The same thing will apply for the method also, guys. Let me try. So we'll say a object dot, I'm not able to access, guys, dot method a. Okay, it's not coming. Now what if I make this method also public? Okay, from default access modifier, if I make it public, it will be not only public for the classes which are in the same package, but also for the classes which are outside the package. Okay, until then it will act as a private. Okay, default access modifier will act as private for all the classes which are outside the package. Now guys, if I say a object dot method a, it will come. Okay, like this. Fine, guys. So this is how the default access modifier works in Java. If you don't provide any access modifier before the classes, variables, methods, and constructors, that can be treated as a default access modifier by Java. And the default access modifier will act as public for all the classes, okay, which are inside the same package. Okay, this class A and class B are inside the same package. So the default access modifier will act as public for both these classes. But coming to the other class which is outside the package, which is in a different package or outside the package, for that default access modifier will act as private. Okay, so private, you will not be able to access the private related stuff outside the packages, right? So that's the thing. So guys, this is all about the default access modifier in Java. Okay, this is how we have to use the default access modifier by not specifying any access modifier before classes, variables, methods, and constructors. Okay, so that's it, guys. In the next video session, I'll explain the next access modifier, that is protected access modifier. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 181 of Java for Tester series, that is protected access modifier. So protected access modifier can be used with different things in Java like variables, methods, and constructors, guys. Okay, we can use this protected access modifier with variables, methods, and constructors. And this protected access modifier cannot be used with classes, guys. Okay, should not be using protected access modifier with classes. If you try to specify some class with this protected access modifier, then you are going to get some compiler error. Okay, so protected access modifier only works or can be used with variables, methods, and constructors, and it cannot be used with classes because it results in some compiler error. Okay, so fine. So what is the purpose? Okay, how does this protected access modifier works in Java? When you use this when you specify these variables, methods, and constructors with this protected access modifier, okay, this variables, methods, and constructors will behave as public, okay, for all the classes which are in the same package, okay, for all the classes which are in the same package, this protected access modifier for these variables, methods, and constructor will act as public access modifier. It acts like, okay, and it acts like private for all the classes which are outside the package, okay. It acts like private access modifier for all the classes which are outside the package. That means you cannot access the variables, methods, and constructors which are specified with protected outside the classes, because private means cannot be accessed, okay. It can be only accessed in the created class, but outside the class you cannot access, right? So private means like that. So within the package it acts like public. That means you can use all these variables, methods, and constructors everywhere inside the same package, okay. In all the classes which are in the same package, it will be used as public, okay. Protected means. Coming to the outside the package, you cannot use these variables, methods, and constructors because it acts like private. Protected acts like private outside the package. Protected acts like public access modifier inside the package, okay. And this kind of thing, this kind of working nature of this protected looks similar to the default, okay. I explained in the previous video, I explained about the default access modifier, right? So the protected and default access modifier, the functionality looks similar, right? When you specify this default with variables, methods, and constructors, okay, default is also like public for all the classes inside the same package, and outside the package it is private. The same thing is for protected and same thing is for default. But what is the difference, guys? What is the difference between this protected access modifier and default access modifier? A small difference, guys, okay. A small difference, guys, that is, you can say that protected access modifier is an extended version of default, okay. Protected access modifier is an extended version of default. Though protected and default has the same properties, like they will behave like public for all the classes which are in the same package and private for all the classes which are outside the package. But there is small difference between these two things. That is protected, okay. For outside the package, it's completely private, right? Default is completely private for all the for all the things that are outside the package. But coming to the protected, it has some extension, guys. That is the child classes, okay. Child classes outside the package can child classes outside the package can access the protected variables and methods. You're getting my point, guys? So small difference between this protected and default is that in protected, guys, this part is same as default, okay. Up to here it is same, guys, okay. Protected and default are same up to this box. But outside this box, protected is somewhat an extended version of default where it allows the child classes outside the packages, okay. The exception here is child classes, guys, okay. Though it is private, protected is private for all the classes outside the package, but there is an exception here. If that class which is outside this package, if the class which is outside the package is a child class, okay, then you can access the variables and methods of the which are specified in protected access modifier, okay. This is a kind of exception, guys, exception category this is, okay. So default plus this extra thing will become protected, simple, okay. So all the classes outside the package cannot access these variables, methods, and constructors. But there is an exception where if that particular class which is outside the package is a child class, then you can access the variables and methods which are specified with protected. That's the exception. Okay, this part is the exception, guys, and it is differentiating the protected access modifier from the default access modifier. So let me practically demonstrate, guys, okay, how to use protected with variables, methods, and constructors and all this stuff, whatever I explained so far, okay. And how protected access modifier cannot be used with classes, how we can get some compiler error and all those things also I'll practically demonstrate. So let's start working on. Let's create a new package, say pack1, and inside this package, let's create a class. I will name this class as class A. You can name it anything. Click on finish. So inside this class, okay, let's start, guys. Okay, let's get started. For example, this is a class. and this current access modifier for this class is public. So I'll make this public to protected. Immediately when you make this public to protected access modifier, okay, for this class, you specify this class with protected access modifier, you will immediately get a compiler error. Compiler error will be displayed. As you can see, protected cannot be used with classes, okay, cannot be specified with classes or classes. So when I try to specify the protected for the classes, I got a compiler error saying illegal modifier, okay, only public and other things can be used but not protected. So I have to again make it back to public, okay, so I cannot use protected with class, so I have to leave it like this. Next thing is, inside this I'll create some variables, guys. Let's say I'll say protected int a, okay. I have specified this variable with protected access modifier, and also I'll create a method also, same thing, protected void the method a. This method is also specified with which access modifier? Protected access modifier. I'm going to create a constructor, and also I'm going to specify the constructor also with the protected access modifier. Protected, the name of the constructor should match with the name of the class. So let me copy paste the class name here, and like this. This is a constructor and it is also specified with the protected. Here, guys, since classes doesn't support protected, if I try to do so, I'm getting some compiler error saying that illegal modifier. So I have to change it back to public. So there is no way that I can use protected with the class. But coming to other things like variables, methods, and classes, okay, variables, methods, and constructors, sorry, variables, methods, and constructors, you can specify them with the protected access modifier as shown here. You see this variable, method, and constructor are here provided with which access modifier? Protected access modifier. Okay, fine. So far so good. Let's create another class, guys. Say let's call this class as class B, and click on finish. I'll drag it to the right side somewhere, and inside this class B, I'll create some method public void some method B, and inside this method, I'll try to access this variables, methods, and constructors. Okay. In order to access these variables, methods, and constructors, I have to create an object for this class, right? Since class is already public, so you can easily create, guys. Okay, without any problems, you can create class A object is equal to new class A, like this. So I created an object for the class A, and here you see the constructor is being called, guys. Class A constructor. This class A constructor is of which type? Is specified with which access modifier? Class A constructor is specified with protected access modifier. This protected works as public access modifier for all the classes which are inside the same package. Here class B is also inside the same package. So this protected will act as a public. That means you can use this, you can call this constructor from anywhere inside the package. So from class B, which is also in the same package, I can easily call without any problems. It's accessible, guys, okay, without any problems. Now using this object reference of this class, I'll try to access these variables and methods, okay. System.out.println, the value of A is, I'll say, plus, using this object reference, I have to access these variables and methods of a separate class, right? So I have to say A object dot A. You see, I'm able to access. Why? How I am able to access this variable, guys? Because this variable A is specified with protected access modifier, which works as public access modifier for all the classes which are inside the same package. Since this particular class B is inside the same package, so here protected will act as a public. That means you can access the variables from this class, okay, without any problem. Similarly, method also is specified with protected. I can directly call it without any problem because this protected will act as public for this method also. A object dot method A. I'm able to call this method without any problem because this protected is acting as public here. Okay, fine. So constructor calling is done, then variable accessing is done, then method calling is done. So we are able to access the variables, methods, and constructors, okay, from the class which is inside the same package. Okay, this protected specified variable, methods, and constructors we are able to call from the class which is inside the same package. It's working fine. So let's create another package, guys. So let's name this package as tag2, and let's create another class. Right click new class. I'll name this class as class C. You can name it anything. Click on finish. Just make it down somewhere. Okay, so in this class, I'll create some sample method like public void, okay, public void method C, like this, some sample method I'll create, and I'll try to access, okay. Now, after creating this sample method, I'll try to access what you call the protected specified variable method and constructor. I will try to access. Okay. So will I be able to do that? Here, protected will act as private for all the classes which are outside the package. You see, this class A is in another package, class A is in another package. That means from class C, which is outside the package, if you try to access this protected specified variables and methods or constructors, you are going to get compiler errors for sure, because this protected will act as private. Private means you cannot access. Private can be only accessed within the class, right? So let's see how we are going to get this compiler errors. Let's see. Okay, let's first start with in order to access these variables, methods, and constructors, we have to create an object for this class. So class A, some A object is equal to new class A. Like this, I am going to create an object. So here it will ask me to import, guys, import this class A, because class A belongs to a separate other package and class C is in another package. In order to access this class A from a different package, I have to first import it. So I'm just importing this class A from package, then I can start using the class. I'm able to access the class, guys, because class is of public type, not protected. Okay, you cannot use protected with class, so directly I'm able to access the class. That's fine. But coming to the constructor calling, I'm getting some compiler error, guys, because it's saying that this constructor calling is not visible. This constructor calling is not visible, guys. The problem here is this constructor is specified with protected, which acts as private outside the package. Since we are accessing from outside the package, this protected is behaving as private. That means you cannot call this constructor. Until you make this public, you cannot call this. Once I make this public, you see the error got resolved. Now I'm able to access. But if it is protected, this protected will act as private for the classes which are outside the package. So immediately we are going to get the compiler error like this, not visible. Okay, let me make it public for a while, guys. Okay, let's make this public so that we will be able to create some object and all. Okay, fine. Otherwise, you will not be able to access. So remove this, and so fine. Let's do one more thing. So let's make this to public. Okay, class A to public, constructor to public, so that you can create an object at least. And using this object reference, let's try to access this variable and method which are specified with protected. Here, protected means private for the classes which are outside the package. So if you try to access that, like system.out.println, the value of A is this plus A object dot A. I am not getting that, guys. Okay, if you try to do so, it will not be visible because this is protected, guys. Protected will act as private. So private specified variables cannot be accessed outside the class. Same thing will apply to the method calling also. Method is also protected here. If you try to access using this object reference, if I try to access A object dot method A, you see I'm getting some compiler error here because this method A is also specified as protected, which is private for outside classes, which outside package classes. Okay, fine. But guys, there is no way, right? There is no way you can access this variables and methods which are specified with protected access modifier. There is one way, guys. Okay, as I told you. So far it's almost same as default access modifier, right? So far whatever the things I explained here, okay, within the package it acts like public, and outside the package it acts like private. All those things are similar to the default access modifier which I explained in the previous video. But protected is a kind of extension version of this default where it has some exception here. Okay, this is a separation. That is, if in case whatever the class which is outside the package, okay, is a child class, extends, okay, child class of the class which is in the package. If you are trying to access this class A, in which this variables and methods are specified with protected access modifier, if this particular class is a parent class of this class C, which is outside the package, in that case, guys, inheritance will carry on, right? So this protected access modifiers can be inherited. That's what is the thing. I can directly use them, guys. Okay, I don't have to even create an object for the class. I can directly use them. System.out.println, the value of A is directly I will say plus A. Okay, you see I can directly use the protected specified access variable, protected access modifier specified variable. I can directly use because this class is extending the class A. Okay, that's how the protected specified access modifier can be used here. Okay, and I can also access this method directly. Okay, I don't have to create an object and access this method from class A, because class A is extending class A. And since these two variables and methods are like what do you call protected specified access protected access modified specified variables and methods, you can directly use them, guys. That is here I can say directly I can call this method from the class C. That is I can directly say method C like this. Okay, method C. So from method C, I'm calling this method A. Okay, sorry, method A. I'm calling the method A. You see, I don't have to do anything, guys. So these are protected. So for protected access variables, protected access modified specified variables and methods, okay, you can access them from the child classes. Even though this class is outside the package, you can still access this protected access modified specified variables and methods. Okay, same way like this. What if let's find the difference, guys. The difference between the protected and default is like this: protected will allow the child classes outside the packages to access the variables and methods, right? But coming to the default, it will not do so. Okay, if I remove this, it will become default, guys. Right? You see, immediately I'm getting, even though this class C is extending the class A, since this variable and methods are here default access modified specified variables, I'm getting compiler errors. Okay, I'm getting I cannot use like this, guys. Okay, not visible will come. Even though class C is a child class of the class A, but here these variables and methods are default access modified specified variables, right? And methods. So you cannot access them. But if you make it protected, then you can access, guys. Okay, child classes outside the packages can inherit this variables and methods which are specified with protected access modifier. Okay, that is the difference between the protected and default, guys. Protected is an extension version of the default where it allows the child classes outside the package to access the protected access modified specified variables and methods. Okay, hope you understood this, guys, how the protected access modifier works and how it is different from the default access modifier, which I explained in the previous video. So that's it, guys. In the next video session, I'll explain the first non-access modifier, okay, that is static non-access modifier. Okay, how to use static non-access modifier in Java. I'm going to explain this in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 182 of Java for Tester series, that is static non-access modifier. Static non-access modifier in Java can be used with variables and methods. Okay, static non-access modifier in Java can be used with variables and methods. And we cannot use, okay, the static non-access modifier cannot be used with classes, guys. We cannot use this static non-access modifier with classes. If you try to use this static non-access modifier with classes, you will get a compiler error. Okay, you'll get a compiler error if we try to use static non-access modifier with classes. But we can use static non-access modifier with variables and methods. Before I explain how to use this static non-access modifier with variables and methods, let me first show you how we will get this compiler error on using the static non-access modifier with classes. Okay, why we cannot use static non-access modifier with classes, I am going to show you first. For that, guys, this is a Java project. Under this Java project, create a class. Name this class with any name. I am giving car here. Finish. Okay, by default there is no static non-access modifier specified before this class. So what I will do is I will try to add a static non-access modifier here. Immediately after adding this static non-access modifier, okay, before this class, I'm getting a compiler error. Okay, I'm getting a compiler error saying that illegal modifier. You cannot use this modifier with the class. Okay, you can use other modifiers, but you cannot use this static non-access modifier with the class. So if I remove that, you see, things are working fine, right? Things are working fine. So static non-access modifier cannot be used with classes. Okay, it can only be used with variables and methods. And the reason for that you will be knowing soon. Okay, in this video session you will understand why we cannot use static non-access modifier with classes, guys. Okay, why we cannot use static non-access modifier with classes, we will understand. Fine. Now, guys, let me show you how to use this static non-access modifier with variables. Okay, how to use static non-access modifier with variables? Let me explain now. So before I explain how to use this static non-access modifier with variables, let me explain you few things. So variables in Java can be categorized into different types. Okay, one is local variables, other one is instance variables, and then we have other variable types, that is static variables. Okay, there are three types of variables in Java, guys. One is local variables, another one is instance variables, and another one is static variables. If you use this static non-access modifier with variables, they become static variables. Okay, the variables will become static variables when you use this static non-access modifier with them, right? So in order to understand the static variables in a better way, you have to understand the differences between these local variables, instance variables, and static variables. Okay, let me explain you the differences between this local, instance, and static so that you can understand the static variables better. Fine. So inside this class, let me create a method, guys. Okay, public void some method x. Just creating a method. Okay. So first I will explain what is a local variable. Local variable is a variable which is created inside the methods, guys. Okay, if you create some variables inside the methods, that variables are known as local variables. So if I say int a, okay, this is a variable, guys. Okay, a is a variable here, and this variable is created inside the method. So this variable is known as local variable. Okay, but what if I create a variable directly under the class? Okay, outside the methods and directly under the class, if I try to create a variable, let's say if I create something like int b here. Okay, what is this variable, guys? This variable is known as instance variable. Okay, directly under the class, but outside the method is known as instance variable. Now, if I create another variable int c and I specify this variable with static non-access modifier, this variable will become static variable, guys. Okay, a variable which is created directly, okay, a variable which is created under a method is known as local variable. A variable which is directly created under the class but outside the method is known as instance variable. A variable which is directly created under the class and outside the method and also specified with static non-access modifier is known as static variable. Okay, now you understood, right, what is a static variable? Static variable is a variable which is directly created inside the class. Okay, directly under the class we are creating this static variable, right? Static variable is a variable which is directly created inside the class, outside the methods, and specified with static non-access modifier. Such variables are known as static variables, guys. Okay, such variables are known as static variables. Okay, there is small difference between the instance variables and static variables, guys. Both these instance variables and static variables are directly created under the class, right? Outside the method, inside the class, these two types of variables are created directly under the class and outside the methods. But the one which is not specified with the static non-access modifier is known as instance variable. The one which is specified with static non-access modifier, such variables are known as static variables. Okay, so static variables are the variables which are directly created inside the class, outside the methods, and specified with static non-access modifier. Such variables are known as static variables. So you understood what exactly the static variables are now, right? And how the static variables are different from the local variables and instance variables. Fine. Now let's move to the next one, that is memory. Okay, let's talk about the memory, guys. Fine. So here I mentioned there are two types of variables. One is instance variables and static variables, right? Okay. So let me take a new one to explain this stuff. Okay. So memory allocation, static variables and memory allocation. I am going to explain this. Static variables and memory allocations I am going to explain. Okay. There are two types of memory, guys. Okay. There are two types of memory allocations that are generally done. One side we have class memory. Other side we have the object memory. Okay. There are two types of memory allocations. One is class memory, another one is object memory. Okay. Class memory and object memory. Fine. So when you create some instance variables, okay, when you create some instance variables, they will be saved in or stored in object memory. Okay. And when you create static variables, they will be created in class memory. Okay. They will be stored in class memory. Instance variable, they will be stored in object memory, and static variables, they will be stored in class memory, guys. Okay. So let me show you practically how this happens in real time. Okay. Let me show you how this static variable storage in class memory and instance variable storage in object memory, okay, will happen. Fine. So for this, let me take a fresh example. So let me delete this car class for now. I'll create the car class again. Just to explain how these static variables are stored in the class memory and how these instance variables are stored in the object memory. Okay. I'm going to create the car class again. So let's create a car class again. So right click new class. I'll name this class as car. Click on finish. The car class got created, guys. And inside this car class, let me create some instance variables and static variables. Okay, some instance variables and static variables let me create. So let's start with some int cost, which is an instance variable, and other one is like I will create some static other instance variable, let's say mileage, and one static variable saying static int wheels, okay, is equal to 4, like this. Okay, there are two normal variables, that is instance variables. These two are this is an instance variable. Okay, we are directly creating these variables under the class, right? That's why this variable is known as instance variable, and this variable is not specified with static non-access modifier. Hence, this is an instance variable, right? Similarly, the second variable is also same. This variable is also directly created under the class and without specifying the static non-access modifier. So hence these two variables are instance variables. But coming to the third variable, okay, it's specified with static non-access modifier and it's created directly under the class, okay, and outside the methods. So hence this variable is known as static variable. Fine. So now guys, what will happen? I'll explain you, okay, how these things will happen and all, everything I will explain you now. So now let's create another class. Let me call this class as demo class. Click on finish and move this to somewhere so that you can see both the classes. Now create some main method inside this public static void main string of args. Okay, string of args inside this main method. So I'll create an object. Okay, I will create an object for this car class. In order to access this variables of this car class, I would like to create an object for this car class from a different class. Okay, in order to access the variables of this car class from a different class known as demo class, I would like to create an object for this car class. Say car, okay, car Benz is equal to, okay, new car. Car Benz is equal to new car. Fine. I just create an object for the car class. And using this object reference, if I say Benz dot cost, okay, Benz dot cost is equal to some 30 lakhs. 30 lakhs. And Benz dot mileage, okay, Benz dot another variable, that is instance variable, that is mileage, is equal to Benz dot mileage is equal to, I'll give something like some 12 kilometers per liter. Fine. Similarly, I'll create another object for the car class, that is Benz RD is equal to new car, RD is equal to new car, okay, car RD is equal to new car, RD dot cost is equal to some 40 lakhs, and RD dot mileage is equal to some 10 kilometers per liter. Fine. So here what's happening, guys? What's happening? So I created another class, and inside one of the method is one of the method of the another class. I just created an object for this car class. Two objects I created. So in the memory, what will happen in the memory is, when you create this car class, guys, okay, in the computer memory, let's assume that this is a computer memory. Okay, let's say this is a computer memory. Using this program, guys, I am going to show you how the memory will be allocated. Okay, how the memory will be allocated for these variables, and how the memory will be allocated for this static variable and all those stuff. Okay, I'm going to show you. So this is the entire computer memory. Let's say in this computer memory, when you create a class, okay, when you create a class, here we created a class known as car. So for this car class, okay, in computer memory, inside the computer memory for this car class, some memory will be allocated. Okay, this is car class memory. So on the top we said there are two types of memories allocations, right? Class memory and object memory. Okay, so this is a class memory, car class memory. So in this car class memory, the static variables will be stored. Okay, inside this car class memory, which variables will be stored? Static variables will be stored. Okay, static variables will belong to the class memory. I will explain the reason why, okay, afterwards. For now, just understand the static variables will be stored in the which memory? Class memory. So this static int wheels is equal to 4. That means wheels is equal to 4 is stored in the which memory? Class memory, that is car class memory. That's fine. After that, we have another class, and we have a method inside this another class. Under the method, inside the method, we created few objects for this car class, right? The first object of the car class, the second object of the car class. And using this object reference of the, okay, using this first object reference, we initialized cost and mileage. Okay, this instance variables, in order to initialize this instance variables, you have to create an object, right? So Benz.cost, Benz.mileage is equal to 12. Here also another object, using that we created. So when this object creation statement is executed, car Benz is equal to new car, in the computer memory, some memory will be allocated. Okay, some object, okay, object, this object memory will be allocated, and this object can be referenced using Benz. Okay, Benz is the object reference. Car class object, this is car class object, and we have to access this. We can refer to this object memory location using this Benz object reference. And in this first object that got created, these two values, okay, the instance variables will be stored. That is, inside the Benz.cost is equal to 3 lakhs. That means cost is equal to 3 lakhs. Another one is mileage. Mileage is equal to 12. Okay, this is the first object to which Benz object reference is referring to. Okay, so we have this cost and mileage. This cost and mileage are instance variables. So they got stored in the which memory? Object memory. Okay, This is class memory. In the class memory, static variables are stored. But coming to the object memory, which variables are stored? Instance variables. Cost and mileage are instance variables. Similarly, we created another object for the car class, and we have used object reference as OD to refer that object, right? So another memory will be allocated. Another object memory. This is another object memory. Okay. And to access this object memory, we have to use object reference known as per the program, we have to use AUDI. Okay, AUDI, AUDI, AUDI. Fine. And cost and mileage, instance variables. Okay, these are the instance variables for this particular object. Cost is equal to cost of AUDI, that is 40 lakhs, let's say, and mileage is equal to some 10 kilometers per liter. Okay, these two are object memories, and this one is a class memory. So class memory, static variables will be stored. Wheels in this program is a static variable, hence that is stored in the which memory? Class memory. And other variables are instance variables, okay, which will be stored in the object memories. So how many objects you create, that many times you can store them. Okay, fine. And we have another name, guys. Okay, for class memory, we can also call this class memory as common memory. Okay, whereas object memory, we can call object memory as specific memory, specific to that object. Okay, object memory means specific to that object. That's why we can call this object memory as specific memory. But coming to the class memory, it is a common memory. Okay, this object is also specific object memory or specific memory. Okay, so this is the object memory or specific memory. This is also object memory or specific memory, and this is a class memory or common memory. Why I'm saying common memory, guys? Because static variables will store the common, okay, common values. Common values, if you want to in Java programs, if you create some variables and if you want to store some common values, in that case you have to use static variables, guys. So the example is car here. Okay, almost all cars, okay, will have the same number of wheels. Okay, either it may be Benz car or Audi car, whatever it is. Okay, they both will have the same number of wheels, that is 4, right? Benz car will have 4 wheels and Audi car will have 4 wheels. But coming to the cost and mileage, these two variables are not common for all the cars. Okay, this variable is common for all the cars because all the cars in the market have 4 wheels. But coming to the other variables, that is cost and mileage, they change from car to car. Cost of Benz car will vary from the cost of the Audi car. Cost of the mileage of this Benz car will vary from the mileage of the Audi car. Okay, both will not be same. But coming to this wheels, it's common. Okay, so class memory is known as common memory. Okay, that's why wheels is equal to 4. If you want to store some common values, okay, common value into the variables, then you have to declare that, you have to state that variable with static, okay, non-access modifier. You have to specify static non-access modifier before the variables, which generally store the common values like this wheels. Okay, wheels of the car is equal to 4. And other variables where you will store variable value, okay, the value that actually changes from object to object. Such kind of variables, you have to make them as instance variables so that they will be stored in the object memory or specific memory. Okay, it's specific to that particular object, that's why we call it as specific memory. Fine. So there is one more name for this object memory and specific memory, guys. Okay, so we can call them as instance memory. Okay, the memory at which this instance variables will be stored is nothing but instance memory. Okay, that's nothing but instance memory. Whereas this memory is known as static memory. The memory where the static variables will be stored is known as static memory. So the common memory, class memory, static memory is same, whereas object memory, specific memory, or instance memory. Okay, we can call with different names, guys. These memories we can call with different names. At a high level, this is a class memory and other things are the object memories. Okay, class memory is the common memory, whereas object memories are the variable or specific memories. Fine. So guys, this is the memory allocation. Okay, this is how Java will store the static variables into the common memory, that is class memory, whereas instance variables into the specific memory is known as object memories. Okay, object memories. Fine. So when we have to use the static variables, guys, when you have the common value to be stored, okay, across here, if you don't make this as static, guys, okay, int wheels is equal to 4. Let's say this int wheels is equal to 4 is there, okay, or else int wheels is equal to there, okay. Here, if you make this as instance variable, okay, if you make this as instance variable, if I make this wheels also as instance variable, what will happen? You have to repeat the code, guys. Okay, your code will get repeated. That is for each and every object. That is for Ben's object, you have to say Ben's dot wheels is equal to 4. Okay, for Audi object also, Audi dot wheels is equal to 4. Same value, guys. You see, the wheels is equal to 4, wheels is equal to 4. No matter how many objects you create, every time you have to specify Ben's dot wheels is equal to 4, Audi dot wheels is equal to 4. Okay, any other things like Mercedes dot wheels is equal to 4. Okay, Porsche dot wheels is equal to 4, like that. Okay, so instead of doing that, instead of storing the common value into the instance variables, Java is allowing you to create some static variables. Okay, if you make this wheels as static, and simply if you say wheels is equal to 4, okay, this wheels is equal to 4 will be there for each and every, it's a common memory, guys, right? For example, system.out.println, simply will say, instead of saying Ben's dot wheels is equal to 4, okay, 1 minute, control space, okay, system.out.println. In this, instead of we saying Ben's dot wheels is equal to 4 every time, and Audi dot wheels is equal to 4 every time, since it is a common memory, since this wheels is stored in the common memory, static specified wheels is stored in the common memory, simply we can say the number of wheels in Benz is, how to access, guys, how to access this static variables, how to access the static variables. The process of calling or accessing this static variables is by using the class name, because these static variables will belong to the class. So how to access this static variable? Since this static variable belongs to this class memory, we have to use the class name to which this static variable belongs. That is, class name is car here. So car dot wheels, that's it. Okay. So for this RD also same thing. For RD also same thing. System.out.println. Okay. The number of wheels in the RD is car.wheels. Okay, using the class name. So here, in order to access the instance variables, we have to create an object for the car class, and using that object reference, we have to call, right? Because this variables, instance variable belong to the object memory, in order to access them, we have to create an object for this classes. But coming to the static variables, they belong to the class memory. So we have to use a class name to access them. Here objects are used for accessing the instance variables. Here class name is used for accessing the static variables. Okay, fine. This is another difference, guys. So let me write down. So how to access the accessing, I'll call it as accessing instance variables and static variables. Okay, the way of accessing the instance variables and static variables is completely different. That is, in order to access the instance variables, okay, in order to access the instance variables, that is object variable. Instance means object, guys. Okay, another name for object is instance. Instance is object. Okay, accessing instance variables and static variables. So in order to access the instance variables, we have to create an object. We have to create an object for the class. Okay, using object references, we have to access this instance variables. But coming to the static variables, using class name we can access. Okay. In order to access the static variables, we have to use class name. But in order to access the instance variables, we have to use object references. The same thing happened here, guys. Okay. Let's start fresh. Let's access this instance variables. For that, first we have to create a class. Let's say Benz is equal to new. We have to create an object. Okay, for this car class. In order to access the instance variables, we have to create an object for the car class. Okay, and using that object reference of that particular class, Benz dot cost, okay, is equal to, I'm accessing, guys. Benz dot cost is nothing but accessing. Benz dot cost is equal to some 3 lakhs I am giving, right? And Benz dot mileage is equal to some 12 kilometers per liter. For printing it out also same thing. So for printing also we have to say Benz dot cost. Using the objects, we are accessing the, using the objects. In order to access this instance variables, we have to create objects and then access using their object references. But coming to the static variables, we have to use a class name. Okay, here we have used object references. Okay, but here we have to use class name to access this static variables. That is, what is the class name? Static variables class name is car. Okay, car dot wheels. You see, you are immediately getting. Fine, this is how we have to do, guys. Okay, this is how we have to access the instance variables by creating the objects, static variables by using the class name. Okay, directly by using the class name like car dot wheels, because these wheels belong to the class memory. So we can simply use class name to access the wheels which is stored in the class memory. But coming to the cost and mileage, they are instance variable. They will be stored in the object memory. So in order to access them, we have to create an object, and using that object reference, we have to access. Okay, that's how the things differ, guys. Next thing here is, let's run this and see whether we are getting an output or not. Right click, run as Java application. Okay, you see, we got the output. Okay, so does that mean that we cannot access the static variables using the object references? It doesn't mean like that, guys. Okay, what I mean to say here is system.out.println. If I say Benz dot wheels, I'm able to access. Okay, so this wheels is a static variable. I'm able to access with the object reference. But you see, there is a kind of warning being displayed here. This is a static field. This is a static field or static variables. In Java, we generally call these variables as fields, guys. Okay, so we can either call them fields or variables. Okay, it's up to you. So here the static field car.wheels should be accessed in a static way. Okay, it's not giving a compiler error. Okay, it's not giving a compiler error, but it's giving a warning saying that this wheels is a static variable which belongs to the class memory. So in order to access them, you have to access in a static way. That is using the class name, that is car.wheels. This is the proper way of accessing. Okay, this thing is not recommended, guys. Okay, even though it's possible, it's not recommended. Fine. So that's something about the memory allocation and how to access the static variables and the instance variables. Fine. And I explained you the static variables generally store the common memory, common values, whereas instance variable, object specific values, they will be storing. Fine. Now next thing is, this is all about the variables, guys. Okay, how we can use static non-access modifier with variables. So far I explained those things. Next thing is that we can use this static non-access modifier not only with variables or fields, but also with methods. Okay, so let me create a method, public. Okay, public some void some method x. This is a normal method, guys. Okay, this is a normal method. This method belongs to which memory, guys? Just tell me now. Okay. This is a non-static method, right? Non-static method, you can say. It doesn't have any static non-access modifier specified in this method. So this method is a non-static method. It's a normal method. Or you can call this as instance method. There is no name as instance method, but I'm just telling you. Okay, this belongs to the which memory? Can you tell, guys? Since it's not static, this belongs to the class memory. Sorry, this belongs to the object memory. Okay, non-static methods are object memory. But coming to the another way method, public static void some method y. Okay, public static void method y. This belongs to, this is a static method, guys. Okay, this method y is a static method which belongs to the class memory, common memory. Okay, if you want to create some common methods across the objects, okay, then you have to create such kind of methods which are specified with static non-access modifier. Okay, they belong to the which memory? Class memory. Okay, the way methods which are not specified with the static are known as non-static methods. They belong to the object memory. Fine. Okay, so static non-access modifier not only can be specified with variables but also with the methods. As you can see, this method y is specified with static non-access modifier. Okay, fine. And there is one rule, guys. With methods, guys, there is one rule, that is static methods. Okay, this method y is a static method, right? Static methods can only access static stuff. Okay, there's something known as static methods can only access static stuff. I'm going to explain you what exactly that does mean. Okay, for example, if I say system.out.println, okay, if I say cost, if I directly use a cost here, immediately you are getting a compiler error. Why? Cost is a non-static, right? Static methods, method y is a static method. Inside the static methods, you can only access the static stuff, but cost is not a static. It is a non-static, non-instance variable. It's normal variable, okay, which is not specified with static non-access modifier. So in case you will get the compiler error, change cost to static, then only you can access this cost inside this static method. If this cost is a static variable, then only you can access. Okay, or if you try to use this mileage, which is also an instance variable, it's not a static variable. This case also you will get the same compiler error. Okay, because mileage is a instance variable but not a static variable. Only the static stuff can be accessed inside the static methods. Fine, I cannot use that. But coming to the wheels, if I try to copy paste the wheels here, system.out.println wheels here, there is no compiler error because wheels is a static variable. Okay, static methods like this can access the static stuff, can only access the static stuff. Wheels is a static variable, hence you can access. Okay, but if you try to access some non-static stuff, that is instance variables or some instance methods or okay non-static methods, you will get some compiler error. Okay, this applies, same thing applies for the methods also. For example, here we have some method x. I'll create another method, say method z. Okay, I'll mark this method z as, specify this method z as static method. In such kind of cases, guys, if I try to access this non-static method from here, that is method x, okay, method x like this, I'll get a compiler error because static methods can only access the static stuff. Okay, method x is not a static method, it's a non-static method, hence you are getting compiler error. What if I use this method z here? If I try to call this method z from this static method, I'm not getting any compiler error because method z is a static method. But there is a way, guys. Okay, but still there is a way. So before showing you that way, let me explain you one more thing, that is this void is a non-static method, right? Normal method, instance method or normal method, non-static method. From this I can access anything. There are no rules for the non-static method. Okay, if I say system.out.println, I can use cost, okay, which is a non-static, and in normal method there are no rules, guys, but in static methods only there are rules, that is Static methods can only access the static stuff, but non-static methods can access any type of stuff. It can be static, or it can be non-static. It can be anything. Okay, anything can be accessed from the non-static methods. You see, if I can even use static variable also. These are instance variables. You see, I'm not getting any compiler error from the normal method. But in static methods, they can only access the static stuff, guys. And coming to the method calling also, I can call the method Z directly from this non-static method, and method Y, which is a static method, also I can call. Okay, there are no differentiations. Okay, but coming to the static methods, they can only access the static stuff. Okay, if you try to access some non-static stuff like instance variables or some non-static methods from the static method, you will get the compiler errors. But there is a way, guys. Okay, there is a way to access the non-static stuff also from the static methods. That is, in order to access the non-static stuff like instance variables and non-static methods from the static methods, we have to create an object, guys. Okay, we have to create an object for the car class, then only we can access. So that is car, some car one is equal to new car, and using this object reference, that is car one. Okay, I can say system.out.println car one dot cost. You see, I'm able to access using the, by creating the object, I can access the non-static stuff inside the static methods, but directly you cannot do that. Okay, system.out.println car one dot mileage, like this. Even I can call the non-static methods also. That is a non-static method. One of the non-static method is method X. I can call that is car one dot method X. Okay, which is a non-static method. I'm calling from the static methods. Okay, so for directly under the static methods, if you want to access this, if you want to access the variables and methods directly, okay, those variables and methods should be of static type. Okay, static stuff. But other than that, if you try to access the non-static stuff like instance variables and non-static methods from the static methods directly, you will get the compiler errors. To avoid that compiler errors, we have to create an object, okay, for the class, and then using that object reference, we have to access them from the static methods. So guys, so this is all about the static non-access modifiers and how you can use this static non-access modifier with variables and methods in Java. Okay, fine. So that's it, guys. In the next video session, I'll explain the next non-access modifier, that is final non-access modifier. Okay, so that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 183 of Java for Tester series, that is final non-access modifier. Final non-access modifier in Java can be used with different things like variables, classes, and methods. So we can use final non-access modifier with variables, classes, and methods. So what will happen when you use final non-access modifier with variables? So let's start with variables, guys. So if you use this final non-access modifier with variables, the result will be you can only assign the value to the variable once. Only once you can assign the value to this variable, guys. Okay, you cannot assign the value multiple values to the, you cannot assign multiple times. Okay, you cannot assign values multiple times to the variable which is specified with final non-access modifier. So to help you in understanding this thing, okay, let me first start explaining with a normal variable. Okay, so I will first explain how the normal variable will behave. Then afterwards, I will assign this final or specify this final non-access modifier with variables and show you how it differs. Fine. So I'll create a normal variable int a is equal to 5. Now in the next step, if I say int a is equal to 9, what will happen, guys? Will this work? Yes, it will work. You see, Java is already accepting it. I'm not getting any compiler error. Okay, initially I'm assigning some value, say a5 to the variable a, and then in the second step, I'm assigning another value to the same variable, okay, a, You see, like this, I can assign any number of times. A is equal to 11, A is equal to 15, like this. Okay. If I say system.out.println A, what will be the value, guys? So what will be printed in the output? The answer is the latest assigned value to the same variable A will be printed. That is, in the output, 15 will be printed. Let's see whether we are getting the expected outcome. Run as Java application. As you can see, the latest assigned value will be printed. But what if I simply specify this variable A with final non-access modifier? You see, I am getting compiler error. Okay, the reason here is the variables which are specified with final non-access modifiers can be only assigned once. You can only assign a value to variable of final non-access modifier only once, guys. Only once. Okay. If you try to reassign or assign again different values, that will not work. Okay. If you try to assign again, it will not work, guys. You see, that's why we are getting these compiler errors. The final cannot be assigned. Okay. The final local variable cannot be assigned. The same compiler error everywhere. Okay. The reason here is final. Okay. Only once you can assign, guys. So what if I don't assign in the first step? I don't assign the variable A in the first step. So here A is there. So what will happen? Only once it will allow. You see, in the second step, it is allowing, guys. Okay. I'm not assigning the value to this variable in the first step. But in the second step, I am assigning, it's allowing. Here, since this is the first time, it is allowing. But here, not allowing, not allowing. We are getting the compiler error. Okay, that's the reason, guys. If you specify any variable with final non-access modifier, you can only assign the value to that particular variable once. Only once you can assign, guys. Okay, that's the final assignment to that particular variable. So that's about the variables, guys. Now coming to the other thing like classes. What will happen if you specify this final non-access modifier with classes? Let me explain. So if you assign final non-access modifier to the classes, these classes cannot be inherited. Okay. Okay. So class specified with final non-access modifier cannot be inherited by other classes. So there cannot be any child classes. You cannot create child classes for the classes which are specified with final non-access modifier. So let me practically show you. Let me delete this. Let me create a class, say car class. Okay. And finish. So I'll not create anything inside this car class, but I'll create another class, new class, and name this class as Ben's class. Okay, finish. So I'll move it to the right so that you can see both the classes together. Here we have two classes, guys, car class and Ben's class. I want to make this Ben's class a child class of this car class. So car class is going to become the parent of this Ben's class. So how to do that? Ben's extends. There's a keyword known as extends keyword in Java, using which we can inherit parent class. So car, Ben's extends car. Now, after writing this extends car, the car class has become the parent of the Ben's class, and Ben's class has become the child class of the car class. Okay, this is possible. Okay, in general, we can make a class a child class of another class. This is possible in general. But what if I add this final non-access modifier before this car class? Okay, simple, guys. After I saved this, after I added this final non-access modifier and saved this, as you can see, I already got a compiler error here. It says that the type Benz cannot subclass the final class car. So the classes which are specified with final non-access modifier cannot be inherited or extended. You cannot create child classes for the classes which are specified as final. Okay. So if you remove the final, things will work. Okay. If you remove the things are working. But if once you add the final, you cannot create the child classes for the classes which are specified as final. You'll get the compiler errors like this. Okay. So that's about the classes, guys. Now let me explain about the third item, that is methods. What will happen when you use this final non-access modifier with methods? So methods, if you try to use final non-access modifier with methods, you cannot override. Okay. You cannot override the methods. You cannot override the methods if you specify the final non-access modifier with methods. Let me show you. So here I'll remove the final for now from the class. So let's say this is the parent class and this is a child class. Okay. Bench class is extending the parent class car class. Okay. Let's say what is overriding, guys? Overriding means if the parent class and child class have the same method, then the method in the child class is said to override the method in the parent class. Okay. As explained in one of the previous videos, if we have same methods in the parent class and child class, then the method in the child class is said to override the method in the parent class. So let me create some method, guys. Public void, okay, some start car method, okay, start car method. Inside this method, I'll write some print statement. System dot out dot println car started, I will say, okay. Here also, I'll create the same method, guys. I'll copy paste the same method inside the child class. As you can see, the same method is being copy pasted here in the child class. But here, I'll say Ben's car started. Just a print statement is different. But still, this method is said to override this method in the parent class because the method in the child class is having the same name and okay, same name and same parameters kind of thing. From the when you compare that method with the parent class, both these methods have the same name and same parameter types. Fine. Now in this case, this method in the child class is said to override the method in the parent class. This is now possible. Okay, in general, a child class method can override the parent class method. That's possible. Okay, but what if I make this? I just provide this final non-access modifier before such methods in the parent class. Okay, the same method in the parent class is specified with final non-access modifier. Now, if I save this, immediately you will get an error saying that you cannot override. Okay, so cannot override the final methods in the parent class. Okay, the child class cannot override the methods, okay, in the parent class. If they are specified with, if these methods are specified with final non-access modifier, you cannot override them. Overriding is not at all possible. So what you will do, guys, you have to remove it. There's no other way. Okay, if a parent class is specifying some methods as final, then the child class cannot override such methods. All the other methods it can override, but except the methods which are specified with final access modifier, all the other methods can be overridden. But the method specified with final non-access modifier in the parent class cannot be overridden by the child class. Okay, this is what happens with the methods, guys. That's how, guys, final non-access modifier when specified with variables, classes, and methods will change the behavior like this. Okay, with the variables, you can only assign once. With the classes, child class cannot be created. With the methods, child class cannot create overridden methods for the parent class. Okay, of the parent class if the methods in the parent class are specified as final. Okay, so this is how the final non-access modifier works with variables, classes, and methods in Java, guys. So that's it, guys. In the next video session, I'll explain the next non-access modifier, that is abstract non-access modifier. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 184 of Java for Tester series, that is abstract non-access modifier. Abstract non-access modifier in Java can be used with two things, that is methods and classes. And this abstract non-access modifier cannot be used with variables. That is, if you try to specify this abstract non-access modifier with these variables, you are going to get a compiler error. Okay, compiler error will come. So let me practically show you what will happen on using this abstract non-access modifier with variables. So I am going to show you the compiler error practically. For that, in this Java project, let's create a new class. I'll name this class as some demo class. I will select this public static void main option also to auto generate while creating the class. I'll clear this out and then I'll try to create a variable. Let's say int a. Here a is a variable, guys. I'm going to specify this variable with abstract non-access modifier. On trying to do so, I immediately got a compiler error saying that illegal modifier for this variable. Okay, so it's not possible. Okay, we cannot specify abstract non-access modifier with variables. That's not possible. You are going to get this compiler error. Fine, that's fine. Let's delete this. Now, moving ahead, this abstract non-access modifier can be used with methods and classes only. So what will happen when you use this abstract non-access modifier with methods, and what will happen when you use this abstract non-access modifier with classes? Let's find it out. Okay. To get started, let's find out what will happen when you specify this abstract non-access modifier with methods. So before I practically show you what will happen, let me explain. Okay. So on using this abstract non-access modifier with methods, okay, on using abstract non-access modifiers with methods, Java will not allow you to, okay, Java will not allow you to have the method body. That means if there is a method and if you have specified this abstract non-access modifier with that method, you cannot create the method body, guys. Okay, only method head will be there, body will not be there. So let me, for example, guys, let's say some method is there, public void method A. There is some method known as method A here, and up to here is a method head, guys, and this is a body section. Okay, you can write some logic inside this method body. This is the body section. Whatever I'm highlighting now, starting from the starting curly brace and ending till the ending curly brace. This complete thing is a method body. Okay, and if you specify this method with abstract non-access modifier type, Java will not allow you to have this method body. You have to create something like this. Okay, method without method body will be there. If you specify something with abstract, method body will not be there for the methods. So let me practically show you that. For that, let's create a class. I'll name this class as some 1C. Okay, 1C. I'm just giving some random name for the class, that is 1C. Click on finish. Inside this 1C class, okay, I'm going to create a method. I'll create a normal method, guys, public void some method A, and I'll write down system.out.println inside method A of 1C. Okay, 1C class. That's fine. I'll create another method, public void method B. And inside this also, I'll create some statement inside method B of 1C class. Right? Now, guys, these two methods are the normal methods. Okay? These two methods are the normal methods. Now, I'm going to show you what will happen when you specify this abstract non-access modifier with methods. Okay? Here we have two methods. One is, these two methods are normal methods, but I'm going to choose the second method, guys. I'm going to specify this second method as public abstract void method B. So what's happening, guys? When I specify this method with abstract non-access modifier, I am immediately getting a compiler error. Let's read that compiler error. What does this state? This compiler error states that abstract methods do not specify a body. Here, as I explained, if you mention some method with abstract non-access modifier, that method should not have the body. Here we have the body from here to here. So simply remove this body, guys, and end this method with a semicolon. Okay, this particular method is now without any body. That's fine. But still, after resolving the problem also, I am getting a compiler error. Let's find out whether this compiler error is same or not. You see, we are getting another compiler error, which is different from the previous message. Okay, this states that abstract method B in type 1C class can only be defined by an abstract class. What does this mean? This means that if there is a class This is a class, right? If there is a class which has at least one abstract specified method, in that case, the class also should be specified with abstract. This is a rule, guys. Okay. First rule that I explained here is, if I specify some method with abstract non-access modifier, okay, then that method should not have any body. We have cleared out that rule. Now, this particular method which is specified with abstract non-access modifier doesn't have any body. Okay, the first rule is satisfied. Coming to the second rule, if a particular class has at least one abstract non-access modifier specified method, in that case, that class should also be specified with abstract. Public abstract class 1C. You see, the compiler error got resolved. That means in any class, if you have at least one abstract non-access specified method, okay, in that case, you have to specify the class with abstract. Okay, this abstract keyword should come before the class keyword. Okay, abstract, public, abstract class, class name. Okay, since this particular class has at least one abstract specified method, then we have to mention this class also with abstract. Then only the compiler errors will be resolved. Fine. So that's fine. The methods, the classes having at least one abstract non-access modifier specified method should be specified as abstract. That's fine. That's the second rule. But is it compulsory? For example, if you don't have this abstract method, okay, will I get any error? No, I will not get any error. Okay. So abstract classes, okay, it's not mandatory for the abstract classes to have the abstract methods. Okay. The reverse is not correct. What I mean to say here is, inside this class, there are no abstract specified methods now, but this class is specified as abstract. It's allowed in Java, guys. Okay. In abstract classes, we can have normal methods. Okay. It's not compulsory to have an abstract method inside the abstract class. Okay. But if there is a class which has some abstract specified method, that class should be specified as abstract. Okay. If you don't specify that class with abstract, you will get the compiler error. Okay. You have to make it abstract because this particular class has at least one abstract specified method. Okay. Now we are done with the three rules, right? So, but guys, now I'm going to show you why we are specifying this abstract non-access modifier with classes. Okay. So if you specify abstract non-access modifier with methods, that particular method should not have any body, and that particular class in which this particular method is there, that should be specified with as abstract non-access modifier. So why we have to specify this abstract non-access modifier with classes? Okay. The reason here is, the simple reason here is, if you want a particular class, not to be implemented completely. Okay. If you don't want to implement the entire class, okay, you are creating a class, guys, and in that class, whatever the logic you are writing, you don't want to implement the complete logic. You want to implement some portion of the logic, and you don't want to implement some portion of the logic, like that. Okay. Partial implementation. If you want to create some partial implementation inside a class, then the answer here is, you have to specify that class with abstract, so that it allows you to write the complete partial logic. Okay. You can implement few methods, you don't have to implement few methods. Okay. This particular class allows you to partially implement the logic. If you don't want to implement complete things, then simply create a class as abstract and do whatever you want. You can partially implement. Okay. Whatever you want to implement, you can implement. Whatever you don't want to implement and you want to simply state, okay, instead of implementing, here you see method B is not implemented. It's just stated this particular class should have this method, but it's not implemented. Okay. Such kind of situations, when you get such kind of real-time situations where in a particular class you want to implement few methods and you don't want to implement few methods, okay, you can specify that class with abstract class, and whatever the methods you want to implement, you will provide it normally, and whatever the methods you don't want to implement, you will specify them with abstract non-access modifier. So this is the purpose of the abstract classes, guys. But guys, But guys, here I am doing the partial implementation, right? One of the method is implemented, and as an example, one of the method is implemented here and another method is not implemented. So who will implement this non-implemented method? There is a general question, right? That is a general question everyone will get. Who will implement the non-implemented method here? That is abstract method will be implemented by whom? The answer for that is the child classes of this class have to implement this abstract method. Even though this class is partially implementing the logic, whatever the unimplemented portion or non-implemented portions of this class are there, have to be implemented by the child classes of this class. So how to find it out? Let's create a child class. Right click on this and select a new class and name this class as something like 2C. Okay. I'm giving some random names, guys. 2C, and click on finish. This is another class. Okay, 2C is another class. I want to make this 2C a child class of this 1C. How to make that, guys? You have to say 2C extends 1C. Now, once it extends, once this class extends this another class, this class will become the parent class, and this class will become the child class of that parent class. Immediately, guys, after I extend this parent class, that is 1C, after this 2C class extends this 1C class, immediately I'm getting a compiler error here. Why I'm getting the compiler error? Java is communicating to you via this compiler error. Java is communicating to you that you have to implement the unimplemented methods of the parent class. Okay, Java will state that in your parent class there are some unimplemented methods that you have to implement. Okay, let's read that compiler error so that you will understand what I am saying. Hover the mouse on this child class of this 1C parent class which has unimplemented methods. You see now it states that the type 2C. Okay, that class, the child class must implement the inherited abstract method, that is method B, which is unimplemented in the which class? 1C class. Whatever I said is correct, right? So you can simply hover the mouse and say add unimplemented methods, or you can simply copy paste this one also. That's fine, up to you. Okay. You see, I am implementing it. I have to remove this abstract, guys. Okay. Otherwise, this will become again abstract method. So public without abstract void method B. You see, the error got resolved. System dot. This is one way, guys. Okay. Inside method B of 2C. Okay. Now the child class of this 1C parent class is implementing the unimplemented method. Here, parent class is the abstract method, abstract class. Okay. Parent class is the abstract class which has some abstract method. That abstract method of the parent class is being implemented by its child class. Okay. So here partial implementation is done. Now this child class, with the help of the child class, we achieved the full implementation, right? Whatever that is not implemented in the parent class is implemented here. That's fine. But what if I don't even want to implement this unimplemented method in the child class also? I don't want to implement here also. What I have to do, guys? How to overcome this problem? In the child class also, I don't want to implement this unimplemented method. Okay. So let's create something like public void method C. Okay. In the child class. Okay. System dot. It's a normal method, guys. Okay. You can have its own, this child class can have its own methods inside. What do you call method C of 2C class? That's fine. But I'm implementing some methods in child class, but whatever the method that is unimplemented in the parent class of this child class is not implemented in the child class. That's the reason I'm getting a compiler error here. You must implement, okay, this child class must implement the inherited abstract method of the parent class. Okay, there are only two ways. One way is to implement this method. Okay, implement this method like this, public void some method B. Like this I have to implement. This is one way. If I don't want to implement, this unimplemented method of the parent class, what I have to do next is I have to provide abstract keyword before this class. Okay, again I am providing the same abstract. I'm also making this child class as an abstract class. This is another way, guys. Okay. First option is to implement this unimplemented method in the child class. Second option is to make this child class also an abstract. So what if I make this child class an abstract? How to implement this unimplemented method of the parent class? One see. Again, I need to create another class. This list goes on. Okay. Till you implement this unimplemented method of the parent class. Okay. The child classes. You have to keep on creating the child classes like this. Okay. To implement. Let's say I will create something like 3C. Click on finish. I'll drag it somewhere here. Inside this, I'll say 3C extends 2C. Okay, I want to make this 3C a parent of a child class of this 2C, which is a child class of 1C. Okay, so when I do so, I'm getting a compiler error saying that the type 3C class, that is child class of this 2C, must implement the inherited abstract method of 1C. Okay, here 3C is a child class of the 2C, 2C is a child class of 1C. Since we are inheriting since we are making this a child class of this 2C, and since 2C has not implemented the unimplemented method of this 1C, now the Java is asking you to implement that in the 3C. This unimplemented method of 1C should be implemented in the 3C. Java is asking you to do so. So for the mouse, you can directly say add unimplemented methods. Okay, you don't have to provide that if you don't want to. So system.out.println inside method B of 3C like this. Okay. So there are only two ways, guys. Okay. If you have a child class, if you have a child class whose parent class has an abstract method, that abstract method has to be implemented in the child class. If not, you have to mention that child class as abstract non-access modifier and its child class of the 2C has to implement it. Okay, there are only two ways, either you implement or carry forward to your child class. So this is how, guys, the abstract classes work. Okay, when you specify some class with abstract, then its child classes has to implement that abstract methods. Okay, the child classes of that abstract class has to implement the abstract methods of the parent class. Fine, that's good. Now next thing here is I'll create another class, say new class. I'll name this class as some demo class. I will have this public static void main also. The reason I am creating this class is that I want to create some objects. Okay. So how to access these methods? I want to access method A and method B of 1C. What I have to do, guys? Demo is another class and 1C is another class, right? They are different classes. From this demo class, I want to access these methods of 1C. The general rule here is, in order to access the properties of another class, we have to create an object of that class, right? Inside the demo class, we have to create an object for the 1C, then only we can access these methods. That's the general rule. So, but guys, since this 1C is an abstract specified class, you cannot create object. The rule in Java is that we cannot create objects for the abstract specified classes. Okay. The classes which are specified with abstract non-access modifier cannot be created. Okay, objects cannot be created for the classes which are specified with abstract non-access modifier. Let's try to do so. We'll get some compiler error. So 1C, I'll copy this and paste here. 1C, 1 is equal to new 1C. Let's say I am trying to create an object for the abstract specified class. That is abstract class itself. Okay, when I try to create an object for the abstract class, I'm getting a compiler error saying that cannot instantiate. That means cannot create objects for this kind of classes, which are abstract classes. Okay, this class is an abstract class. You cannot create an object for that. Same thing will happen. Even this child class, that is 2C, is also an abstract class, right? Let's try to create an object for the 2C. 2C, let's say 2 is equal to new 2C. Here also we'll get the same compiler error saying that cannot instantiate. That means you cannot create an object for the abstract classes. Either it is a parent abstract class or child abstract class, it doesn't matter. You cannot create objects in Java for abstract classes. Okay, you have to remember this, guys. And so 3C here is extending 2C. So can I create an object for the 3C? Is 3C an abstract class? No, it's a normal class. So I can easily create. So 3C 3 is equal to new 3C. Okay. So before I create an object here, you have to understand that if I am not able to access this methods of the 1C abstract class or methods of this 2C abstract class, then how I can access this methods of this abstract classes? The only way is to create an object for the child class of this abstract classes. Okay. In order to access the properties of the abstract classes, parent abstract classes, you need to create an object for the child class, which is extending such abstract classes and implementing the unimplemented methods. Okay. So here 3C is the child class of this 2C and 1C, which are abstract classes. You have to create an object for this kind of class. Using that object reference, you can access all the properties of this abstract classes. You can see here. If you can say 3 dot method A. Okay. So method A belongs to 1C, which is accessed. 3 dot method here B, which is implemented in the 3C itself. Okay. You can access. So 1C properties have been accessed properly, right? Abstract class properties have been accessed already. Now using the same object reference, I can also access the properties of this another abstract class, that is 2C also, because 3C is the child of this 2C, which is implementing all the things of abstract classes. So 3 dot method C. You see, even I can access method C of this 2C abstract class. Okay. Like this, guys. Not to access the properties of the abstract classes, you have to create a child class and implement on unimplemented things, and then using that object of the child class, we have to access all the properties of the parent abstract classes. You cannot create object for the abstract classes directly. So in order to access the properties of the abstract classes, you have to create an object for the child class of those abstract classes and then access. Okay, this is the only way. So guys, this is all about the abstract non-access modifier, and I've clearly explained what will happen when you specify the methods and classes in Java with this abstract non-access modifier. So that's it, guys. In the next video session, I'll explain the next topic, that is exception. What is an exception? I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 185 of Java for Tester series, that is exception. So what is an exception? What is an exception? Exception in Java is nothing but a runtime error. Okay. Exception in Java is nothing but a runtime error. What is a runtime error? What is a runtime error? Let's say, guys, you have a piece of code like this. Okay, you have a piece of code like this, and we have different steps here. Let's say we have line 1. Okay, line 1 code, line 2 code, line 3 code, line 4 code, line 5 code. Like this, we have different lines of code. And during this execution of this code, okay, let's say you are executing this piece of code, and during the execution, let's say this step 3 or line 3 has resulted in some error. Okay, while executing this code, while executing this complete code, the line 3 in this code has resulted in some error during the runtime or during execution. Okay, during execution means during runtime. Okay, we got some error. This error is known as exception in Java. Okay, we call such kind of errors which occur during the runtime, that is during the execution of code, as what, guys? We call them as exceptions. Okay, exceptions are nothing but errors which generally display during the execution of the code, that is during the runtime. Okay, while you are executing the code, if you get an error, that error is known as exception in Java, guys. Let me practically show you an example of an exception. So for that, let me go to this Eclipse ID. We have a Java project already created under this Eclipse ID, guys. As you can see, inside this main method, I'm going to write some statements. Say system.out.println beginning of the program. Okay, and I'll write another statement saying system.out.println ending of the program. Okay, so if I run this code, guys, if I run this code, there are 2 lines of code here. If I run these 2 lines of code, I will not get an exception, guys. Okay, everything is valid here. These statements are good. They won't result in any error. Okay, let me run this. Right click, run as Java application. Observe that you're not getting any error. Okay, you see beginning of the program and ending of the program got successfully printed without any error during runtime. During the execution of this program, I didn't get any error. Okay, but what if I try to intentionally fail something? Okay, say int a is equal to 10/0. If I write this statement like this, okay, if I write a statement int a is equal to 10/0, what will happen, guys? In mathematics, if you divide any number by 0, okay, we'll enter into infinite loop. Okay, infinite loop. You cannot, generally in mathematics, if you divide some number by 0, that's not allowed, guys, because it will result in infinite loop. It's not possible. And as you can see, you are not getting any compiler error, right? Even though I am intentionally making a mistake here, my compiler, I am not getting any compiler error. What is a compiler error? For example, if I write instead of system.out.println, if I write small system, okay, .out some println like this, okay, immediately I'll get a compiler error, guys. Okay, if I give small s here instead of capital S, my compiler is identifying, okay, Java compiler is identifying that according to the syntax, this s should be capital S. Here I gave small s. Okay, so it's not, it's like it's giving some compiler error. You see, you can see this error. But in case of this statement, even though there is a possibility of getting an error during runtime, my compiler is not identifying this. That's why this error is, there's no error here. Okay, there is no compiler error here. Okay, but when you run it, guys, okay, this error will be displayed only during the runtime. That's why we call it as runtime error or exception. Okay, it's a runtime error or exception we call. So when I run this code, this will definitely result in some error during runtime, guys. Okay, during the runtime, during the execution, you will get some error. Let me write like run as Java application. You see, first this statement got executed, that is beginning of the program got executed successfully. After that, the statement in the 7th step here, okay, 7th line got resulted in some exception. You see demo.java, demo class.java, at which step we got 7th step, okay, in this code 7th step, an error got displayed, and this error is nothing but an exception, guys. Okay, what type of exception we got? Arithmetic, mathematical related exception we got, guys. When you divide some number by 0 in mathematics, you will get an error. Okay, it will go into infinite loop. Java will treat it as an error, guys. Okay, so that error which is displayed during runtime, that is during execution, is known as exception. So which exception? The name of the exception is arithmetic exception. Okay, there are different types of exceptions in Java, guys. I will explain that in the upcoming videos. Okay, for now understand that what is an exception, guys? Exception is nothing but a runtime error, okay, which will be displayed. An error displayed during the execution of the code is nothing but an exception. That is a runtime error. Fine. So that's all about the exception, guys. Okay, that's all about the exception. So what will happen? What will happen when you get an exception? Okay, now you understood what is an exception. Now you need to understand what will happen when you get an exception. Okay, what will happen when you get an exception in the program? Simple, guys. Here, let's say there are different lines of code, right? When you run this code, there are 5 lines of code here in this program. And when you run this program, during the runtime, you got an error. At which step you got? At line 3, we got the exception. So what will happen is the line 1 will be executed successfully. Line 2 will be executed successfully. But at line 3, we got an exception and the program will terminate. Okay. Program will stop there itself, guys. What about the other two lines of code? Okay. This particular line 4 and line 5 doesn't have any errors, but still they didn't get executed, guys. Okay. Why they didn't get executed? Because at line 3 we got an exception and suddenly the program has stopped or terminated. Now line 4 and line 5 didn't get executed. This is the problem with exception, guys. Okay. So what will happen when you get an exception? When you get an exception, the program will stop and the other lines which are there after the exception line will not be executed. Okay. Simple, guys. These lines won't be executed. Okay. Fine. Let me show you practically. I already showed you guys. As you can see, this is a system.out.println statement which will print beginning of the program. And in the second line, we have int a is equal to 10/0, which will give an exception. That is runtime error will be displayed. When the second step gets executed, the runtime exception, the runtime error, that is exception, will be displayed. We already know that, right? But compiler is not identifying that. That's correct. And third line, we have another print statement. You see, this line is correct. This line is correct, but this line is going to give an runtime error or exception. So that means what will happen, guys? If an exception is there at some line, the after lines of code will not be executed. That means after this line, whatever the statements are there, that won't be executed. Let me make it big. Let's say I will write something like this. Okay. We are going to get an exception in the second line, and all the lines which are coming after this exception, all these 5 lines of code will not be executed, guys. Okay, because in the second line we got an exception. Let's run this and see how many lines will be executed. Right click, run as Java application. You see, beginning of the program, the line of code which is there before the exception is occurred got printed successfully, right? And the second line got executed and we got an exception. We got an error during the runtime, that is exception got displayed. That is arithmetic exception because of dividing the number by 0. Immediately, okay, when you get an exception, the program has stopped, guys. The program didn't continue. Okay, all the other lines which are after this exception line didn't get executed, guys. All these 5 lines didn't get executed. Okay, nothing happened, guys. You see, nothing got printed. If it has worked, ending of the program would have been printed 5 times here, but you didn't get any output. That means if you get an exception in the program, okay, the program will stop right there itself, and all the lines of code which will follow that particular statement which has resulted in exception will not be executed. All these 5 lines of steps will not be executed by the Java program because the program has halted. So guys, hope you understood what is an exception and what will happen when you get an exception, right? So exception is nothing but a runtime error which is displayed during the execution of the program. Okay, and when it occurs, all the lines of code which come after that exception line will not be executed. So this is nothing but an exception, guys. Okay, this is nothing but an exception. So that's it, guys. In the next video session, I'll continue the exception topic by explaining what is exception handling and how to do that using try-catch blocks. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 186 of Java for Tester series, that is exception handling using try-catch blocks. Exception handling using try-catch blocks. Fine. So in the previous video, I've explained what is an exception, and what will happen when you get an exception. So what is an exception, guys, and what will happen when you get an exception? So let me practically show you. As I already covered this particular thing in the previous video, I'm just going a bit fast here. So let's say you have a print statement. Let's say something like before, and another print statement after. Here I'm trying to intentionally fail, okay, or I'm going to intentionally write a statement which will give an exception during runtime. Fine. So if I say int a is equal to 10 by 0, okay, when I run this code during the runtime, okay, at compile time, I'm not getting any compiler error, but during the runtime, that is during the execution, this statement will print before, and this statement will result in an exception. Okay, I explained in the previous video, this statement will result in an exception. So when you get an exception, the program will terminate, and the statements following the exception statement, this particular statement will not be executed. Okay, won't be executed. What is the reason? What is the reason why this particular statement is not getting executed? The reason here is, here in the second step, we got an exception, and because of that exception, the program will terminate or stop. Okay, program will terminate or stop because of this exception. Wherever we get an exception in Java, the program will stop there itself. Okay, it will not continue the other next step. Okay, we may have multiple steps here. Okay, it may not be a single step, many steps may be there. Okay, all the other steps which are following this particular exception statement, all these steps will not be executed, guys. Okay, after the exception, the statements will not be executed. The program will stop here itself in the second line itself. So let's confirm that. Right click, run as Java application. You see the first statement, print statement, that before got printed. After that, we got an exception in this seventh step. You see, seventh step, we got an exception. And after that, whatever the statements are there, they didn't get executed. If they have executed, we would have got after 4 times here. Okay, we didn't get anything in the output. That means the statements following the exception will not be executed, guys. Okay, this is a drawback. This is a drawback, guys. This is a problem statement, you can say. If you get an exception, the program will stop there itself, and it will not continue. What if, guys, despite of getting an exception, you want to continue the execution? Despite of this exception in this particular statement, you want the Java program to execute this later steps. Okay, so what is the solution? That's a problem, right? In this problem, as you can see, when I run this program, I'm getting an exception and the program is stopping there itself, and the statements following this exception are not getting executed during runtime. So what's the solution then? The solution here is exception handling. By implementing this exception handling, we can make this program execute the remaining steps even after getting the exception. So we don't want the program to terminate or stop after getting an exception. Rather, we want the program to continue with the remaining steps of execution. Okay, we want the program to continue the execution by executing the remaining steps which are after this exception. So how to perform this exception handling? So for now, guys, what is exception handling? What is exception handling? Exception handling is nothing but, okay, handling the occurred exception with an intention of continuing the program execution. By handling the exception that is occurred, okay, here as you can see at the step 7, that is this particular second line of code, we got an exception, and if you handle the exception, all the other steps will be executed, guys. Okay, the program will not stop or terminate because of the exception handling. As we have handled the exception here, the other steps will be executed. Okay, other steps will be executed without stopping or terminating the program. Fine. So how to handle the exceptions, or how to perform exception handling? In order to perform this exception handling, we have to use try catch block. Okay, there's something known as try catch block in Java, using which we can perform exception handling. Whenever you get any type of exception in Java, you can handle such kind of exception using exception handling mechanism with the help of try catch block. Fine. Before I implement the try catch block here to overcome this exception problem, okay, we need to first understand few things about the try catch block. Okay, we have to first know the try catch block about. Fine, let me explain you about the try catch block. So what I will do is first I will give you the syntax. Okay, I'll explain the syntax of how the try catch block will look in Java. That is first thing I will do. Later I will explain the flow of execution. Okay, when you implement the try catch block, how the execution flow will change. Fine. So let me show you. First thing here is I will show you the syntax. The syntax of the try catch block will look something like this. Try block, something like this, guys. Okay, try. This is starting of the try block. This is ending of the try block. Starting curly brace, ending curly brace. This is a try is the keyword. Okay, and try catch. In try catch blocks, there are two blocks, right? Try block is done. Now coming to the turn of catch block. Okay, they have to be used together, guys. Try followed by catch. So here is the starting of the try block, and this is the ending of the try block. And catch block is starting here, and ending here. Okay. So in the try block, we will, what will be there in the try block, guys? So try block is generally used to surround the statements, code statements, which have the possibility of throwing an exception. Okay, will surround the code statements which have the possibility of throwing an exception. For example, here second statement has the possibility. Okay, it's actually intentionally we are throwing an exception here, right? So we already know that 10 divided by 0 will give an exception. Okay, what if in real time we have something like int bc and we are collecting this input from the user? Okay, here I'm not providing the exact program, but just assume that here int a is equal to b by c is there, and these b and c values will be provided by the user. Okay, in real time, let's say, not here, but in real time. Okay, let's say the user has inputted, in place of b, user has inputted 10, and in place of c, the user has inputted 0. What you will do, guys? The exception will come and the program will stop there itself, right? So we have to handle such kind of situations. We have to handle such kind of situations. If the user gives 10 divided by 2 or something, there will not be any problem. But if the user gives something like 0, there comes a problem. Okay, we'll get an exception here, arithmetic exception here. Okay, so if in real time case, guys, if int a is equal to b by c is there, and we are collecting the b and c values from the user, let's say. Okay, in such kind of situations, we can expect that this is a probable code. Okay, this is a probable code. There is a possibility, lot of possibility that user may enter 0 in case of C, right? So there is a possibility. Such kind of possible code will provide inside the try block. Okay, code statements having exception possibility need to be covered inside the try catch block, try block. Okay, whatever the code statements are there which have the possibility of throwing an exception need to be covered inside this try block. Okay, that means, for example, here 10 divided by 0 is there. Assume that there is a possibility, guys. Here b by c is there. Okay, since I cannot take such kind of example in this scenario, what I am doing is I am just providing the try block here. I am surrounding. Okay, you see, assuming that this is the statement which has a possibility of throwing an exception during the runtime. Okay, I am surrounding this statement inside the try block like this. Okay, try, starting brace, ending brace, like this. And what will be there in the catch block? So catch is not completely written here. Catch, I have to say exception E. Okay, exception is a predefined class in Java. E is the object reference, guys. Okay, E is the object reference of this exception class. So let me show you. So let's go to something like Java 8 API. Open it. Control F. Search for exception. Okay. This is a Java 8 API, guys. Java API document. If you search for exception here, you'll somehow find that. Not finding it. Exception. We'll go here. You see this one. Okay. Exception. So exception is a predefined class in Java. Okay. So that we have to, that particular predefined class, we have to specify in this catch. Okay. Catch kind of method, kind of syntax is there, right? Catch. Within the parenthesis, you have to provide that exception class. And this is the object reference, guys. You already know about the object references, right? Well, while we create the objects, we have to provide the object reference. Exception E is equal to new of exception. We can write something like that, right? So exception E. E is the object reference. Exception is the exception. Okay, class. Fine. So even though you don't write anything inside this catch block, okay, from here to here, even though you don't write anything here inside this, in between this catch block, if you don't write, nothing will happen, guys. Okay. So this will handle the exception already. For example, this is a probable code for throwing an exception that we have surrounded inside the try block. When you get an exception, this catch statement, okay, will handle it. This will handle the exception. Okay. After handling the exception by this catch or exception, what you want to do? Okay. That code you have to write here. Code right here. This will handle the exception, guys. Then after handling the exception, what should be done? That should be written here. Okay. You can write as simple as system.out.println exception got handled. That print statement also you can write if you want. Okay. You can ignore this also. Okay. If you don't write anything, nothing will happen. Exception will be handled and things will close. That's it. Okay. The program will not terminate, guys. For example, this is a statement which is throwing an exception. The exception will be thrown to this object reference. Okay. Will be assigned to this object reference of this exception class. And this catch will handle the exception. Okay. Without throwing the exception to the Java and abruptly or terminating the program, rather the exception will be thrown and assigned to this object reference of this exception class, and thereby it will be handled. Okay. So if it is not handled here using the catch block, the program will terminate, right? Since the exception thrown here is being assigned to this object reference of this exception by catch block, okay, the exception is getting handled here. Okay, because of this, the exception is getting handled here. What is try block doing? Try block is actually collecting the exception and diverting it to the catch block. Okay, try block is whatever the exception is thrown by the statement, that try block is, instead of sending that exception to the Java and then abruptly or terminating the program or stopping the program because of that exception, we are diverting that exception to the exception or runtime error to this catch block, where that exception will be assigned to the object reference of this exception class, and thereby it will be handled. Fine. So another thing that you need to understand here is exception flow. So let's say there are multiple statements that you have covered inside this try block. Assuming that any of these statements, there is a possibility of some exception being thrown. Let's say during the runtime, when you execute this program, the statement 2 inside this try block is throwing an exception. So in normal case, if without try block, the statement will stop the program, right? The exception thrown by the statement 2 will be passed to the JVM, and the JVM of Java will terminate the program. Okay, it has no choice. Java has no choice. Whenever the Java receives the exception, it will terminate the program. Okay, but in case you surround these statements which has a possibility of throwing an exception with inside the try block like this, try starting and ending. Okay, So whatever the exception that will come from this any of the statements during the runtime, that exception instead of going to the Java will, okay, Java or JVM of Java, which is actually executing the program, okay, will actually get diverted to this catch block. Okay, fine. So when it gets diverted to the catch block, that particular exception thrown by this statement will be assigned to this object reference of this exception class, and this catch block will handle it. Okay, catch block will handle it. Thereby, the program will not stop, guys. The exception got handled because of this catch. Okay, and here you will write a code after handling the exception. Whatever you want to write, you can write. Okay, you can simply print out. We have handled the exception or anything you can write down here. Okay, so this is the exception flow, guys. This is exception flow. Okay, this is the syntax of the try catch block, and this will throw the exception. The thrown exception will be collected by the object reference of exception class, where catch block will handle it. Okay, fine. So guys, lot of theoretical things I have explained. Now let's move into the practical mode, where I will show you. I already covered this statement, which has a possibility of throwing an exception inside the try block. Now I will write on catch block, which will handle the exception. Okay, as I said, I'll use a predefined class of Java, that is exception class E object reference. You can give any letter here, guys. It's not about E. You can give F, you can give a C, like this. Okay, you can give any name. This is object reference name. That's it. Nothing will happen. Okay. Now here system.out.println, I'll simply print out exception handled. Okay, exception handled. That's it. I will not do anything. Inside the catch block, I'm just writing a normal print statement. That means if this statement is printed, that means this particular statement has thrown the exception, and without the program getting terminated, the exception will be collected by this E of this exception class. And since the exception is handled by this catch block, the statement inside the catch block will be executed. That is system.out.println exception handled will be printed. Okay. So here, guys, I will explain more about this exception here and its uses in the upcoming videos. Okay. For now, understand that the exception thrown by this probable statements inside the try block will be collected by this object reference of the exception class, and thereby catch block will handle it. Fine. Whenever there is an exception, the statement inside the catch block will be executed. Fine. So let's run this and see this time. Earlier, when I have run this, I got an exception like this, right? The only before got printed, and after that we got an exception and program got stopped. Now we are handling the exception, okay, thrown by this particular statement using the try catch block. Let's see what will happen. Okay. So what will happen before running the program? Let me explain. It will first print before, then it will try to execute this int a is equal to 10 by 0. Definitely we'll get an exception because we are dividing a number by 0. According to mathematics, a number cannot be divided by 0 and it will go into infinite loop. Since Java cannot handle such kind of error, Java will throw an exception, right? Java will throw an exception known as arithmetic exception. That arithmetic exception, when thrown from inside the try block, will be diverted and stored into the object reference of the exception class. Okay. Now Java will not worry about this. Only the exception thrown by this or error thrown by this statement got saved into this object reference of the exception class, and thereby handled by this catch block. Nothing will happen. Since the exception has occurred, the catch block will be executed. Since this particular exception has occurred, and we have the thrown exception is stored into this E of this exception class, since this particular catch block got invoked because of that exception thrown from the try block, the statement inside the catch block will be executed. So exception handled will be printed. Fine. After that, as the program has not terminated because of handling the exception here using the try catch block, the statements which come after the try catch block will be executed. That is, all this after will be printed. Okay. Now it will be executed. Okay. Fine. The program will not be terminated now. Okay. Exception will come. Exception will be thrown, but it will be handled by the catch block. Since the catch block is invoked, the statement inside the catch block will be executed. So as the program didn't stop, all the statements after the try catch block also will be printed. Right click, run as Java application. You see, no exception, guys. Exception got handled. by the catch block. And you see, first before got printed, then catch block got invoked. So exception handled got printed here. Fine. Now then we got all these three statements, that is after. All these after statements after got printed. What if there is no exception? In what will happen in this case, guys? I'm giving int a is equal to n by 2. It will not result, this particular statement will not result in an exception. So in that case, what will happen? So guys, first before will be printed as usual. Then 10 by 2, it's a valid, guys. So 10 divided by 2 is 5. 5 will be stored into the variable a. Okay. Then since there is no exception here, okay, catch block will not be invoked. If there is an exception, then only catch block will be invoked, right? Thrown exception will be saved into the E of exception and catch block will be invoked if this particular statement is resulting in an exception or runtime error, right? But if there is no runtime error or exception by the statement will be executed and catch block will not be executed, guys. Catch block will be skipped. And finally, all these three statements will be executed. Okay. So before, then after will be printed. Okay. Catch block will not be executed. Catch block will be skipped in this case. Without exception, the catch block will not be invoked. Okay. Only when there is an exception, the catch block will be invoked and statements inside the catch block will be executed. Otherwise, the catch block will be skipped. You see, before, after, because there is no exception. Fine. So guys, so this is how we can handle the exceptions using try catch block in Java. Okay. I'll explain more about the try catch block and this exception class and this object reference. Okay, there are a lot to be told, so which I will be covering in upcoming videos. Fine. So that's it, guys. In the next video session, I'll explain try catch blocks and the variable scope. Okay, that is, if you declare or create a variable inside the try catch block, can you access that particular variable out of the try catch block or not? What is the variable scope which is declared inside the try catch block? That thing I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 187 of Java for Tester series. That is try catch blocks and variable scope. So in this session, I'm going to explain the scope of the variables which are created, that is declared inside the try and catch blocks. So guys, before I practically demonstrate what will happen when you create a variable inside this try catch blocks and what is the scope of these variables, okay, let me explain that. If you create a variable or declare a variable inside this try catch block, the scope of the variable will be up to that try catch blocks itself. Okay. If you create or declare a variable inside this try catch blocks, the scope of the variable will be up to this try catch blocks itself. You cannot access the variable outside the try catch blocks. Okay. The variables created inside the try catch blocks cannot be accessed outside the try catch blocks. They can be only accessed inside the try catch blocks itself. Okay. If you create a variable inside the try block, then the scope of the variable is up to the try block itself. If you create a variable inside the catch block, the scope of the variable is up to the catch block itself. Let me practically show you guys whatever I'm explaining. Okay. So guys, what I will do is I'll directly create a try catch block here. So this is a try block, as you know, and associated with a catch block. I'm just giving some predefined class known as exception and E. Okay. This is a try catch block syntax, right? Fine. If I create a variable inside this try block like this, int a is equal to some 5. Okay. Can I access this particular variable outside this try block? Outside this try block, can I access? No, guys. The answer is the scope of this variable a is up to try block itself. Okay. So let me practically show you now. Okay. For example, if I say system.out.println a, okay, I'm trying to access this variable a, which is declared inside the try block. Since this particular print statement is also inside the try block, I'm able to access without any problem. I'm able to access. what if I move this print statement outside the try block like this? Okay, outside the try catch block, if I move this statement, I'm immediately getting a compiler error. As you can see, there is a compiler error which is displayed immediately. A cannot be resolved to a variable. That means since the scope of the variable A which is declared inside the try block is up to the try block itself, that's why we are getting this compiler error, guys. Okay, we are not able to access it outside the try block. So a question may arise, if I create a particular variable or declare a variable inside the try block, okay, then can I access it inside the catch block? The answer is no, guys. You cannot even access in the catch block also. Okay, the variable created or declared inside the try block, the scope is up to this try block itself, guys. Okay, not behind this. Whatever the selection area is, up to that only the scope of that particular variable will be there. If you try to access even in catch block also, you'll get the compiler error. As you can see, there is a compiler error. Okay, so you can only, this particular statement will only work in the try block. You cannot use it outside the try block. Fine. Then what about the catch block, guys? Will it apply will the same rules apply for the catch block? Yes, guys. The same rules will apply for the catch block also. For example, you create or declare a variable inside the catch block like this. Okay. The scope of this variable B is up to catch block itself. Okay. The scope of this variable B will be up to this catch block itself. The block in which this particular variable got created. Up to that only the scope will be there. Okay. If I say system.out.println B, I'll be able to access without any problem because this particular statement is also there in the catch block. Since the scope of the variable B is up to this catch block, this will not result in any error. What if I move this statement outside the catch block like this? I'll definitely get a compiler error saying that this variable is not findable or something. Okay, that means since the scope of this variable B is up to this catch block, we are not able to access this variable B outside the catch block. Okay, even in try block also we cannot access. We'll get a compiler error. So guys, this is all about the variable scope in the try catch blocks. Okay, so that's it, guys. In the next video session, I'll explain about arithmetic exception. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 188 of Java for Tester series, that is arithmetic exception. So what is arithmetic exception? Arithmetic exception is a predefined class in Java. Is a predefined class in Java. Let me show you. So if you go to Google, search for Java 8 API, you will find this link. Just click on that link. Okay, you will be taken to the API documentation page of Java. And Control F, search for arithmetic exception. So when you search for arithmetic exception, you see this particular thing is getting highlighted on the left side. This is a class. Click on this. You see arithmetic exception is a predefined class in Java. Okay, fine. So where we can use this arithmetic exception class in Java? Okay, fine. Arithmetic exception is a predefined class in Java. That's fine. But where we have to use it? Where we have to use this class? So generally we use this class with catch block. Okay, we have to use this inside the catch block. Why we have to use this arithmetic exception predefined class in the catch block? To handle arithmetic exception thrown from the try block. Okay, for example, you have a try block like this and you have a catch block. Assume that some statements, okay, some statements inside the try block are resulting in an exception known as arithmetic exception. In that case, if you use this predefined class known as arithmetic exception in this catch block here, catch arithmetic exception, okay, you can give any variable A or E or something, whatever you feel convenient. So when you use this arithmetic exception predefined class of Java in the catch block, okay, if any statement inside the try block is throwing an exception like arithmetic exception, that exception will be handled by the catch block, okay, because of this class. So let me explain you practically, guys. Okay, let me explain you practically. For now, understand that arithmetic exception is a predefined class in Java, and we have to use this particular arithmetic exception predefined class in the catch block, okay, to handle the arithmetic exception thrown from the try block. Fine, let me show you. So let's immediately create a try block, then catch block. So this is a try block and this is a catch block. Let's create a statement inside the try block, guys. Let's say int a is equal to sum 10 by 0. Okay, I'm intentionally dividing this number 10 by 0, which will result in an exception as explained in the previous videos, right? As explained in one of the previous videos, if you divide a number by 0, Java programs will throw an exception. What type of exception will be thrown, guys? Exception means error, right? What kind of exception will be thrown in this case? Since it is a mathematical kind of exception, we are going to get arithmetic exception. If we run this program in the runtime, we are going to get the arithmetic exception, okay, because of this exception. Because of you are dividing the number 10 by 0, we are going to get an exception during the runtime. That is, exception is going to be arithmetic exception, okay. So if you are going to get an exception here, if the statement is going to throw an exception here, that exception need to be handled using the try catch blocks, right? So in the catch block, you have to provide a predefined class. In one of the previous videos, I have used exception class, right? Exception class is also a predefined class in Java, okay. But here we are going to get an arithmetic exception. Here exception class can also handle this arithmetic exception, because exception class can handle more than arithmetic exception. Different type of exceptions exception class can handle. But here, guys, instead of going to that exception class, if you have provided this predefined class, that is arithmetic exception class in Java, okay. Arithmetic exception is a predefined class in Java. This kind of arithmetic exceptions can be handled, okay. You don't have to use exception class for this arithmetic exception, guys, okay. You can use arithmetic exception class also, okay. Arithmetic exception class is intended for handling the arithmetic exceptions only, okay. So if this particular statement is throwing an arithmetic exception, that exception will be handled by the catch block, because we have provided the class name as arithmetic exception here, okay. Fine. So I'll say system.out.println arithmetic exception handled, okay. Arithmetic exception handled. So if I run this, okay, if I run this code, if this particular statement is printed, that means whatever I said is working, right? This statement will throw an arithmetic exception, and that will be handled by the catch block will be invoked, and this particular exception thrown by this statement from the try block will be handled by this arithmetic exception predefined class of Java. Okay. On handling this, we'll get this print statement. So let's run this. Right click, run as Java application. You see, arithmetic exception has properly handled. Fine. So what if I don't use arithmetic exception? I will use some other exception class like array. There are different exception predefined exception classes in Java. So I'm using another one, array index out of bounds exception. Okay. Array index out of bounds exception, like this. Fine. This is another predefined class in Java, which is intended for another type of exception. Here, from the try block, I am going to get an arithmetic exception, but here in the catch block, I am using another class known as array index out of bounds exception. This arithmetic exception and array index out of bounds exception is not matching. So what will happen, guys? You will get the exception. Okay, you are going to get the exception. You see, it's not handled because you have not used the proper class here. As you are getting in the try block, you are getting the arithmetic exception, but in the catch block, you are using a different predefined class which cannot handle this arithmetic exception. Array index out of bounds exception class cannot handle the arithmetic exception, guys. That's why we are getting the exception here. What if I use the proper class, that is arithmetic exception class. If I use a proper class here, this will handle the exception. Now the exception will be handled, as you can see. Right click, run as Java application. You see, this time the exception got handled because we have used the correct predefined class for handling that arithmetic exception. Fine. So guys, now tell me, what is the arithmetic exception? Arithmetic exception is a predefined class in Java which can be used with a catch block for handling the arithmetic exceptions thrown from the try block. Okay, that's nothing but the arithmetic exception. So that's it, guys. In the next video session, I'll explain about another predefined class of Java for handling the exceptions, that is array index out of bounds exception. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 189 of Java for tester series, that is array index out of bounds exception. So what is array index out of bounds exception? So array index out of bounds exception is nothing but a predefined class in Java. It's a predefined class in Java. Array index out of bounds exception is a predefined class in Java. Let me show you guys. Let's open any browser. Let's Google search something like Java 8 API. And you'll get such kind of search results. Click on the first search result which says Java API. Click on this. It will take you to the API documentation page of Java. And here say Control F and search for array index out of bounds exception. Okay, just search for this thing. As you can see on the left side, array index out of bounds exception has been found. Just click on this link. You will be taken to the array index out of bounds exception class. So array index out of bounds exception is a predefined class in Java. That's why it's there, right? Since array index out of bounds exception is a predefined class in Java, it's there in the API documentation of Java. Okay. So what is array index out of bounds exception? It is a predefined class in Java. That's fine. So where we have to use this array index, okay, where we have to use this array index out of bounds exception, where we have to use this class, guys. So we have to use this predefined class in Java at using catch block. As we know, we have try catch block in Java, right? For handling the exceptions, we have try and catch. Some exception E like this we have in Java, right? This is a try catch block in Java which can be used for handling the exceptions. Here in place of this exception is also a class, guys. Exception is also a predefined class in Java. In place of this, we can use array index out of bounds exception. Okay. So array index out of bounds exception is a predefined class in Java which can be used with the catch block. Okay. In Java, we can use this array index out of bounds exception with catch block. Fine. So how to use it? Practically, let me explain how to use this array index out of bounds exception class in Java with the try catch block. Okay, let me practically demonstrate now. So let's right away write down this try block. Okay, this is a try block, guys, associated with some catch block. Inside this catch block, we have to provide a class, some predefined class we have to provide. That can be exception class, that can be arithmetic exception class, that can be array index out of bounds exception class. It can be anything, guys. Okay. Here we have to provide some predefined exception class here. You can give any variable here, A or B or C or E or anything will work fine. So what if I don't provide anything here? Okay. So I'll write some code, guys, which will throw some exception. Okay. First, I will demonstrate you some code which will throw some array index out of bounds exception first. Okay. a kind of error will be thrown when I write this program. So I'll create some integer array. A is equal to integer array A is equal to new int of some 3. Fine. Now here I am trying to assign the elements to this particular array. All the element values should be of integer type, right? A of index, array index starts with 0 as explained in one of the previous videos. A of 0, 0 is the index of the first element in the array. And for this first element in the array, I am storing some value say 5. Then for A of 1, I am storing some value say 7. A of 2, I am storing some value say 3. For A of 3, I am trying to store a value 9. So guys, did you get any error here? After writing this code, did you get any compiler error here? There is no compiler error coming, guys. Okay. But when I run this code, I am going to get an error. That is an exception I am going to get. Okay. Array index out of bounds exception I am going to get if I run this code. The reason here is I have created this array. While creating this array, I mentioned that the size of the array is only 3. Into this particular variable of array type, integer array type, we can only store 3 values. But how many values did I store here, guys? Up to here is allowed, but this is the fourth value. This array is only allowing three values, but here I am giving 4 values. That will be a problem, guys, right? So this will result in array index out of bounds exception. An error will be thrown by this code. During the runtime only it will come. Okay. Compile time, there is no error displayed. But when I run this program, right click run as Java application, as you can see, we got an exception. At which line? 11th. You see at 11th line, that is this one. We are trying to assign 4th value into the array, which can only store 3 values. In such kind of cases, we are going to get array index out of bounds exception, guys. Okay. So the reason here is you can only assign 3 values, but you are assigning 4 values. That's the reason. Nothing more than that. So how to overcome this error, guys? So in real time, we may face such kind of situations where such kind of array index out of bounds exception may come. Wherever there is a possibility, we'll enclose such kind of code inside the try block like this. Okay? With an intention of handling this kind of exception, we'll put this inside the try block, and in the catch block, okay, we will provide array index out of bounds exception and some variable you can give some A or B or something, whatever you want. Okay. Here simply I will say system.out.println exception handled successfully. Okay, exception handled successfully will be printed. So guys, the code in the try block will definitely throw a array index out of bounds exception because we have to store only 3 values, but we are storing 4 values. So this code will result in array index out of bounds exception. That exception thrown will be stored into the variable of which class type? Array index out of bounds exception class type. Array index out of bounds exception is a predefined class in Java. Okay. This is the object reference of this predefined class which can store the exception thrown by this try block code. That exception is nothing but array index out of bounds exception can be stored into the object reference of this array index out of bounds exception, and thereby this catch block will be able to handle the exception. Okay. So when the catch block successfully handles the exception, okay, this message will be printed. The code inside the catch block will be invoked and will be printed on successful handling of the exception. Otherwise, if it is not handled, we will get the exception again. Okay, let's see when if I run this time it should not display any error, guys. Okay, it should print exception handled successfully. Without exception, without the need of exception, we got exception handled successfully, guys. What if I provide a wrong class here? Instead of array index out of bounds exception, if I provide arithmetic exception class here, spelling mistake, arithmetic exception. Okay, arithmetic exception is another predefined class which is used for handling another type of exception known as arithmetic exception. But here try block is throwing which type of exception, guys? Array index out of bounds exception. But here in catch block, what kind of class we have provided? Arithmetic exception. There is a mismatch. Arithmetic exception class cannot handle array index out of bounds exception. So when I run this, you are going to get the exception, guys. Okay, it will not be handled even after using try catch block, since there is a mismatch between the exception thrown and the exception class type here. Okay, we are going to get the array index out of bounds exception. Fine. So that's the reason, guys, we have to use appropriate exception class, that is array index out of bounds exception class here to handle such kind of exceptions. So run this. Now the exception will be cleared and it will be handled successfully. Fine. So guys, this is all about the array index out of bounds exception. In the next video session, I'll explain about the exception hierarchy. So in place of array index out of bounds exception and in place of arithmetic exception, we can use some parent exception classes also, okay, which can handle all the types of exceptions. Here guys, in this example, we have provided array index out of bounds exception. And if you provide arithmetic exception here, it will not work out. But if I provide exception here, it will work out. Okay. If I provide exception here, it will work out. It will be handled successfully. Even though this is not array index out of bounds exception, it is not. Still, if I provide exception here, it's working fine. How it is working fine, guys? This is all because of the exception hierarchy that I'm going to explain in the next video session. So in the next video session, you will understand why this particular exception class is working in place of array index out of bounds exception. Okay. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 190 of Java for Tester series, that is exception hierarchy. So what is exception hierarchy? So before understanding what exactly is exception hierarchy in Java, let me first explain few basic concepts. Okay, after understanding those concepts, you will be able to understand exception hierarchy in a better way. So let me explain that concepts. So guys, in Java, we can assign the object of child class to the parent class object reference. Okay. So in Java, we can assign the object of the child class to the parent class object reference. But vice versa is not possible. But vice versa is not possible. That means you cannot assign the object of the parent class to the child class. But you can assign the object of the child class to the parent class is possible. Okay. So let me practically show you what I am talking about. So for that, guys, let me create two classes. Right click, new class. I'll name this class as class A. You can give any name, guys. I'm just naming this as class A and click on finish. So it's taking time. Okay, it got created. Class got created here, as you can see. Okay, class A got created. As a sample, I'm just creating some variables, say int x. Okay, I'm not creating much in this class. Okay, only int x I'm creating. Similarly, I'm creating another class. Right click, new class B. In the class B also, okay, in the class B, I'll move it this side so that you can see both the classes together in Eclipse IDE. I'll create another variable like int y. Okay, now we have two classes, class A and class B. I want to make this class B a child class of class A. That means I want to make this a parent class. And I want to make this class as a child class of this parent class. Okay. So in order to make this class B as a child of this class A parent class, what I have to do, guys, I have to say class B extends class A like this. I have to do. Okay. After doing so, what I will do is I will create another class. Okay, just for creating the objects and all. Just for creating and assigning the objects, I want to create another class. I'll name this class as some demo class, and I will select this public static void main option to be auto generated. Eclipse IDE will auto generate it for us. I will drag and drop it here. Okay. So inside the demo class, we have the main method. Fine. Now this is a parent class, and this is a class B is a child class of this class A parent class. Let me create an object. Okay. Let me create an object for the parent class. Class A. Some A object is equal to, okay. So this is just a creation, guys. Okay, here I am defining this variable as a type class A, but I am not creating an object. So far I didn't create any object, right? Class A is a parent class. Left side we have the parent class, and this is a variable of that parent class type, right? Now on the right side, if I say new class B, what happens, guys? Will this be allowed or not? I am creating an object for the class B and assigning it to the variable of the class A. Yes, guys, it is possible because here the object is created for which class? Using the new operator, the object got created for which class? Class B. This object is getting assigned to the variable of which type? Parent class type, that is class A. So this is possible. This is possible in Java. You can assign the object of the child class to the parent class. That is possible. Okay. But vice versa is not possible. That means assigning the object of the parent class to the child class is not possible. Let's see that. Okay. Here class A is the parent class and class B is the child class. The object of the child class can be assigned to the variable of the parent class. That is possible. But what if I say something like this? Class B, some B object is equal to new class A. This is not possible, guys. You will get a compiler error. Okay. When you hover the mouse on this, you can see that type mismatch cannot convert from class A to class B. You cannot assign the object of the parent class to the variable of the child class. This is not possible. Okay. So guys, you have to have an idea of this. Okay. So in order to understand this exception hierarchy, you have to understand this thing, which I have practically shown you just now. We can assign the object of the child class to the parent class, but we cannot assign the object of the parent class to the child class. Okay. So this is one thing. Second thing you need to understand. Okay. So let me show you another thing that you need to understand before I explain you the exception hierarchy concepts. So let me delete all these things. So second thing here is what happens when an exception is thrown. Okay. So when an exception is thrown, the program will stop, right? When an exception is thrown from the Java program, if an exception is thrown, the program will stop. Let's create an example for this. Okay. You already know this, but I'm just recreating it. I'll say demo and with this public static void main. So everything got auto generated for us. Inside this, I am just writing something, right? Like int a is equal to some 10 by 0. Okay. This statement, as we know, will throw what kind of exception, guys? Arithmetic exception. And that too during the runtime. During the execution only, this kind of error or exception will come. So we can see that. Right click run as Java application. You see arithmetic exception got displayed because of this statement, because we are dividing the number 10 by 0, which is not possible in Java. And Java will result such kind of things in the arithmetic exception kind of exception. The reason here is you are dividing a number by 0. Fine. So in order to handle such kind of exceptions, we already know that we have to do exception handling. Okay. We have to do exception handling. How do we do exception handling, guys? We have to use something known as try catch blocks, right? So the probable code which can throw the exception has to be provided inside the try block like this. Try. Inside the try block, we have to provide this code. And here catch block, catch exception, some E. Okay, I'm just writing the syntax here. Fine. I'll explain all these things, whatever you need to understand. So now, guys, here if I say system.out.println exception handled like this. Okay. So if I run this code, what will happen, guys? Even though the exception is thrown from here, from the try block, even though exception is thrown, the catch block will handle the exception. And when the exception is handled, this particular statement will be printed. So let's run this and see whether the program is getting stopped or it is getting handled. It will be handled, guys. Okay. Exception handled. Exception handled. Fine. Now, guys, you need to understand here one thing. Okay. So what's happening internally? How this try catch block is internally working. So in order to understand the exception hierarchy, you need to understand the working of the try catch block internally. The internal working of the try catch block you need to understand. So let me explain now. Okay. Let me explain the internal working of the try catch block. So what happens here? So guys, here this particular statement is throwing an exception, right? When you run this program, this particular statement will result in an exception. The exception is known as arithmetic exception. So earlier I showed you, right? We got some exception, that is arithmetic exception. When this particular only this statement got executed, that kind of exception got displayed in the output. That's fine. So what's happening here is this statement when executed will without this try catch blocks. Okay, without this try catch blocks, what's happening is this exception will be thrown and you will see the error as we already know. Okay, this kind of error will come. So how this error is coming internally, how this error is coming, how this exception is coming in the output. The thing here is this statement when executed during the runtime, okay, will throw an object, okay, internally an object of the arithmetic exception predefined class of Java. We already know that arithmetic exception is one of the predefined class in Java. In one of the previous videos, I explained to you, right? Let me show you again. So if you search for Java 8 API, you will be taken to this Java search results. You just click on that Java API link and you will be taken to the API documentation page of this Java 8. Control F and search for arithmetic exception. Okay. As you can see, something got highlighted on the left side. This is nothing but the arithmetic class. Click on that. It will take you to the dedicated page of this arithmetic exception class of Java. Okay. Arithmetic exception is a predefined class of Java. Okay. So guys, so whenever this kind of statements we use, okay, which result in some kind of error, like this is a mathematical error, guys. You cannot divide a number by 0. Okay, that is a mathematical error. So since Java cannot handle this, what Java will do is during the runtime, during the execution of the statement, Java will throw an error. That error is nothing but an exception. That is nothing but an object of the arithmetic exception predefined class of Java, guys. So here, so this statement is throwing the object of which class? When an error comes, this statement is throwing an object of which class? The object of the arithmetic exception predefined class of Java. It's being thrown, guys. Okay, and to whom this particular thing is thrown? Okay, to whom this particular error is being thrown? It is being thrown to JVM of Java. Okay, JVM is something which is taking care of the execution, guys. Right? Okay, JVM in Java is something which is taking care of the execution. So that particular object of the arithmetic exception, okay, is being thrown to this JVM of Java. So what will happen in such kind of cases? JVM will get this object of this arithmetic exception, and once it gets this arithmetic exception, okay, this JVM will display this output. Okay, JVM cannot handle that. There's no way that JVM can handle that. Okay, the object of the arithmetic exception predefined class is directly thrown to JVM. So as JVM cannot handle that, JVM don't know what to do. So simply JVM will stop the program by throwing this exception. Okay, so now JVM can understand that this is an arithmetic exception because an object of arithmetic exception class is thrown to the JVM, and JVM uses that arithmetic object of the arithmetic exception and then display this message saying that Java language arithmetic exception has occurred. Okay, an object of the arithmetic exception predefined class is thrown to me. That's why I'm displaying this message. JVM is saying something like that, and along with that, this this object will also contain this message. Okay, along with the type of the exception, the object will contain two things, guys. One is exception type that is being thrown, and other thing is the reason for the exception. Those two details will be inside this object of this arithmetic exception predefined class that is being thrown from this statement. Okay, so JVM will simply display those things for us in the output by stopping the program there itself. Wherever you get the error, the program will be stopped there itself. To avoid such kind of situations, we are using try catch block. We are simply using try catch block like this. Try catch exception E. Okay, exception E, and here we are simply writing down exception got handled. So here now without try catch block, the object of the arithmetic exception predefined class is being thrown to whom? JVM of the Java, right? But what if I surround this particular statement inside the try block? In that case, guys, the try block will divert. Okay, the try block will divert the object thrown from the arithmetic exception predefined class, not to the JVM, guys. Instead of taking that object of arithmetic predefined class, thrown object of the arithmetic exception predefined class to JVM, instead Java will, this try block will take that and assign it to the object reference of this exception class. Okay, this object of the arithmetic exception predefined class thrown by the statement as an exception will be assigned to the variable of this exception class, to the variable of this exception class. Okay, so how can exception class handle the arithmetic exception object? You are assigning the object of the arithmetic exception to the variable of the exception class. How this is possible, guys? Literally, this is happening, guys. Okay, internally, this is happening. Exception is equal to new arithmetic exception. This is happening internally. Is this possible, guys? Can you assign the object of the arithmetic exception class to the variable of the exception class? Is this possible? Yes, this is possible. Why? Because arithmetic exception class is a child class of the exception class. Exception is the parent class of the arithmetic exception class. Okay. As I explained you already in the beginning of this video session, you can assign the object of the child class to the variable of the parent class. That is possible. That's the reason, guys, if you keep exception here instead of arithmetic exception, it will work, because the object thrown by the statement, the object of the arithmetic exception predefined class thrown by the statement will be assigned to the this particular variable of the exception class by this, by dividing by the try block, and catch block will simply handle this. Okay, using this information, catch block will handle the situation by simply printing. Instead of throwing the error, this exception got handled will be printed. That's how exception got handled here. So here internally what's happening, you have to understand that internally we are assigning the object of the arithmetic exception predefined class thrown in the try block to the variable of the exception class in the catch block. Okay, this is possible. So now, guys, this leads to something like we have to find out what is a child class, what is a parent class. How can I know that arithmetic exception is a child class of the exception parent class? How can I know that, guys? Okay, here I am saying that this is possible because arithmetic exception is a child class of the exception. I am saying exception is a parent class and arithmetic exception is a child class, child predefined class. I am saying, but how can I say that? So to say that, I'll show you few things. Okay, how to find it out? Let me show you. So guys, I already searched for arithmetic exception here, and we got this predefined class page, right? Arithmetic exception predefined class page in the Java API. That's fine. Now, using this information, let's find out what is parent class and what is child class in this exception classes. Okay. So here we are. Arithmetic exception is here, right? So what is on the top? Let's start from the top, guys. Object. Object class is on the top. So not only for exception classes, guys, not only for the exception classes, but for all the classes in Java, object is a parent class. Okay. Now I am explaining about the exception hierarchy, guys. Now I am explaining. Now you understood all the concepts. Okay, internal working of the try-catch blocks and assigning the object of the child class to the parent class. Everything you understood now, right? Now I am going to explain about the exception hierarchy. So we are going to like design the exception hierarchy based on the information we have in this Java API. Okay. So for now, to get started, as you can see, object is a parent class of all the classes in Java. Not only exception classes, but all the wherever you go, this is the top one. Root class of Java is object class. So it comes anyhow, it comes on the top. When I talk about the exception hierarchy, when I talk about the exception hierarchy, the object class should be on the top because object class is the parent class of all the classes in Java. No matter what, it will be on the top. Okay. So under object class, as part of exception hierarchy, under object class, what is there, guys? Under object class, we have throwable. Okay. What is throwable? Let's find it out. Throwable is another predefined class in Java. Okay. Which is on the top. Throwable. So throwable is under object class. Okay. Throwable is under object class as part of exception hierarchy. Now under throwable, we have exception. Okay. We have exception. Under exception. Okay. Under exception, we have runtime exception. So we have this. So I have to take a new page, otherwise Control C, file, new. Okay, I'll make it bit low. Okay, exception hierarchy, object class throwable exception. Otherwise, Control Z, Control V. Okay, fine. Exception hierarchy, object class, throwable class, exception class. Under exception, we have seen. We'll modify this based on the changes. Okay, we have runtime. What is that? Runtime. Runtime exception. This is another predefined class, guys. Runtime exception is another predefined class, and runtime exception is another predefined class. Okay, different predefined classes you can say. Fine. So we have exception predefined class and runtime exception predefined class. Fine. What next? Under this runtime exception, we have arithmetic exception. So arithmetic exception is coming here, somewhere here. Arithmetic exception. So here in our example, this particular statement is throwing an object of which class? Arithmetic exception predefined class. That is nothing but this particular class. Object of this particular class is being thrown, and we are assigning to the variable of this which class? Exception class. Here exception is exception class is the parent class of the arithmetic exception class? Yes. Okay, because exception class is on the top, guys. Exception class is on the top. That means exception class is the parent class of this arithmetic exception. Not only parent, it's a grandparent. The parent is runtime exception. So what does this mean? So instead of arithmetic exception, if I give in the catch block exception, this is working, right? What if I give runtime exception? Will it work? If I give runtime exception, will it work, guys? Okay, maybe this is runtime exception. Yeah. So here it's not capital T, it's small t. Okay, it's a runtime exception. So this is also a parent class of arithmetic exception, right? Arithmetic exception is a child class, whereas runtime exception is a parent, immediate parent of this arithmetic exception class. So here, in order to handle this exception, if I provide the runtime exception, which is a parent of this arithmetic exception in the catch block, will this situation be handled? The answer is yes, guys. It will be handled because you can assign the object of the child class to the variable of the parent class. That's satisfiable. And also runtime exception is the parent class of the arithmetic exception class, so it can handle the exception without any problem. Right click, run as Java application. Exception got handled. Okay. So what about exception? Already showed you it's working. So exception is the grandparent of this arithmetic exception class. So this also can be handled. The object of the arithmetic exception predefined class can be assigned to the variable of the exception class. So right click, run as Java application. It's working. So let's go to the top. What about throwable? Can throwable also can handle this kind of arithmetic exception? Let's find it out. Yes, guys, it can even. Okay, even throwable is the parent of grandparent in the hierarchy. In the exception hierarchy, throwable is the parent of the grandparent class of this arithmetic exception. So it can also handle. So right click, run as Java application. Okay, it can also handle. Fine. Now, so this is about arithmetic exception. What if I go back and I search for something known as array index, another type of exception, that is array index out of bounds exception. Okay, so this is another exception class. I explained about this array index out of bounds exception in one of the previous videos, right? Okay, if your array is set to the size of 3 and if you are trying to assign 4 values into that particular array, okay, you are going to get such kind of exception as explained in the previous videos. Fine, this is another predefined class in Java. So here, this array index out of bounds, let's find out the hierarchy, guys. Okay, let's find out the hierarchy. So array index out of bounds exception is under which parent class? Index out of bounds exception. That means this hierarchy will be something like this. Under runtime exception, arithmetic exception is there. Apart from that, under runtime exception, we have another class also, that is under runtime exception. What is there? Index out of bounds exception is there. Index out of bounds exception. Okay, index out of bounds exception. So we are designing the hierarchy, guys. Okay, based on the Java API documentation, we are modifying this hierarchy of the exceptions. Fine, index out of bounds exception, and under index out of bounds exception, what is there? Under index out of bounds, whatever the array index out of bounds exception we want, that particular class is there. So let's write down here. Under index out of bounds exception, we have array index out of bounds exception. Okay, this is under this one. So let's change the code here for a while. That is, let me change the code so that it can throw some array index out of bounds exception. That is, let's say int a is equal to some new int of only two values it can take. But here I am saying a of 0 is equal to 1, a of 1 is equal to some 3, a of 2 is equal to some 9. Okay, I'm trying to assign 3 values into this array. Only 2 values are allowed, but I'm trying to assign the third value here. Okay, third value is not allowed. I'm not getting any compiler error, but when I run this program, okay, if I remove this try catch blocks here, when I run this program, I will get an exception. That is, array index out of bounds exception will be thrown. You see, here I'm not handling this. So directly this object of this array index out of bounds exception predefined class will be thrown to the JVM as an error. Okay, JVM cannot handle that kind of situation because there is no exception handling mechanism provided here, and simply JVM will stop the program and display this output with the details of array index out of bounds exception object has been thrown, and the reason for that is only 2 values are allowed in the array, and but you have provided third value also. Okay, so anyhow, to handle such kind of situation, we generally use try catch block. Let's handle this with the try catch block. Try catch. If I give exception some e, if I say system.out.println, system.out.println, exception got handled. Okay, so this will handle the exception, guys. This will work. The reason is same. The reason is same. Here, which exception is being thrown? Array index out of bounds exception is thrown, right? The object of the array index out of bounds exception, the object of the array index out of bounds exception predefined class is being thrown here, and that is getting assigned to the variable of the exception class. So this will be something like this. Exception is equal to new array index out of bounds exception. Okay, like this. So here array index out of bounds is the child class, grandchild class of the exception predefined class. Okay, the grandparent, this is a grandchild. Somewhere here we have array index out of bounds exception. So guys, so this situation will be handled, right? Yes, it will be handled because we are assigning the object of the child class to the variable of the parent class. Okay, the object of the child class is being thrown from the try block, and the variable of the parent class is there in the catch block. So let's right click run as Java application. You see, exception got handled. So let's try all this chain. Exception is fine. What about index out of bounds exception? Instead of array index out of bounds exception, can I use index out of bounds exception? I can use that. Okay, index out of bounds exception. I can use it because I'm assigning the object of the child class to the variable of the parent class. Here, index out of bounds exception is a parent class. Right click run as Java application. You see, it got handled. You can even provide array index out of bounds exception. So this is nothing but you are assigning the object of the class to the variable of the same class itself. That is always possible in Java. Okay, it will directly handle the exception. You see, it got handled. So whatever it is, you provide exception or throwable or whatever it is, everything will work here in the chain. Whatever you provided, everything will work, guys. Okay, if I say throwable, it will also work. Right click run as Java application, it will also work. Even if you provide runtime exception also, it will work. Okay, runtime exception. Run this, it will work, guys. Okay, so this is how the hierarchy, okay, exception hierarchy is making the things possible. Fine. So let's go to few things like let's go to something like throwable. Under throwable, what is there? There are two subclasses under throwable. One is error subclass and another is exception. So throwable has this exception and error. Okay. Under throwable predefined class, under throwable predefined class, we have two classes. One is exception class and another one is error. Okay. So there are some situations where you'll get some kind of unsolvable errors. This error class will take care of such kind of things. Okay. So I don't have to. This is out of topic, guys. I'm only talking about exceptions. So we'll go in this hierarchy. Okay. But throwable class has two subclasses. Here, as you can see, this throwable class has two subclasses. They are error and exception. Under exception class we have lot of subclasses are there, right? Under exception class, under this exception class, only runtime exception is not the only class we have. We have many classes. Runtime exception is only one class. Control F, runtime, okay, exception. Runtime exception is one of the child classes of this exception parent class. But apart from this runtime exception, there are many other, okay, many other child classes also there, right? So let's go to inside the runtime exception. If I click on the runtime exception, under runtime exception, again there are many subclasses regarding exception classes. There are many exception subclasses are there under the runtime exception. Okay, you don't have to learn each and everything, guys. Okay, so even though there are many things, whatever that is needed, you have to learn it. Okay, so whatever that I said, like arithmetic exception or array index out of bounds exception, those are famous. Okay, those are generally seen exceptions. So you have to know only those things. You don't have to learn each and every exception that is listed down here. You are just learning the hierarchy. Okay, just you are learning the hierarchy of the exceptions by using this API documentation. So here, as far we know, under runtime exception, we have arithmetic exception and index out of bounds exception. So under runtime exception, let's find out whether we have this arithmetic exception and arithmetic. Yeah, arithmetic exception is there here, and another one is index out of bounds exception. Okay. So we have these two things. Apart from these two things, we have many other exception classes. Under index out of bounds exception, we have this array index out of bounds exception. So let's go inside the index out of bounds exception. Control F, array index. Okay, you see under this index out of bounds exception, the subclass is array index out of bounds exception. Okay, and another subclass is also there, that is string index out of bounds exception. We don't have to learn that. Okay, whatever that comes in our way, we will learn it. Okay, we don't have to learn each and every exception class that is there in the Java. Okay, so this is, guys, this is how the exception hierarchy is there in Java. The main intention of this exception hierarchy is that the object of the child class can be assigned to the variable of the parent class. Okay, and while you are handling the exceptions, the object thrown in the try block. Okay, if it is a object of the child class, that can be handled by the variable of the parent class. But what if this is array index? This is a what do you call array index out of bounds exception. But here, if I give arithmetic exception, will it work? It will not work, guys. Okay, because this is object of the array index out of bounds exception class, and here this is a variable. This arithmetic exception is not the parent class of this one, right? As you can see in the hierarchy, array index out of bounds exception is not the child class of this arithmetic exception. You see, only index out of bounds and then runtime exception is the parent class of this array index. But this arithmetic exception is not the parent class of this array index. So what will happen when I run this? You'll get the exception. It will not be handled, guys. Catch block cannot handle this. You see, the exception will be thrown to the JVM and it will be printed like this, because this particular class is not the parent class of the array index out of bounds exception class in Java. Okay. So we have to use the appropriate parent class, or we have to provide directly the array index out of bounds exception. Either we have to provide the exact predefined class of this particular object that is being thrown as an exception, or we have to provide the parent of that particular class. Then only the exception will be handled. In all the other cases, the exception will not be handled, guys. So that's it, guys. This is all about the exception hierarchy. Okay, this is all about the exception hierarchy. In the next video session, I'll explain about using multiple catch blocks in the try catch block statements. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 191 of Java for Tester series, that is multiple catch blocks. So we can use more than one catch blocks in the try catch block statements. We can use multiple catch blocks in the try catch block statements. So before I practically demonstrate how to use these multiple catch blocks in the try catch block statements, let me show you few things. Fine. So let me show you the basic code for getting a arithmetic exception. So what is the basic code for getting an arithmetic exception? You can simply say int a is equal to divide some number by 0, guys. Okay. If you try to divide some number by 0 in Java, that will result in arithmetic exception. So run this Java application. As you can see, we got arithmetic exception. So more details about this exception I already covered in the one of the previous videos. So similarly, if I try to assign more than the required values into an array. For example, there is something like integer array, and I have set the size of this array to only 2 elements. Okay, that is, but if I try to assign some like this, okay, if I try to assign a value to the element which is not there, so 2 elements means a of 0 and a of 1 is only possible. A of 2, a of 3 cannot be possible. If you still try to store some value into this such kind of array element, it will result in array index out of bounds exception. So right click run as Java application. Observe that we got array index out of bounds exception. Only index 0 and 1 is possible because only 2 elements. Here index value is 3. You cannot assign a value to an element with index 3 into an array whose size is only 2. That is only index 0 and index 1 is possible. So in this kind of cases, we are going to get another type of exception known as array index out of bounds exception. Even I covered this array index out of bounds exception in one of the previous videos in detail. And another type of exception, guys, let's say some string str is equal to, I'm giving my name here. Okay, now I will say str dot caret I'll give the index value as 55. Okay, is there any index value 55? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Only up to 11 index is possible, but here I am saying retrieve the character which is available in this particular string at the index 55. Only 11 is there, but here I am asking to retrieve from 55th index, which is not there in this string literal, right? So in such kind of cases, we are going to get which kind of exception? Another exception, guys. String index out of bounds exception we are going to get. Okay, string index out of bounds exception. This is third type of exception. Okay, like this in Java we have different types of exceptions, right? So, but guys, what I will do here is I will create a basic try catch block. Now you got some idea about different exceptions that are possible, right? So one example I showed you of arithmetic exception, another one is of array index out of bounds exception, and another one is string index out of bounds exception. Three practical demonstrations I showed you right away, right? Now I'll go with the basic try catch block, which has only one catch block. Okay. Inside the try block, I will give something like int a is equal to 10 by 0. What exception we will get here, guys? If I say int a is equal to 10 by 0, what type of exception we are going to get? This will result in arithmetic exception, right? So I'll write something like this, catch. I have to write something like this, arithmetic exception, right? Exception E. Okay. So system.out.println, I'll write some specific statements like arithmetic exception handled. Okay. So if you get an arithmetic exception, I want this catch block to be invoked and this arithmetic exception to be handled. So when I run this, right click run as Java application. I'll get arithmetic exception handling message. That's fine. So what if here I don't have a statement that throws arithmetic exception? Instead, I have an array. Okay, integer array. Let's say integer array is called new int of sum 2. I am trying to assign a of sum 9 with some value, say sum 5. Okay, so only to the index 0 and 1 is possible, but here index 9 is there. In such kind of cases, if I run this, right click run as Java application, I'll get array index out of bounds exception. Here, whatever the exception I'm handling is arithmetic exception, but here I am getting array index out of bounds exception. Since that exception is not handled in the catch block, okay, we got the exception directly in the output. Okay, exception is not handled and printed into the output. So to avoid that, I can write another catch block is, okay. So this statement may have arithmetic exception. This statement may result in arithmetic exception. It may result in array index out of bounds exception. So to handle such kind of multiple situations, I may write array index out of bounds exception like this. Okay. So if not this catch block will be invoked. Okay, multiple options. System.out.println. System.out.println. Here, if this particular catch block is kind of invoked, I'll print array index out of bounds exception handled. Okay, array index out of bounds exception handled. Okay, so if I run this code, will the exception will be handled, guys? Here we have two catch blocks, and this code is going to throw array index out of bounds exception. So in the first catch block will be checked, and it has arithmetic exception. So this particular catch block will not work. It will not be, this first catch block will not be able to handle this array index out of bounds exception thrown by this try block, and the control will go to the second catch block where we have the array index out of bounds exception to be handled. Since we are getting the array index out of bounds exception, the second catch block will be invoked and this particular statement will be printed. Okay, right click run as Java application. Sorry, I selected wrong option. So let me run it again. Right click run as Java application. As you can see, array index out of bounds exception got handled. Okay, array index out of bounds exception got handled. What if here we have, what if I comment this? And if I have this int a is equal to 10 by 0. In this kind of situation, what message will be displayed, guys? Arithmetic exception handled or array index out of bounds exception handled? Here, since this particular statement throws arithmetic exception, this catch block will be invoked and this particular statement will be printed. Okay, let's see whether we are getting the proper output or not. You see arithmetic exception. And if I comment this and if I uncomment this, which message will be printed? Which exception will be handled? Array index out of bounds exception should be printed. So right click run as Java application. Okay, like this, array index out of bounds exception. Okay, so like this, guys, we can have multiple catch blocks specified in the try catch block statements. So what if we got a situation where we didn't get arithmetic exception or we didn't get any array index out of bounds exception? Okay, despite of having multiple catch blocks, one catch block is taking care of the arithmetic exception, another catch block is taking care of the array index out of bounds exception, but still we got another type of exception from the try block. Let's say string str is equal to Arun Motori. If I say str.char@, some 55 index. Okay, here string index is up to 11 only, but I am giving 55 index. In such kind of cases, I am going to get a different exception, guys. Other than arithmetic array index, I am going to get another exception type. So if I run this, I'm going to get the error directly in the exception directly in the output, because these two catch blocks cannot handle this exception. This exception is different exception, guys. That is string index out of bounds exception. But here we have the catch blocks to handle only arithmetic exception and array index out of bounds exception. So guys, finally what we can do here is we don't know what type of exception that can be thrown, right? If you are clear, like this statement may lead into arithmetic exception, then you can provide this catch block. If there are some block of code which has possibility of both arithmetic exception and array index out of bounds exception, you can provide two catch blocks. But if you have a block of code which may give you arithmetic exception, array index out of bounds exception, or a different exception that we cannot imagine, in that case we can simply say catch, simply give exception E, okay, exception E, system dot out dot println, okay, exception got handled. Here we are giving a generic message, guys. Okay, we don't know which exception we are going to handle. Okay, so this exception class will handle all the types of exceptions. It may be arithmetic exception or array index out of bounds exception or any other exception. Since we already have this arithmetic exception, this catch block will take care of the arithmetic exception. We already have this array index out of bounds exception in the catch block, second catch block. This will take care of the second, okay, second type of exception, array index out of bounds exception. And if not arithmetic array index, if another exception is coming, in that case, third catch block will take care of that, guys. We'll get exception got handled message. It is a generic message. Okay. And this kind of catch block should be provided at the end, guys. Okay. All the basic all the child class exception classes should be provided first in the order. Okay. First the arithmetic exception comes, because arithmetic exception is the child class of the exception predefined class in Java. Even array index out of bounds is also child class of the exception. So first child class exception classes should be there in the catch blocks, and finally we have to go to the parent. Fine, right click run as Java application. You see exception got handled will be printed, because this particular statement is throwing you the string index out of bounds exception. But here first catch block arithmetic exception no match, so this will not be invoked. Second one is array index out of bounds exception, which is no match with the string index out of bounds exception, so this is also not matched. And finally we'll go with the third catch block. Okay, here we have exception class, which is a parent class of different exception classes in Java, like arithmetic exception, array index out of bounds exception, and string index out of bounds exception. So this exception class can take care of all the other exception types. Hence, this particular catch block will be invoked, and the string index out of bounds exception will be handled by this catch block, and this particular message will be printed on handling, after handling. Okay. So guys, like this, we can have multiple catch blocks in the try catch block statement, starting with the child class, child exception classes, and going to the parent exception classes. Okay. So run this, and we already got the answer. Okay. So to upgrade this, we can also, in the real time, we can actually do something like this. Again, catch block, we can say string index out of, if you know the exception type, then you can simply provide this child class exception classes before the final exception class. Okay, for safe side, you can keep the exception class at the end, guys. Okay, like this, catch, and here, where is the end? Okay, system dot out dot println. Here I will say string index. We are going to get the specific messages, right? Which exception got occurred and all we'll get with this kind of approach. With this kind of approach, we are going to get the specific messages, right? If the arithmetic exception has occurred in this block of code, then we'll clearly get this message like arithmetic exception got handled. And if we get array index out of bounds exception, then we'll clearly get the message like array index out of bounds exception got handled. If we get string index, then string index out of bounds exception message will be printed in the output. So that's how by using the multiple catch blocks, we can get specific messages. And for the safe side, at the end of all this multiple catch blocks, just provide this exception E, guys. If in case you get an exception out of all this, if you get an exception which is not there in arithmetic or array index and string index, if you are going to get another type of exception from this block of code, the final safe side exception class will sort it out all. Okay, will sort out everything for us, guys. Okay, the final catch block will sort out everything for us. So right click run as Java application. Fine, string index out of bounds. We got a specific message. Instead of generic message like exception got handled, we got a specific message like string index out of bounds exception got handled. And similarly guys, if this catch blocks, if we are going behind this catch blocks, for example, if we are going behind this exception classes, okay, there are some situations where we not only get exceptions, we also may get errors. Okay, so the exception class cannot handle the errors. Okay, there are like two types of errors. Like one is direct error, there's no possibility of handling that error. Okay, it's not an exception. Except errors are of two types, which can be handled and which cannot be handled. So there are errors like which cannot be handled. Such kind of errors cannot be taken by exception, guys. Okay, The errors which can be handled, that is exception type of errors, can only be handled by this exception class. Okay, if this particular code is resulting in some error which is not an exception, okay, in that case this exception class cannot handle. For more safe side, if you want this catch blocks to be more safer, okay, at the final moment you can say throwable. As explained in one of the previous videos where I explained exception hierarchy, I explained you throwable is a parent class of this exception class in Java, right? So this exception class can only handle the exceptions. Different type of exceptions can be handled because this is a parent of all the exception classes. But throwable is a parent of the exception class. It can not only handle the exceptions but also the errors. Okay, in the Java programs, not only the exceptions but also the errors. Okay, so if you are in a situation where even after keeping this exception class, if the things are not sorting out, okay, simply put the throwable, guys. Okay, it will get sorted out. So here error got handled, I will say. Okay, if not exception, finally error. Okay, it's an error. So right click run as Java application. Fine. Anyhow, we got string index out of bounds exception. Okay, so like this, guys, you can have multiple catch blocks, and first we have to start with the child exception classes, then exception class. Even after exception class also, if it's not figured out, then we have to go with another catch block which has a throwable class. Okay, this is the final parent class in the exception hierarchy. Okay, which can handle both errors and exceptions. This one can handle only exceptions. All types of exception can be handled here. This one both errors and exceptions. This one only string index out of bounds exception. This one only array index out of bounds exception, and this one only arithmetic exception. Like this, guys. Okay, if you come across such kind of situation, you can actually use multiple catch blocks in your Java programs to handle such kind of situations. So guys, this is all about the multiple catch blocks and how to use them in Java. Fine. In the next video session, I'll explain how to print exception details in different ways. So far, we are printing normal print statements. Okay, we are not printing anywhere the exception details. We are directly printing this exception occurred and that exception occurred, but we have not actually printed the details of the exception. Okay, so which I am going to explain how to print the exception details, this object reference. Okay, we can use this object reference to print more details, guys, about this exception. Okay, instead we are simply printing the normal print statement by writing a normal text, okay, related to that exception. But using this object reference, we can actually print out more advanced details into the output. So that thing I'll explain in the next video session by explaining printing exception details in different ways. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 192 of Java for Tester series. That is printing the exception details in different ways. So far, till the previous videos, I've explained or used normal. I've used normal system dot out dot println some message. Okay, in order to print the exception details, I've used the normal system dot out dot println message, right? But in this video session, I'm going to show you the different ways in which we can print the exception details. Right, in the try catch block, the catch block, whenever an exception has occurred, the catch block have used this normal system dot out dot println message in the catch block, right? But in this video session, I am going to show you the different ways in which we can print the exception details in the catch block. Okay, what are the different ways in which we can print the exception details inside the catch block that I am going to practically show you in this video session. So guys, let's switch to the practical mode now. So let's create a program. I will create a variable a by declaring that with integer int data type. That's fine. Then I'll try to assign this variable a with a value like 10 by 0. Okay, I'm going to divide the number 10 by 0, which will actually give an exception. It will throw an exception, guys, right? That kind of value I'm trying to assign to the variable a. Anyhow, when this particular statement gets executed, okay, this will give you an exception in the output, right? Directly the program execution will stop and we'll get an exception or exception error details in the output. Without handling the exception, we will get the exception details in the output. Now, if I try to print the value of a like this, a, okay, So will this statement be executed or not? As we are getting an exception here, here we'll get an exception, right? Exception will be thrown here. So if an exception occurs here and if it's not handled, that means the Java will throw this exception directly to the JVM and JVM will directly stop the program there itself. The program will stop there itself in the second step. It will not move any further. That means this particular print statement after the second step will not be executed at any cost, right? Let's run this and see. We are expecting the same. Whatever we are thinking is happening or not. As you can see, in this line 8, that is A is equal to 10 by 0, we got an exception known as, we got an exception in this main method, that is java.lang.arithmetic exception we got. And the reason for the exception is we have divided the number by 0. Okay, divided by 0. The number got divided by 0. This is the reason, guys. This is the class of the exception that has been thrown. Okay, this statement has thrown an object of this arithmetic exception. This statement has thrown an object of this arithmetic exception predefined class. Okay, as an error, an object of this arithmetic exception has been thrown here, and the reason is divided by 0. Okay, and where exactly the exception has occurred? At demo class, inside the demo class, and inside the main method, inside the demo class, inside the main method. Okay, at the line 8, at the line 8 we got this exception. So this is how the exception details are being printed, right? And here the problem here is we have not handled the exception. That's the reason this print statement has not been executed. The statement which is coming after this exception has not been executed. As you can see, the A value has not been printed here, right? Fine. Now, so what I'm going to do now is I'm going to handle the exception using the try catch block. So let's do that. Try. Okay, I'll use try block. Inside the try block, I will put this statement so that I can handle it. Then I will provide the catch block. I will say exception E. Simply inside the catch block, whenever this exception is handled by this catch block, I'll simply print out a message like this: system.out.println. This is what I have been doing. Okay, this is what I have been doing in the previous videos. Till the previous videos, I'm simply printing this message. Okay, some exception got handled. Such kind of generic messages I used to print using this normal print statement. Okay, till this time. So right click. Here we are getting an error. When I saved it, I am getting an error, guys. I cannot run this with this error, right? Over the mouse, it says that local variable A may not have been initialized. Okay, why I'm getting this error, guys? It is asking you to initialize this variable A. Okay, this particular error, compiler error. This is a compiler error, guys. Okay, this is asking you to initialize the variable A. Why it's asking you to initialize the variable A? Because it is not able to understand, like we have already initialized, guys. As you can see, A is equal to 10 by 0. This state initialization is already done inside the try block. But as you know, this try block is restricting the scope. Okay, the visibility of this variable A, whatever the actions that are being done to the variable A are being restricted by this try block. Only they are visible inside the try block. That's the reason, guys, this variable A outside the try catch block is not able to understand whether this variable A is initialized or not. It is initialized inside the try block, but the visibility is restricted outside the try block. So here, what I have to do in order to overcome this situation, I have to say A is equal to, I have to assign some default value. Default integer value generally is 0. Okay, generally if you have to provide some value to the variable A which is declared with some int data type, you have to provide the 0, guys. In case of string, we have to provide null. Okay, if there is something like string B is equal, okay, string B, if you have to initialize with some default value, you have to say B is equal to null. But in case of integers, okay, in data type, we have to assign a value 0 as a default value. Okay, this is the general thing. Fine, 0 is the default thing, that default value that can be assigned to the variable A of in data type. As you can see now, the error got resolved. Okay, so the initialization is there and it's not being observed by this program. We are getting some error. That's the reason I have to manually initialize it. Okay, have to initialize it at any cost. For that, I have to initialize this variable A with some default value like 0. Okay, fine. Now save it. Now things are good. So here, guys, what will happen when I run this program? A will be initialized with 0, that's fine. Then we'll go inside the try block and A will be assigned with some value, but this value will not be assigned to the variable A, guys, because when you divide the number 10 by 0, immediately we are going to add the exception and this assignment will not happen. Okay, an object of this arithmetic exception predefined class will be thrown from this try block and will be assigned to the variable E of exception predefined class, and the catch block will handle the exception by simply printing this normal message like exception got handled. Okay, nothing more than that. After the exception got handled, this statement will be printed. Since this initialization doesn't happen, it will consider the initial initialization, that is A is equal to 0. So here 0 will be printed. So simply we'll get the normal message like exception got handled and the value of A, that is 0, will be printed. Let's see. Right click, run as Java application. Exception got handled and we got the value as 0. Okay, that's what we expected. But I don't want this normal messages like exception got handled and all those stuff. Instead, I want to use this object reference of this exception class. Okay, why I'm going to use this object reference? I want to print the exception details in different ways here. I don't want to use the normal system.out.println statements with normal messages. Okay, instead, I want to print the exception details in a different way using this object reference of this exception class. Why I have to use this object reference of this exception class? Whenever an exception is thrown in terms of an object of the predefined class of the exception class, okay, that object will be assigned to this variable, right? This object reference has all the details of this exception thrown, right? So using this object reference, I can simply say system.out.println. I have to simply print the E, guys. Okay, just provide this object reference here. Okay, which is holding the exception thrown by this try block, right? So when you print this, when you run this, the exception details will be printed, as you can see. Okay, I'm not giving any message, normal message here. Instead, I am directly printing the exception details thrown by this try block to this catch block. Okay, right click, run as Java application. As you can see, what's happening, guys? This is got printed. When I print the variable E here, object reference E here, I got the class name of the exception that has been thrown from this. Okay, this statement has thrown which exception? This statement has thrown which object of exception class? Object of the arithmetic exception class has been thrown. So java.language is a package name under which we have this arithmetic exception predefined class. So object of this arithmetic exception predefined class is thrown by this statement that has been printed. Along with that, the reason for the exception also got printed. The reason here is we are dividing the number by 0. That's why we got this arithmetic exception we got. Okay. So here this is not an error kind of thing. It's a normal message, you can see, right? I didn't provide the message like arithmetic exception got displayed or divided by 0. Automatically it came. When I printed this object reference, automatically the exception type and the exception class and the message, the reason for the exception got printed. So what if I don't want to get both the details? Okay, I don't want to print both the details of the exception. Instead, I want to only print the message. Only this message I want to get. Okay. So let's say I will customize a statement like this. The reason for getting this exception is, okay, the reason for getting this exception is, some colon I will give here to print, plus E dot, I'm using the same object reference E, guys. You can give a, if you are giving some B here, you can give the same B here. Okay, you can give any variable name here. So I'm giving E here, so I'm giving the E, same E here. E dot, if I say E, both the exception class type and the reason for the exception both will be printed. But if I want only the message, I have to say E dot get message. E dot get message. Okay, if I run this now, you see, this time the reason for getting this exception, is, what is the reason? You are dividing a number by 0. Okay, that's the reason you are getting the exception. So only message part will be printed. What if, okay, what if I don't want to get the message, but I only want to get the exception type? Okay, the exception type is, okay, the exception type is E dot, okay, E dot get class. Okay, only the exception class type, okay, will be printed without any message. Like this, guys, there are different ways we can actually print the exception details. The exception class type is java.language.arithmetic exception is a class type. Okay, here there is no message. Earlier we got only message, now we got only class type. And initially when I printed directly, we got both class and message, right? So there is another way also. If you want to get more details about the exception, okay, if you want to get complete details about the exception, okay, after handling the exception, if you want to get the complete details of the exception, what you have to do is, you don't have to do any print statement, guys. Instead you have to say e dot directly e dot print stack trace. Okay, there's a method known as in print stack trace. Okay, e dot print stack trace. So when I run this, complete details, guys, not only the exception class type, not only the exception message, the reason behind the exception, but also the place where the exception has occurred also will be printed. You see, Java, this is the exception class type got printed. E dot print stack trace is printing the class type exception, the type of the exception got that occurred, and the reason for the exception, that is divided by 0, the second thing, and the place where the exception got occurred. Okay, in the demo class, inside the main method, at the line number 10, that is 10th line, we got the this thing. Okay, so this is how, guys, we can print the exception details in different way. If you only print E, what's happening? The exception class type and the reason for the exception are getting printed. If I say e dot get message, only the reason for the exception will be printed. If I say system.out.println e dot get class, only the exception class type that occurred of the exception occurred will be printed. If I say e dot print stack trace, not only the exception class type, not only the exception message, reason for the exception, but also the place where the exception got occurred will also be printed. And after that, as you can see, the value of the a will be printed. Because the exception got handled, we'll get the value of the this particular statement will also be executed, and the default value, that is 10, will be printed in the output. Okay, like this. Fine, guys, these are the different ways. Okay, these are the different ways we can print the exception details in Java. Okay, whenever an exception occurs, instead of providing a normal system.out.println message, okay, you can use this kind of methods, e dot get okay message, or e dot print stack trace, e dot get class, or directly printing e will allow you to print the different levels of exception details in the Java programs. But guys, there is one question here. Okay, so where these methods have come from, where this e dot get message, e dot print stack trace, okay, or e dot get class, all these methods, where exactly they have come from? If you remember, in one of the previous videos, I explained about the exception hierarchy. Okay, I explained about the exception hierarchy in one of the previous videos, where object is the parent of all the classes in Java, right? Under object, if you refer to the exception hierarchy, the first root class of the exception hierarchy will be, okay, throwable. Okay, throwable is the predefined class of the exception hierarchy, which has object class as its parent class. Fine. And under throwable, we have exception, right? Under exception, we have other things. We have different things. Okay. Under exception, we have runtime exception, and all the other child exception classes are there. Okay. So here, all these classes, okay, I'll say child exception classes will be there under this exception predefined class. So all this child exception class and this exception class are inheriting or extending which class, guys? Throwable class. Throwable is the parent class of all the other exception classes in Java. So this throwable class, if you go to this throwable class in the Java API, search for Java 8 API in Google, and you will be taken to this results, and you just click on Java API and Control F, search for throwable. Okay, throwable is a predefined class, which is the parent class of all the exception classes in Java. It only has one parent class known as object class, because object class is parent class of all the classes in Java. So every class in Java will have to be extending the object class, which is going to be object is the root or parent class of all the classes, guys. Okay, coming to the exception classes, throwable is the parent of all the exception classes. Okay, under throwable we have the subclasses like exception and error, like that, right? So here, as explained in the exception hierarchy video, I explained everything there, guys. If you want to learn more about this exception hierarchy, you can refer to the previous video in this series. Okay, so inside this throwable class, if you go down a bit, it has some different methods. Okay, it has some predefined methods. This exception, this throwable class has some predefined methods. That is, what are the methods, guys? There are different methods, like whatever the methods we use. That is get message. It only gets the message. Okay, that is exception message will be retrieved, right, and printed. And we have other thing that we have used is the like get. Where is that? Okay, get not this one. Print stack trace, right? We have used print stack trace also. Okay, this also belongs to same. Okay, this also belongs to the same throwable class. Okay, so all these methods are inherited. That's the reason, guys, we are able to use. Okay, all the methods of the throwable class are inherited because these are the child classes which actually inherit the methods and variables of this throwable class, right? So that's the reason, since this throwable class has this methods like get message and print stack trace, we are able to use them with the other classes like exception class also. Object reference of this exception class can also use that e dot print stack trace. Okay, why I'm saying e dot print stack trace here directly? How can I say e dot? This is an object reference, guys. Okay, using the object reference, I'm calling I'm using this, right? E dot object reference dot print stack trace. Okay, fine. So what else? That's all, guys. That's all. That's all about the different ways of printing the exception details. Okay, in try catch blocks in Java. So that's it. And in the next video session, I'll explain about throw. There is some keyword known as throw in Java, and it is related to the exceptions only. Okay, this throw keyword is related to exceptions. So the purpose of this throw keyword in exceptions, I will be explaining in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 193 of Java for tester series, that is throw keyword. So what is this throw keyword? Throw keyword in Java is used for manually throwing the exceptions. If you want to manually throw the exceptions based on some condition, if you want to manually throw the exception, we have to use this throw keyword in Java. Okay, so in order to understand this throw keyword better, we have to switch to the practical mode. So let me switch to the practical mode and explain about the throw keyword. So before I practically demonstrate how to use this throw keyword in a practical way, let me explain you few other things in a practical way. For example, if I write a statement like this, int a is equal to 10 by 0, what will happen, guys? This statement will throw an exception because you are dividing the number 10 by 0. So Java will automatically throw an exception. You don't have to manually throw the exception in this case. Here, Java will take care of throwing the which exception, guys? In this case, arithmetic exception. Arithmetic exception will be thrown by Java. Okay. Here you are not manually throwing the exception. If you run this, you can see that you'll get an exception. You'll get an arithmetic exception in the output, right? So here Java is throwing the exception here. But what if I want to manually throw an exception based on some condition? Okay. So there is no problem in the code, but still I want to, based on some condition in the code, I want to throw an exception based on my need basis. Okay. So in such kind of cases, we have to use throw keyword, guys. So let me create such kind of condition where I want to throw an exception, okay, manually. So for example, I'll create a variable like int age is equal to some 5. Okay. I just created a variable named age, okay, with the value assigned as 5. So I'll create some condition here, guys. If age is less than 6, okay, if age is less than 6, then I'll write a statement like this: throw new exception. Okay, throw new exception. I'll say. Otherwise, if the age is not less than 6, then I will say system dot out dot println. Okay, welcome to our, or else you can say you can register in our website. Okay, you are eligible for registering in our website. So let's assume that there is a website, web application, which actually checks whether your age is either equal to 6 or greater than 6. Okay, if your age is minimum 6, then you are eligible for registering in that website. So such kind of condition we have to check. Okay, so if your age is like equal to or greater than 6, minimum 6, then it will allow you to register in their website. Otherwise, we want to throw an exception. Okay, so for that I have to use a statement known as, I have to use this keyword known as throw, guys. Okay, throw, and throw will throw an object. Okay, this throw keyword will throw an exception of an object. So exception is nothing but object of a particular class, right? So here exception is a predefined class in Java, and we are creating an object for the exception class. So this throw keyword will throw an object of this exception predefined class, so that exception will happen. But guys, before I execute this, I cannot run this because I'm already getting a compiler error. Why I'm getting a compiler error here while using throw new exception? When you hover the mouse, it says that it's an unhandled exception. Okay, it's an unhandled exception. So that means you have to handle it. How to handle the exceptions in Java, guys? You have to put this code inside the try catch blocks. Okay, try. Just put this if condition inside the try block. Okay, and here provide something like catch, some exception E. Okay, like this. System.out.println. Okay, system.out.println. You are not, your age is less than 6, hence you are not eligible for registering in our website, like this. Okay, so we can create such kind of logic, guys. Okay, based on the condition we can throw an exception. Here we have to surround this with try catch block so that you can see the compiler error got resolved. Okay, this particular statements wants you to handle the exception, then only it's allowing you, guys. Okay, then only it's allowing you to move forward. So I have handled the exception, and as you can see, when this statement will throw an exception for sure. Okay, since the age is equal to 5, that means age is less than, okay, age is less than 6. Okay, here condition is age is less than 6, 5 is less than 6, true or false? True. So it will throw an exception. Okay, it will throw an exception. So fine. So what I will do is I'll write something here. If age is greater than or equal to 6, then only I will print this. Okay, otherwise it will be printed every time, because exception will be handled here using the try catch block. Even after the exception is thrown because of age less than 6. Okay, since it is handled, this particular statement will be printed, right? After handling the exception, the statement will be printed. Even though they are not eligible, your eligible will be printed. That's the problem. So I have to cover this with age greater than or equal to 6 condition. Then only it will be printed. Fine. Anyhow, since the exception is handled here, whatever the this is here, you are manually throwing the exception, guys. Using this throw keyword, you are manually throwing the exception based on this condition. Okay, you have created a condition here. Based on this condition, you are manually throwing the exception, guys. Okay. So even after it is handled, it will check whether the age is greater than or equal to 6. Then only it will print you are eligible. Okay, fine. Anyhow, so let's run this, guys. Let's run this code and see what's happening. Right click, run as Java application. So it will say that your age is less than 6. Hence you are not eligible for registering in our website. That means what happened here is in try block, this condition has been passed, and hence this throw new exception has been executed. So this throw keyword has manually thrown an object of this exception class, and hence the exception will be thrown, and that thrown exception will be saved into this object reference of this exception class and will be handled by this catch block. When this catch block is invoked and handled, when this catch block is invoked and the exception is handled, this particular print statement will be printed. So that's the reason, guys. your age is less than 6, hence you are not eligible for registering in our website has been printed in the output. Okay, from the catch block, whatever the print statement that is there in the catch block got printed in the output. That's fine. Okay, and the next thing here is if age is greater than or equal to 6, okay, then only you are eligible for your registering in our website will be printed. Since age is less than 6, this has not been printed. Okay, so what if I make the age to 10? If I make the age to 10, what will happen, guys? In this case, we'll go inside the try block. Age is less than 6 is false. So this manual throwing of the exception will not happen. Okay, since there is no exception here, catch block will not be invoked. And hence directly we'll go here if age is greater than or equal to 6. Here 10 is greater than or equal to 6. That is true. So you are eligible for registering in our website will be printed. Okay, if there is an exception, then your age is less than 6 will be printed. Otherwise, you are eligible for registering in our website will be printed. For creating such kind of logics, guys, we have to use this throw new exception. Okay, and also guys, and also for example, you don't want to print it separately. Okay, you don't want to print this particular thing separately. Otherwise, what you want to do here is instead of this one, you want to provide a message here itself. Your age is less than, in this exception method itself. Okay, in this exception constructor itself, I am providing this one. Your age is less than 6, hence you are not eligible for registering in our website. Okay, instead of printing the message, I am just providing this as a message in the exception constructor. Okay, so along while the object of this exception class is thrown by this throw keyword. Okay, along with that, this particular message will be carried, guys. Okay, so how to get that message, guys? So we have something known as e dot print stack trace. Okay, which will print the exception and also the message, right? So and the place where the exception has occurred also. Complete details will be printed. So here age is still equal to 10. So I'll change it to 5 so that it will throw an exception here, manually throw an exception with this particular message. Earlier, I have thrown the exception but without the message. But this time I'm throwing the exception with the message. Okay, that's the difference. Right click run as Java application. You see, Java, what is the class type? Exception. Because we are throwing an object of the exception class, so exception will come here. And along with the message, what is the message? What is the reason for the exception? Your age is less than 6, hence you are not eligible for registering in our website. Okay. What is the place at which this exception has occurred? In the demo class, inside the main method, at the 11th step, that is this one, throw new exception. This is throwing the exception. Okay. So other than that, if you only want to throw like, if you only want to print, what do you call the message, then you can say e dot get message. Okay, e dot get message, run it. You see, only the message related to the exception will be printed. Okay, what if only the class e dot get class? Okay, get class method is a predefined method of the object class in Java. Okay, since object class is parent class of all the classes in Java, including the exception class, we can use this get class with the object reference of this exception class. Okay, so let's see, it will print the exception class. Okay, simple. Whatever the exception class object of the class name of the object, okay, that is thrown here will be printed here. So right click run as Java application. You see, exception class that is exception class under the java.language has been thrown. Okay, the object of this particular class has been thrown. And any other things, if you only print e, what will happen? Right click run as Java application, the class and the message along with these things will be printed, but it will not print the place where the exception has occurred. Okay, so anyhow, I explained the different ways of printing the exception details in the previous video. And here our focus is more on the throw keyword, guys. We are using the throw keyword for manually throwing the exception. Okay, here object of the exception class has been thrown with this particular message. We can even change this, guys. You don't have to provide exception here. You can say arithmetic exception also. Okay, it's not correct, but I'm just showing you that you can actually provide arithmetic exception also here. This example is not suitable for arithmetic exception, throwing the arithmetic exception, but still I am providing that here. Okay, so let's run this. Right click run as Java application. As you can see, arithmetic exception has been thrown. Whatever the class you provide here, the object of that particular class will be thrown, guys. Okay, using the throw keyword, we can manually throw any type of exception. Okay, and with the message. So like this, guys, we can manually throw the exceptions based on our desired conditions in our Java programs using the throw keyword in Java, guys. Okay. So that's it about the throw keyword. In the next video session, I'll explain about the other topic of exceptions, that is checked and unchecked exceptions in Java. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 194 of Java for Tester series, that is checked and unchecked exceptions. So, exceptions. Exceptions in Java can be categorized into two types, that is checked exceptions and other one is unchecked exceptions. Checked exceptions and unchecked exceptions. So what are checked exceptions and what are unchecked exceptions? Let me explain. So let's start with the unchecked exceptions, guys. So what are unchecked exceptions? So unchecked exceptions are the exceptions, okay, which can be only identified during the execution. Okay, when you execute the program, on executing the program, you find out that there is a particular exception in the code. Okay, such kind of exceptions are known as unchecked exceptions. Okay, here compiler won't be able to find these exceptions. Only when you run the program, you will come to know that there is some exception in the code. Okay, but the compiler will not be able to identify before executing the code. The compiler will not be able to identify and give some compiler error. There will not be any compiler error in this kind of case, guys, because compiler will not be able to identify the unchecked exceptions. You can only identify the unchecked exceptions on execution. That is during the runtime only. During the runtime only, these exceptions will be identified. Okay, fine. Since these exceptions are kind of identified during the runtime, okay, we can also call this unchecked exceptions as runtime exceptions. Okay, there is another name for this unchecked exceptions, guys. We can also call this unchecked exceptions as runtime exceptions because these exceptions are generally identified during the execution. Okay, so we'll come to know that there is an exception in the code only after running the program. Before running the program, our compiler will not help us in identifying them. Such exceptions are known as unchecked exceptions or runtime exceptions. Let me give an example for this unchecked exceptions, guys. Fine. So I'll write a statement like this: int a is equal to 10 by 0. Okay. Did we get any compiler error here in this particular statement? Did we get any compiler error, guys? I didn't get any compiler error. So if I run this program, right click, run as Java application, but in the output during the execution, I got this runtime exception. And the name of this runtime exception is arithmetic exception, right? We got this unchecked exception known as arithmetic exception during the runtime. Okay. So such kind of exceptions are known as such kind of exceptions. The example here is arithmetic exception. So here unchecked exception, one example for unchecked exception is arithmetic exception. Okay. Any other example for this unchecked exceptions, guys, which can only be identified during the execution or runtime? Another example is array index out of bounds exception. For example, if I create an integer array here, int a is equal to new int of sum2. Okay. But if I try to assign array index 5, a of 5 with some value 9, okay, like this. If I try to assign something like this, so what will happen here, guys? Am I getting any compiler error? No, I am not getting any compiler error. But when I run this program, I am going to get an exception. During the runtime only, this kind of exception will be identified. Okay. So there is a problem in the code. Such kind of problem or error in the code is identified during the runtime. During the execution only, we are able to find the problem. The problem here is array index out of bounds exception. Okay. The reason here is 5. You are assigning a value of 9 to an array at the index 5. But this particular array has a size of only 2. But you are assigning at the index 5, which is not possible. Okay. Up to index 0, a of 0 and a of 1 is possible because size is 2 here. But here you are assigning a of 5 is equal to 9. It is not possible. That's the reason we got this array index out of bounds exception. But here guys, the thing that we have to focus here is our compiler has not identified this exception in advance, right? We didn't get any compiler error while writing this code. But when I run this program, I got this array index out of bounds exception. So such kind of exceptions which are identified during the execution of the program, okay, that is during the runtime, are known as unchecked exceptions or runtime exceptions. Okay. So another example for this unchecked exception is array index out of bounds exception. Okay, array index out of bounds exception. So there may be more exceptions. Okay, under this unchecked exceptions. The main examples I gave here are arithmetic exception and array index out of bounds exception. Apart from this, there may be other type of exceptions that can be identified during the runtime only. Okay, fine. So guys, now coming to the other type of exceptions, that is checked exceptions. Okay, other type of exceptions is checked exceptions. So what are checked exceptions? So in contrast to this, here these unchecked exceptions are identified during the execution, but checked exceptions are kind of opposite to this unchecked exceptions. That means can be identified, okay, during the compile time itself. So here guys, checked exceptions are the exceptions which can be identified in advance by the compiler, okay, by providing a compiler error. So here we'll not find out that the exception is going to happen or not, but our compiler will tell that, Java compiler will tell that there is a possibility, okay, the exception may or may not come, but there is a possibility of getting a checked exception. Okay, there is a possibility of getting an exception. This only thing will be provided by the compiler guys. Okay, even though the code you have written may not produce any exception in the runtime, but in case of these checked exceptions, the compiler will provide the possibility of getting an exception. Okay, during the compile time itself, we will get an indication by the compiler that there is a possibility in this particular code to raise an exception, okay, to get an exception. Such kind of exceptions, okay, such kind of exceptions where the compiler is giving the possibility of getting an exception, such kind of exceptions are known as checked exceptions. Okay, you don't have to wait, you don't have to execute the program to find out whether there is an exception in the code or not. Before that itself, the compiler will give you the possibility of getting an exception. Okay, this code may or may not result in an exception. Such kind of exceptions where the compiler is giving you the possibility of getting an exception are known as checked exceptions. Let me give an example, guys. So guys, whatever the code I'm going to write here, just ignore that. Okay, I didn't explain such code in the previous videos, but just blindly follow whatever the code I am writing. Okay, because whatever the code I am writing is going to be covered in the upcoming videos. But for now, you have to understand whatever the code I am writing here in the context of checked exceptions only. Okay, you don't have to understand this code, but you have to understand the checked exceptions concept behind it. Fine, let me start doing so. Fine. So before writing any code, what I will do here is I have this location in my system, one of the folder, location folder in my machine. Okay, you can also create any folder in your machine and open it like this. Okay, it can be location folder, it can be ABC folder, anything. Okay, in that folder, create a new file. So I will name this file as some ABC file. Okay, some ABC file. Inside this text file, I'll open it and I'll write some sample text Arun Motori, something like this. Okay, sample text by Arun Motori. Some text I have written inside this file. That's fine. I just created a sample file, guys. Nothing more than that. Okay, in this folder, in one of the folder in my machine, I created a sample text file. That's it. Okay. So here, in order to represent this particular file, Java is providing a predefined class known as file class. Okay, there is a predefined class known as file class. So I will name this as ABC. File ABC is equal to new file. Okay. And here I have to say double quotes, put the semicolon here. So I'm getting some compiler errors already. Over the mouse on this file, and it's asking you to import the package. This particular file predefined class of Java. File is a predefined class of Java, guys. Okay. Under which package this particular file is available? Java.io. Since this file package is in a different package, file class is in a different package like java.io, we have to import. Okay. I explained in one of the previous videos on the packages. We have to import this particular file predefined class of Java from this java.io package, not to use it. That's fine. So now the compiler errors have been resolved, right? But here I have to represent the file. Okay, this statement is used for representing a file on your computer. On your computer. So I want to represent this particular file known as ABC file on my computer. So how to represent using this file ABC is equal to new file ABC. Okay. So here I have to give the path of this particular file completely. So first I need to copy this path, guys. So here before while I'm copying, as you can see, single slash is there. But when I try to paste here, I will get the double slash. This is the correct format of providing the location, guys. Okay. Whenever you provide some file path in your computer, in your Java programs, you have to convert the single slash to double slash. Then only it will work. Okay. Here in your computer, it is single slash. But in the Java programs, when you paste it, Java is automatically converting the proper format. Okay. So if you manually type, you have to make sure that you have to type double slash in place of the single slash, guys. Okay. This single double slash will only work in place of single slash in Java programs. Okay. When you represent a file. For example, after location, have to give ABC dot text file, right? So for that, in order to provide that, I have to say double slash inside the location folder. Instead of single slash, I have to say double slash. Okay. Under this location folder, we have this file. So right click on this file, say properties. And what is the name of the file? ABC. Copy this name of the file and paste it here. And what is the extension of this file? .txt. Okay. .txt. Copy this and paste it here like this. Now guys, this is a statement for representing one of the file on your machine. Okay. Using the file predefined class in Java, we have represented a file in, okay, we have represented a file in our computer, on our computer. Fine. Now things are good. Till now, nothing happened, right? Now I'm going to write another statement. Let's say I'm writing some statement known as file reader. Okay. File reader is another predefined class in Java. I will say fr is equal to new file reader. Okay. File reader fr is equal to new file reader. File reader is another predefined class in Java. Hover the mouse on this file reader. You have to import this file reader predefined class from java.io. Okay. So like this. So here we are getting two java.ios. Okay. Instead of these two things, we can simply make this two hash trick. This will also work, right? All the classes inside this java.io should be imported. So you don't have to import each and every time. Okay. You get some predefined class from java.io package, right? So single statement that will be done. Still, after resolving this importing problem of this file reader class from java.io package, still we are getting a kind of compiler error here. When you hover the mouse, it says the constructor file reader is undefined. That means here you have to provide this ABC, guys, like this. Okay. So now hover the mouse. Again, we are getting a compiler error. We have resolved the earlier problem where this file reader constructor should be provided with this particular file. This file should be the input for this file reader class. Okay, fine. So hover the mouse and it says unhandled exception type, file not found exception. So here, guys, my compiler is, we are getting a compiler error. Okay, compiler error is giving this kind of thing, guys. Okay, compiler is Java compiler is telling you in this particular statement that, okay, there is a possibility of getting an exception. Okay, this Java compiler here is giving this compiler error saying that there is a possibility of getting an exception here in this kind of statement. That's why this kind of exception, what type of exception you may get? File not found exception. Okay, that's why this file not found exception falls under which category? Checked exception category, because in case of this file not found exception, the compiler is telling you in advance that there is a possibility of getting an exception. Okay, so so what we have to do then? The compiler is giving a compiler error saying that it's in advance saying that there's a possibility of getting a file not found exception. So I'm not going to allow you, okay, without handling the program. You have to handle it. After running the program, if you get an exception, what you will do, guys? You will try to handle that code, right? Right? In case of unchecked exceptions, okay. So when you run some code and then during the runtime, if you get an exception, what you will do? You'll go to the code and handle it using the try catch blocks. The same thing will happen here, right? The same thing you have to do here. It also says that you have to handle this. There is an unhandled exception which is possible, okay. It doesn't mean that the exception will come, guys, because if you provide this proper path, if you provide a proper path here, the exception will not come in this statement because this file exists here. But our compiler is just assuming that if in case this file is wrong, this file path is wrong, who knows, right? Who knows this file path is correct? This file may or may not exist at this particular location. Its compiler is thinking in that such kind of terms, and this statement may result in an exception during the runtime. That's why beforehand the compiler is telling you that this particular statement there is a possibility of getting a which kind of exception? File not found exception, because this path may or may not be correct. Compiler is telling you in advance. So it's asking you to handle it. Even after we don't get the exception also, it's asking you to handle it. Okay, fine. So what we have to do, guys? What we have to do in this case? In this case, we have to handle it using the normal try catch block. Okay. So if I say try and then catch, okay. So file not found. There is a possibility of file not found exception, right? Exception. Some e and e dot. If in case we get an exception, we'll say e dot print stack trace. Okay. This is how we can handle the exception. So if the file path is correct, we'll not get any exception. If we don't get an exception, if the exception is handled proper, if we don't get an exception, what will happen, guys? This catch block will not be executed. If you don't get an exception in this statement, this catch block will not be executed. Instead, the statements followed by this try catch will be executed. That is, let's say after try catch, I'll write something like this for our understanding. Okay. So run this, right click, run as Java application. As you can see that after try catch, because why this statement is coming here, the path provided is correct. We have provided the correct path where this ABC file is there. That particular path we have provided, right? Fine. So this file is there at this provided location, and when this particular statement got executed, it has not resulted in any file not found exception. Has okay, the exception has not been thrown here because this ABC path is correct. Okay, that's why no exception has been thrown. Since there is no exception thrown by this code inside this try block, the catch block will be skipped. It will not be invoked. The catch block will be skipped and the remaining statements will be executed. That's why we got after try catch block. What if I intentionally change this path to XYZ? Do we have this xyz.txt file inside this location folder? No, only ABC is there. What if I change to XYZ? This particular path is not available. In that case, when I run this program, right click run as Java application, you see we got an exception. Okay, here we have said e.print stack trace. That's why all the details got printed here. Otherwise, if you want to say only something like the system dot okay out.println exception got handled. I want to print normal statement like instead of e.print stack trace, if I do something like exception got handled, if I run right click run as Java application, only that exception got handled will be printed. Okay, so that means that here the path is wrong. Since the path is wrong, this particular statement will result in an exception, right? That is nothing but file not found exception, and this catch block will handle that. When the catch block is involved because of this exception thrown in this particular try block statement, the statement inside the catch block will be executed. That is exception got handled will be printed here. Since the exception got handled, the statements following the exception handled exception will be printed. That is after try catch will be executed. Okay, the statements following this exception will be executed because we handled the exception. So guys, so this is how we can handle the checked exceptions. Okay, we can handle the checked exceptions, something like this. Fine. I have to explain more about how to handle the checked exceptions. Okay, there are different ways we can handle the checked exceptions. Fine. So before going there, let's understand. Okay, let's at a high level, let me explain you that exceptions are of two types. One is checked exceptions, another one is unchecked exceptions. Checked exceptions and unchecked exceptions. In case of unchecked exceptions, okay, we'll identify the exceptions during the runtime only. Then only we'll find out there's some exception being thrown from the code, right? Before that, compiler will not tell you or hint you or tell you the possibility of getting an exception in the code, right? Or after execution only, we'll find out that this particular section of the code is resulting in an exception. But coming to the checked exceptions, okay, in checked exceptions, the compiler will tell you the possibility of getting an exception. The exception may come or may not come, but the compiler will give you a compiler error saying that this particular statement of code may result in an exception. Such kind of exceptions are known as checked exceptions. Okay, such kind of exceptions are known as checked exceptions. So that's about the checked and unchecked exceptions, guys. And there is more that I have to explain as part of checked and unchecked exceptions in detail. Okay, so that's it about this session. And in the next video session, I'll explain how to handle the checked exceptions. Okay, I'll explain how to handle the checked exceptions in detail. Fine. So that's it, guys. See you in the next video session where I'll be explaining how to handle the checked exceptions, where the compiler will tell you the possibility of getting an exception in detail. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 195 of Java for Tester series, that is handling checked exceptions. As explained in the previous video, there are two types of exceptions. There are two types of exceptions. One is checked exceptions. Other one is unchecked exceptions. Okay, there are two types of exceptions in Java. One is checked exception and another one is unchecked exception. In this video session, I am going to explain how to work with these checked exceptions, work or handle these checked exceptions. So coming to the working of checked exceptions, there are two ways, guys. Okay, how to work with these checked exceptions? There are two ways. Either you have to handle the checked exceptions. Otherwise, we have to ignore the checked exceptions. Okay. So how to handle the checked exceptions? The same way we used to handle the normal exceptions, right? The same way we used to handle the exceptions, we have to use for handling the checked exceptions also. What is the process for handling the exceptions in general, guys? We have to use something known as try-catch block, right? Using try-catch block, we can handle the exceptions. Using try-catch block, we can handle the exceptions. Coming to normal exceptions or checked exception, the process is same. In order to handle the checked exceptions also, we have to use the try-catch block. Okay, there is no other way. And coming to the ignoring part, if you don't want to handle the checked exceptions, okay, then we have to ignore it. Okay, if you don't want to handle the exceptions, checked exceptions, you have to ignore it. So what is the process for ignoring? How to ignore the checked exceptions? We have to use something known as throws keyword. Okay, in order to ignore the checked exceptions, we have to use the throws keyword. Okay, so in this video session, I'm going to practically demonstrate how to handle the checked exceptions using this try-catch block and how to ignore the checked exceptions using the throws keyword. Okay, let me show you. Fine. So before I show you how to handle and ignore these checked exceptions, let's create a kind of program, okay, which actually gives us the checked exception. Fine. So let's write down. Let's represent a file in Java, guys. File is equal to new file. Okay. So I have to give the path of the file here. Before giving the path of the file here, I have to import this file class from java.io. Okay. Then I have to provide the path of the file that I want to represent here. So for that, let me go to this location. This is the file I want to give, guys. This is the location. Copy it, paste into this double quotes and say double slash. Then right click on this file that I want to represent. And then copy the name. I just copied this name, guys, and paste here, and then copy the extension of this file .txt here in this case. Copy this and paste here. Fine. So this file predefined class is now representing this file at this particular location. That's fine. Now I'll write another predefined class file reader. I'll create an object for file reader now. Okay, fr file reader fr is equal to new file reader like this. Okay, hover the mouse on this file reader and select this import file reader from the same java.io package itself. Hover the mouse and import it. We have imported even file reader also. Now guys, it says that the constructor file reader is undefined. That means you have to provide something into the constructor that is nothing but this file. Okay. Now you'll get another error guys, unhandled exception type. Okay. So we are getting the checked exception. Checked exceptions will be found during the compile time itself. Okay. You don't have to run this program. Before running the program, during the compile time itself, the compiler will identify the possibility of the checked exceptions. Okay. So here our compiler is not saying that you are going to get this particular checked exception for sure. Okay, what is kind of checked exception in this case? File not found exception. Okay, here compiler is not saying that you are definitely going to get file not found exception, but instead the compiler is saying that you may or may not get this file not found exception. And so if as there is a possibility of getting this file not found exception from this particular statement, compiler is suggesting you to handle it. Okay, to handle it or ignore it. Compiler is giving you two options guys. Either it's asking you to handle it or ignore it. So if you want to handle it, what you have to do guys? You have to use this surround with try catch block, right? Try catch block. You can select this option if you want. Surround with try catch block. You see, try catch block, this particular statement which has a possibility of throwing the checked exception, that is file not found exception, is now being surrounded by try catch block. Okay, like this you can handle, or else Control Z. Okay, just press Control Z. It will go back. Or else there is another possibility coming here from this error, compiler error, that is add throws declaration. Okay, when you select this option, like this will happen. Throws file not found exception will be added here. Okay, so import this file not found exception from the same java.io package. Okay, fine, done. You see, the compiler error has been ignored. Here in this case, we are not handling this exception. Okay, there is a possibility of file not found exception being, okay, there is a possibility of getting the file not found exception during while running this program. Okay, that's the reason the compiler is hinting you to handle this. If you don't, if you are very confident that this particular path will not change and the file actually exists at this particular actually exists at this particular location. Okay, if you are very sure of that, okay, then you can use this throws file not found exception. Okay, throws file, this will ignore guys, this will ignore the exception. Okay, instead of handling, we are ignoring the exception. So if I run this program, okay, right click run as Java application, this will run. Okay, this will run without any problems. There is no code here to be printing. I will write something like this: system.out.println. Okay, ending print statement, something like that. I'm just writing something. Okay, ending of the program or something you can write. So right click run as Java application. Since there is no exception here, since there is no exception from this file reader step, we got this ending print statement got printed here without any problem. What if this throws, using this throws keyword, we are ignoring this exception guys. Okay, if there is a possibility of getting a checked exception here, and if in case we get an, we are simply saying that ignore such kind of exception. Okay, ignore it. You are telling the compiler to ignore it, even though compiler is hinting you, you are muting the compiler. Okay, words. What if really whatever the compiler is expecting is happening? For example, instead of ABC, if I give XYZ here, okay, so this xyz.txt file is not actually there in this location. Okay, in this location folder, there is no xyz text file. So this path is wrong now, right? This file doesn't exist. In such kind of cases, this statement is going to give a kind of checked exception saying file not found exception. But here compiler is muted now. Okay, we have muted the mouth of the compiler by saying throws file not found exception. We have ignored the exception. Okay, we have ignored the indication by the compiler using this throws keyword. So this throws file not found exception has to be used with the method name. Okay, this is a method, right? Along with this method, before this starting curly brace starts, we have to write this statement. Okay, after this string of args, we have to write throw file not found exception. Okay, now guys, coming to the context, here xyz.txt is not at this particular file location. Okay, this path doesn't have this xyz.txt file. This file doesn't exist, and this is going to give an exception, and we have ignored the exception. Okay, that is going to come. So what will happen, guys, when I run this program, the exception will be thrown. Okay, since this particular file is not there here, the file not found exception will be thrown here. Okay, and your program will stop abruptly. Okay, the program will stop there itself, guys. You see, you will get an exception and program will terminate. This statement will not be printed because you got an exception and you didn't handle it. Okay, you didn't handle the checked exception. If you have to handle the checked exception, you have to use what, guys? You have to surround this particular statement with try catch block. Then only it will be handled. But here you have ignored the exception. Okay, so that's the thing, guys. If you want to ignore the exception, whatever the compiler error that is coming, if you want to ignore that, you have to use throws file not found exception. So this will work in case when you have provided the proper path. Okay, like this, right click, run as a, this will work in this case. But if the provided file path is not available, then you are going to get an exception in case of ignoring the exception. But in case of handling the exception, okay, instead of ignoring, if you are handling the exception, whatever it is, if the file exists or doesn't exist, the program will not terminate. You will not get an exception in the output. The exception will be handled. Okay, the exception will be handled. So this is how, guys, we can work with checked exceptions. Either we can handle the exception that is probable to come, or we can ignore the exception that is probable to come. Okay, it's up to you, up to us. Fine. So guys, this is all about the handling of checked exceptions or ignoring the checked exceptions. Handling, and you can simply say handling and ignoring checked exceptions. Okay, handling and ignoring, the ways to handle and ignoring the checked exception. For handling the checked exception, what we have to use, guys? We have to use try catch block. For ignoring the checked exceptions, what we have to use? We have to use throws. Okay, we have to use throws. Fine. So guys, that's all about the handling and ignoring the checked exceptions. So in the next video session, I'll explain more about these throws. Okay, whatever the keyword I have used for ignoring the checked exceptions, that is throws keyword. I'll be explaining about this throws keyword in detail in the upcoming video or in the next video. Okay, so that's it, guys. See you in the next video session. Thank you. Bye.